Welcome to the Complete Python Guide. I am very happy to see you on board. And let's start this course with the explanation who is this course for. This course is for those who want to start learning programming, because Python is the most simple programming language to start with, and it is very suitable for beginners. Also, this course is for those who want to do data processing and analysis, or for example machine learning or artificial intelligence, because Python is a very good choice for such kind of tasks. Also, this course is for those who want to plan and create web applications using Python, because there are several very nice frameworks and libraries for Python which allow to create full-featured web applications. And the most popular one is Django. Also, Python is a very good choice when you want to write some small programs or microprograms which help you to perform some small tasks on your local computer. For instance, you could very easily write a Python program which processes Excel files or CSV files, or perform, for example, reformatting of the video files or compressing of the photos. Python is a very good choice for such kind of tasks. And also this course will be very good for those who already have basic Python knowledge and want to deepen it. Because in this course I will not only explain how to use Python, but also I will explain how Python works under the hood, and what happens when you perform this or that operation using Python. And how to take this course? What is the approach which you should follow in order to get best results after this course? First, write code yourself. Don't just watch how I code and try to remember what I'm doing. The best way to learn is to code yourself, because the best knowledge is hand-gained knowledge. The more times you repeat specific task yourself and type specific code, the better you will memorize it and remember afterwards. Also, I recommend to you not just to run a specific block of code, but also modify it and decide yourself how you should tweak the code in order to get other results. And you should do that until you get completely full understanding of what is happening when you write and execute specific block of code. Also, I recommend to you to use Google search or, for instance, different chatbots in order to find answers to your questions. Because it's highly likely that you will stuck and you will get errors. This happens to all software developers in the world, but don't give up. Simply take information from a specific error and try to find solution to your problem. Try to find how to fix this error. And it is very likely that other people in the world got the same error before, and they already posted an answer and explanation how you should fix this error. But if you find someone else's block of code which solves specific problem, don't just copy-paste it and execute it. Just take ideas from that block of code and afterwards write solution yourself. Also, I recommend to use Notion or any other text editor which allows you to store information in structured format. And key moments from the videos, from the code examples, I recommend to you to save using Notion. And in such a way you will structure your knowledge, and also you will be able quicker remember what you learned few months ago, if you want to recap your knowledge in the future. Also, you could make handmade notes if you want to do so, but I personally use always Notion, and I make notes in this program. That's my recommendations how to take this course in order to get maximum benefits from it and retain your knowledge for longer period of time. And Here you see how not to take this course. If you want to take this course drinking a beer or talking with your friends or playing a game, this is not a course for you. In such a way, you will learn nothing. That's why if you want to get maximum results, I ask you for attention and concentration. Please put aside your phones, tablets and other devices and concentrate on the course. And dedicate to education as much time as possible. Alright, let's get started with the course and I wish you all the best and good luck. I hope you will learn much with this course. Hey guys, this course is part of the big Python course, which is more than 50 hours long. Link to the complete course you'll find in the description under this video. Now let's discuss where we will execute Python code. Basically, there are many options where you could do that. There are many online editors where you could create and run Python applications, and also it is possible to do that locally on your computer. And I recommend to you to do everything locally on your computers. In such a way, you will have more control over entire process, and also you'll learn better. And first, in order to create and run any Python applications locally on your computer, you have to verify whether Python is installed on your computer or not. And you could verify that in any terminal application. On Windows it is PowerShell, it is default terminal application. On Mac you could use, for example, Terminal. Also you could use other terminal applications like sh or bash, for instance, if you're a Linux user. And please enter this command, and if a Python version is not displayed, you have to install Python. And you could download Python installer from official website, which is python.org/downloads. And here it is possible to download Python installer for different operating systems such as Windows, Mac OS or Linux-like operating systems. And if you're a Windows user, during installation of the Python, please ensure that you check checkbox Add Python exe2 path. And using this checkbox, you will ensure that Python executable will be available for use in the terminal, in the command line interface. That's why please ensure that you check this checkbox during installation if you are a Windows user. And now let's discuss what else you'll require in order to create and run Python applications locally on your computers. The most popular choice is Integrated Development Environment, shortly IDE, which is called PyCharm. There are two versions, Community and Professional, and Community Edition is free for use and it has a lot of features available for use out of the box. And this IDE is very easy to use and it is very suitable especially for beginners. But also there are other choices for creation of the Python applications, and for instance, you are able to use such code editor as Visual Studio Code. There are of course many other code editors available like Atom, Sublime Text and many others. And of course, there are many online editors, and you are able to create Python applications remotely on remote servers using your web browser. But such free code editor as Visual Studio Code, which has bunch of different extensions, allows you to create not just Python applications, but also applications in other programming languages like JavaScript, Java and many others. And if you use Visual Studio Code, it's good to add such extension as Code Runner, which allows you to run any applications really fast, using just single shortcut. And in this course, we will use IDE PyCharm, but of course you are free to use any other IDE of your choice, or you are able to use code editor like Visual Studio Code or any other. That's up to you. Also, it's possible to use Jupyter Notebook, and it is a tool which allows you to run different blocks of Python code, And you could use Jupyter either online or you could install application locally on your computer. For example, here you see that I created a dictionary, here it is, then I printed it to the terminal, and here I immediately see output, and also I printed result of the dir function call, and here I see bunch of different attributes. And that is possible inside of the Jupyter notebook. And it is also a very nice tool in order to play with Python and in order to see how Python executes different blocks of commands. So, that's our primary tools which we will use in this course. But also there are plenty of other code editors, and also it's possible to write Python applications online. So, choose any tool which you will like. That's up to you. But I recommend to you to use PyCharm or Visual Studio Code. Also, as a playground, you could use Jupyter Notebook. Now I'll demonstrate to you how to install Python on your computer. But before doing that, let's verify whether Python is already installed or not, and if it is installed, probably there is no need to install it again. In order to verify whether Python is present on the computer, you could go to the terminal, I open up iterm2, and if you are a Windows user, please use PowerShell or any other terminal application. If you are a Windows user, please enter here Python ---- version. If you are a Mac user, please enter Python 3 ---- version. Because historically on Macs there are two different versions of Python installed, Python 2 and Python 3. Therefore, if you are a Mac user, please verify using this command. If you are a Windows user, use just Python. And here I see that Python is already available on this computer and its version is 3.11.0. But anyways, I'll install it over again, and here on the python.org website I'll go to download section, and here click on the button download Python. On this page your operating system will be determined automatically, and Python is available for Windows, for Linux Unix, for Mac OS and for other operating systems. So let's go ahead and download Python. Installer was downloaded and let me open it up. Here I'll click Continue, 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 Agree, Install. And here I'll enter my password, Install software. And finally Python was successfully installed. Let me close this folder. And here I see congratulations, Python 3.11.3 in my case was installed. If you installed more recent version, that's pretty fine. All contents of this course will work on newer versions. Alright, let's close this window, move to trash, and now let's go back to terminal. And here in the terminal I'll enter same command again, Python 3 ---- version, and I see updated version. It is the last one available at this moment of time, 3.11.3. And now we are good to go, and next let's install PyCharm, which we will utilize as IDE for this course. Before going on with installation of the PyCharm, I recommend to first try Python Interactive Interpreter, which is available directly in any terminal. We already installed Python and we could launch Interactive Interpreter using simply Python command on Windows or Python 3 on Mac. We could clear terminal. On Mac it is combination of keys Command K, on Windows type CLS if you are using PowerShell. And here simply enter Python on Windows or Python 3 on Mac. And we launched Interactive Interpreter. And here I see version of the Python installed on my computer. Also, further on this line I see C-lang. And that means that Python interpreter itself is written using C programming language. Next I see some commands which I could basically execute directly in the interpreter, such as help, copyright, credits and license. Let's try copyright, for example. I could write part of the word and press tab in order to autocomplete it, and notice that pair of round braces were added here, and that means that copyright is basically a function, and function has to be called in order to get some results. Let's press enter, and here I see some text output. That's copyright information related to Python software. Also, we could try, for example, credits, and also let's call this function, and here I see another text information with some thanks to CWI, CNRI, and so on, companies which participated in Python development. And here in this interactive interpreter, we could basically send some commands to Python, and for example, I could write here, for example, 2 plus 3. Press enter and I get result of this expression, because we just entered an expression, and result is 5. Let's enter name, I'll enter mine in single quotes, and if I press enter, I'll get same string back from the interpreter. But if I enter Bogdan without quotes, like that, I'll get name error. Name Bogdan is not defined. Because now Python treats this input as variable name, and there is no such variable which we created before. That's why we got name error. Also, we could use here built-in print function, write here print, call the function, and here write Bogdan in quotes. You could write your name. Press enter, and I see string Bogdan here in the output. That's interactive interpreter, and here inside you could try Python functionality. Alright, let's exit from it using exit function, don't forget to call it like that, and press enter. And let's clear terminal. Now let's install Python interactive development environment, shortly IDE, which is called PyCharm. It is the most popular IDE for Python applications in the world. Please navigate to this URL jetbrains.com/pycharm/download and select a version of the PyCharm which is called Community. It is free and it is available for different operating systems, for Windows, macOS and Linux. I'll select the macOS version and click here Download. Installation file was downloaded, let's go ahead and install PyCharm. Here I'll simply drag PyCharm Community Edition to Applications folder, copying files, and now I'll open up PyCharm. And if you never used PyCharm on your computer before, you'll see Welcome to PyCharm window. And here let's create a new project by clicking on the plus icon. New project will be created in specific location, and here is path to location. And in my case, Python projects will be located in the PyCharm projects folder in my user directory. And the PyCharm suggests name for this new project as Python project. If you want, you could modify this name to, for example, Python. Next, you see information about Python interpreter, and the new environment will be created using virtual env. There are other options available, but let's keep for now just virtual env. We will talk about virtual environments later in this course. Also, please ensure that base interpreter is set to the Python version which you just installed. In my case, it is version 3.11. If version is chosen incorrectly, please choose the last one in the drop-down list. Alright, now we are good to go, and now let's create new project. Creating virtual environment, and project was successfully created. Let's have a look at the project files. Here on the left, please select project. And you'll see Python folder, which is name of our project in the PyCharm, and in this folder there is subfolder called venv. This folder contains all files related to Python virtual environment. And let's in the Python folder create new file. Right button click New File. And let's name this file simply main.py. Py is extension for all Python files. Press enter, and new file was just created. And here editor for this file was automatically opened. Also, except this main.py editor, it is also possible to open terminal by clicking on the button on the bottom. And terminal was opened. Now there is editor, next to it there is project files navigator, and at the bottom there is terminal. And now let's increase font size to make text everywhere more readable. And for that you could use key combination. On Windows it is Alt-Shift-Dot, on Mac it is Ctrl-Shift-Dot. Let's press several times. And font size was increased everywhere except project browser for files and folders. But we could hide this left section here. Also, PyCharm has many other settings which are available under PyCharm settings. And here let me enable new UI by checking this checkbox, enable new UI. Probably at the moment when you watch this course, this new UI will become default UI. So I'll select new UI and press OK. And let's restart PyCharm. Restarting. Here is new UI and it has a big window dedicated just to file which you are editing. And also it is possible to open terminal by clicking on this icon in the left section. And now let's place cursor in the main.py file. And again, let's increase font size by pressing key combination Alt-Shift-Dot on Windows or Ctrl-Shift-Dot on Mac. And let's increase font size like this. And now let's print something to the terminal and write here print, and here in the parentheses will be Bogdan. Let's run this code by clicking on this icon run main.py, or you could use key combination which is shown here. On Mac it is Ctrl-R. Let's run the code, and here in the output below I see Bogdan. That's how you created the very first project in the PyCharm, and that's your very first Python application. We just created the very first Python application in the PyCharm, and now let's continue with this example and get familiar with other features of the PyCharm. First of all, I would like to say that when you run each program, Python basically executes specific file. And we created file with name main.py, here is this name, and here on the first line in the output I see path to the Python interpreter. In your case, this path could be of course different. And we basically use Python interpreter, which is located in the venv folder in our Python project. And if we expand our project, you'll see here subfolder venv. Here is subfolder bin, and here inside you could find Python interpreter. Here it is. That's that interpreter which is used in order to launch our Python application. And after this path, there is also a path to the file which we basically execute. And here again I see file name main.py, which is located in the Python folder, which is our project. Also, when we execute specific file and, for example, see results here in the output, then we see such message as process finished with exit code 0. And exit code means how actually application ends its job. And if exit code is 0, it means that application was executed successfully and there were no errors. If exit code is not 0, for example 1, 2 or other numbers, that means that the application basically crashed and there was specific issue with application. For example, if I remove this closing paren and then run code again, I could do that by pressing on this icon or by using key combination Ctrl-R on Mac, I'll see another output. Again, I see path to the interpreter, and same as before I see path to the file which was executed, but afterwards I see syntax error. And basically in this output I see specific error and it is very easy to fix that error. Opening paren was never closed. That's specific error in this example. And also below I see that process finished with exit code 1. Non-zero code again means that there was an error. And if I fix the error and execute code again, I will see the result same as before, and exit code is 0. It is also possible to hide those lines, this one and this one, but they will still occupy some place in the output, and now let me demonstrate to you how to do that. Let me copy this path, for example, including Python interpreter. You could copy your path, then go to Settings, and here expand Editor, go to General, expand General, and go to Console. And here it is possible to add fold console lines that contain. Let's press plus here and paste here what we just copied. In your case, please paste your path to the Python interpreter, and let's press OK here. Let's hit OK here, and also let me copy this line, including exit code 0. Again, go to Settings, to the same place, Editor, General, Console, and here let's add one more line. Hit plus here and paste what we just copied. Process finished with exit code 0. OK. And press OK here. And if I execute code now, Ctrl-R, I see that those two lines were basically hidden. But as I mentioned, they still occupy a place here in the output. And it is possible to click on internal line and you'll basically see same line as before. Here the same. So if you want to hide those two lines and show basically only output of the program, you could keep settings like that. But I'll remove those settings in order to avoid any confusion for students which may join the course a bit later in later lectures. So I'll remove those settings and press OK here and execute code again. Also, I would like to mention that here in this output window you'll see specific string, for example, or number only in case you use, for example, built-in print function. If you simply write 10 here and execute the code, you will not see here 10 in the output. In order to see output, you have to add print, and then add here 10 as an argument. 10 is integer in this example. Let's execute code, and now I see 10 here in the output. Also, it's possible to output results of any other expressions, for example, 2 plus 3. Also, let's print, for example, true, which is a Boolean value. Let's run the code again, and I see here Bogdan, 10, 5, which is a result of this expression, and true. Also notice that if I hover mouse over the last closing paren, I see that there is no new line at end of the file. And this is basically PEP recommendation. We will talk about PEP a bit later in this course. But basically PEP is just a document which has some set of recommendations regarding styling of the Python files. And according to PEP 8, you have to add new line at the end of the file. And if I add a new line at the end of the file, this notification basically disappears. But result, when we execute this code, remains unmodified. I see same outputs as before here. That's it about this interactive development environment, and in the PyCharm you could work with different files in the project simultaneously. Also, you have access to the terminal, which you could find here. And if you want, you could also execute Python programs directly in the terminal by using Python command and then name of the file, main.py. And I'll get same results. That's outputs of calls to the built-in print function. So if you want, you could execute Python files directly like that in the terminal, or you could use run. And I'll use mostly run and specifically key combination Ctrl-R on Mac. That was an overview of the PyCharm interactive development environment, and this IDE is the most popular full-featured IDE for Python applications. If you want to learn how to create web applications using Django Web Development Python framework, I welcome you to the complete Python course, which is more than 50 hours long. Now let's start with the most important thing in Python. And it is object or objects. Why? Because Python is object-oriented programming language. And that means that the main idea in Python is following. All entities in Python are objects. Even strings, integers, or booleans, everything is an object. Functions are also objects. And the object is always an instance of specific class. It means that there are a bunch of built-in classes in Python, such as str for strings, such as int for integers, and so on. What is class? Class is a template or prototype for creation of the objects. And from the single class, you could create as many objects as you like. One class, and you could create many objects based on that class. But of course, such objects will be different and independent from each other. And you could perform different operations with different objects. And each such object is called instance of specific class. Also, each object has attributes, and you could access attributes anytime you want. If an object has specific attribute which value is a function, then such attribute is called method. You can call any function, and same you can do with methods. You could call any method. Also, I would like to mention that each object could have own attributes and also inherited attributes. And in most cases, objects in Python inherit, for example, methods from the class, which was used for creation of specific object. So please keep in mind that Python is an object-oriented programming language. And every entity in Python is an object. Strings, integers, float numbers are all objects in Python. And all of them are instances of specific class. And there are many built-in classes in Python. As I already mentioned, Python has a lot of built-in classes for creation of different objects. And also there are data types. And now let's talk about main data types in Python. And first, main data type is string. And each string object is an instance of the built-in class, which is called str, all lowercase letters. So when you create a string, for example this one, Python creates a brand new object, which is an instance of the str built-in class. And this string object has many attributes, and most of them are inherited from the str built-in class. These are strings in Python, and you could use either double quotes or single quotes, up to you. But I personally prefer to use single quotes for short strings, for single word strings like in this example, and for long strings which contain multiple words, I prefer to use double quotes. But that's again up to you. Next main type in Python is integer. And example of integer is 10. Negative 10 or 0 are also integers. And each integer is an instance of the built-in int class. And of course, each integer is an object. Next type is Boolean, and corresponding built-in class is called bool. And there are just two possible values, true or false. And first letter is uppercase. Next type in Python is list, and list is sequence of elements. And list could be modified. You could add new elements to the list. You could remove elements from the list. You could remove specific element by its index, because lists are ordered sequences of elements. And order of the elements here in the list does matter. Each list in Python is an instance of the built-in list class. Also, there are dictionaries in Python, and here is an example of dictionary. Dictionary is basically a set of key-value pairs. Here is first key-value pair, and here is second key-value pair. And those curly braces here tell Python that here is a dictionary. Each dictionary is an instance of the built-in dict class. And you must use either single quotes or double quotes near the names of the keys in the dictionary. And it's a common practice to use single quotes for this purpose. And values for the keys in the dictionary could be of different value types: integers, strings, booleans, lists, other dictionaries, and so on. There are no limitations about that. Also, dictionaries are unordered sequences of elements. Order of the key-value pairs in the dictionary doesn't matter. You can change order of those key-value pairs and the result will be the same. Dictionary will be the same. Also, it's important to mention that you could modify each dictionary. You could add new keys, you could remove keys. You could modify values of the keys. For example, you could change this value, and so on. It means that dictionaries and lists in Python are mutable. You could mutate objects in Python if they are dictionary or list. But you cannot mutate, for example, strings, booleans, or integers. But all those data types are actually types of specific objects. And each of those values is an object which is an instance of specific built-in class. And there are such built-in classes as str, int, bool, list, dict, and there are few other data types in Python, such as tuples, sets, and we will talk about them later in this course. But here you see main data types in Python. Now let's together on practice examine main types in the Python, which are strings, integers, logical values, lists, and dictionaries. Let me remove all those print function calls, and also let's hide this run output, and in order to hide it you could click on this button, or you could use key combination which is displayed here near this button. On the Mac it is Command 4. Like that. And let's start with strings, and let's call built-in print function. Those parentheses here mean that we actually call a function, and in such case function will be executed and produce some results. And here in the parentheses let's type a string, and you could use either single quotes or double quotes. Here in single quotes let's write hello Python. And also you could do the same using double quotes, hello Python. And if we execute such code, we'll see same outputs here. So, with strings you could use either single quotes or double quotes. I personally prefer to use double quotes for long strings, for example like this one, and single quotes for short single word strings. For example, if I use just my name Bogdan or any other single word string, I usually use single quotes. But please be consistent across all files in your Python application. Don't mix single quotes and double quotes. Next is integer, and here let's again call print function, and here type any integer, for example 100. Negative numbers like -20 are also integers. Let's execute this code. And here we see 100 and -20 in the output. Alright, that's where integers, and now let's have a look at Boolean values, and there are just two Boolean values, true and false. Let's execute code now, and here we see true and false. Please notice that true and false start with capital letters T and F. If instead of capital case T you'll write lowercase t and execute code, you'll basically get an error. Name error specifically. Name true is not defined. Did you mean true? Because Python interprets this name here as name of the variable. But before we have not created such a variable. That's why Python produces a name error. So Boolean values start with capital letters, true and false. Alright, that's our Boolean values, and now let's have a look at the list. Let's print empty list. In order to create empty list, you have to use simply pair of square brackets. And if we run such code, we'll see empty list in the output. It is possible to create non-empty list using several elements in the list, like that, 1, 2, 3, and such list will have 3 elements. If we run this code, we'll see non-empty list which has 3 different elements. Next, let's create a dictionary, and let's print first empty dictionary, and if you use simply a pair of curly braces, it means that you actually create an empty dictionary. And if we run our program, we'll see empty dictionary here in the output. Let's print non-empty dictionary, print, and here will be dictionary with one key, and keys have to be embedded into single quotes or double quotes. It's a convention to use single quotes for key names. For example, key name is name, and after colon comes value, and value will be, for example, Bogdan. Let's execute this program again, and here I see dictionary which has one key. Name of the key is simply name and value is string Bogdan. It is also possible to split dictionary into multiple lines. Let's copy this line and paste below, and here let's split this dictionary into several lines, like this. It's allowed in Python, it's not a mistake. Let's run code again, and in the output I see 2 exactly the same dictionaries, but in the output we see them on the single line. Also, it's possible to add several keys in the dictionary, and if you split dictionary into multiple lines, you have to add simply comma after each line and add, for example, here another key, and key will be isinstructor, for example, and value will be true. It's Boolean value. So basically in the dictionary you could use values of different types: strings, boolean, integer, float, list, other dictionary, and so on and so forth. Let's execute code now, and here I see dictionary with 2 keys. Key names are name and isinstructor. And as I mentioned before, it is possible to use double quotes instead of single quotes, like that. And you could use double quotes here as well. Let's run the code, and I see no mistake. But in the output, double quotes were replaced with single quotes. But it's a convention again to use single quotes. So let's get back to single quotes here in this dictionary. And we basically covered most commonly utilized types in Python, and they are strings. You could use either single quotes or double quotes, integers. You could also use negative numbers like -20, 0 is also an integer. Here are 2 Boolean values, true or false. Here is empty list. Here is list with 3 different elements. And by the way, you could use values of different types as elements in the list. And here is dictionary. Here is empty dictionary. Here is dictionary with 1 key. And here is dictionary with 2 keys. And it is possible to split dictionary into multiple lines of code in order to make a dictionary more readable. That's all about most commonly used types in Python. Now let's talk about built-in functions in Python. Python has many built-in functions available for you out of the box. And one of such built-in functions is print function. And in order to perform some operations by function, you have to call a function. And here we use round braces in order to call a function. And when you call a function, usually you have to pass an argument. And in this example, argument is a string. And because it is a long string, I used double quotes. So we call built-in print function and pass to it an argument, which is a string in this example. And what this built-in function does, it simply prints result of this expression, hello Python, to the terminal. And you'll see hello Python in the output of your program. You could also create your own functions in Python, and that's how you could do that. First comes reserved keyword def, definition. Then comes name of the function, in this example my_fn. It's a common convention to use snake case notation when you name variables in Python. All lowercase letters with underscores between different words. Then function has a body, and in this example there are 3 lines of code in the body of this function. And also there are parameters of the function. Parameters are located after name of the function in round braces here. And function might have parameters, but might not have parameters. In this example, there are 2 parameters in this function, a and b. Consider parameters as variables, which are available only inside of the function. Also, in this example, function returns result. Return C. Return is a statement, and it allows you to return a specific result from the function. And this result could be used, for example, for other operations. You could assign result of the function call to the variable, or you could pass result of the function call in the call to another function. But of course, when you create a function in Python, it is not executed automatically. You have to call a function. And of course, you could call the same function multiple times. And if function has parameters, you could call function with different arguments. And in such case, function will be executed differently and return different results, depending on the input arguments. So, to summarize, function consists of name, optional parameters, function body, and function could also return a result if you use return statement. If you don't use return statement, function will anyway return result, which is none. None is a value of none type in Python. Let's have a look at other built-in functions in Python. And we already discussed print function. And also there are a bunch of other built-in functions. For example, using type, you could get name of the class which was used for creation of specific object. Using ID, you could get location of specific object in memory. It's a number. Using len, you could find quantity of the elements in particular sequence, for example, in the list. Or you could find length of specific string in Python. Sum allows you to find sum of all elements in particular sequence, for example, in the list. Using input, you could ask user to enter some text input in the terminal when you run your application. And then you could assign result of the input function call to the variable, and then perform some operations with text inputs which you got from the user. There are also some mathematical built-in functions such as round, min, max, And using round, you could round any number to nearest integer. And using min and max, you could find minimum and maximum value among different elements in the sequence, for example, in the list. And also, using such built-in functions as int, str, bool, list, dict, you could create instances of specific built-in classes. For example, calling str function, you could create new string object. Using int function, you could create new integer object, which will hold value of type integer. And also, such built-in functions are usually used in order to convert one value to another. And you could convert, for example, integer to string, or string to integer, or string to boolean, and so on. Let's now examine what we'll see if we just print. Here we pass name of the built-in function in the print function call. And in this case, you'll see that print is just a built-in function. And you could perform similar operation with other built-in functions in Python. And in all cases, you'll see that those functions are built-in functions. And as we just discussed, Python offers you a lot of built-in functions to simplify your Python applications. Because main idea in Python is simplicity. And your Python applications should be Pythonic. Very easy, very clear, and powerful. That's the idea of the Python. And let's have a look at the next built-in function, which is input. And using input, you could prompt user to enter some text in the terminal. And here we ask user to enter his name. And that's the prompt which user will see in the terminal. Then we assign result of the function call to the variable, which is name, and print name here to the terminal. And when you run such application, it will stop and prompt you to enter your name. You enter name using keyboard, then press enter, and after that, input function assigns result which you entered to this variable. And afterwards, in this program, this value is printed to the terminal. That's built-in function input. But please note that anytime when you enter any text after prompt, this text is interpreted as string. It means that input function always returns a string. So please keep that in mind. Let's have a look at another built-in function which is called dir. And this function gives you a list of the names of all attributes which are available for particular object. This object in this example is string, and it is an instance of the built-in str class. And notice how many different attributes this object has. There are different attributes like join, lower, right index, split, and so on. And most of those attributes are inherited attributes, and they are inherited by this object from the string class. And most of them are methods. And for example, you could call a method which is called capitalize, which allows you to capitalize each string. It makes first letter of each word in the string capital case. Also, you could count, for example, quantity of specific character in the string. And for that, you could use count method. That's dir function, and it gives you list of names of all attributes available for particular object. And you could use dir function with any object you like, not just string. And also, you could access any attribute of particular object using dot notation. And you have to put dot after the name of particular object. And here we create a string, here it is, and assign it to the variable name. It is an object, which is instance of the built-in str class. And then we can call, for example, upper method, which is inherited from the str built-in class. Because it's a method, we have to add here a pair of round braces. We need to call this method. And in such case, this method will return brand new string. All characters from this string will be in uppercase. That's what this particular method does. And it is a method, because it performs some operations when we call it. In similar way, you could call other methods which are available for particular object. But please keep in mind that you have to use dot notation in order to access any specific attribute of the object. Let's now summarize. Python has a lot of built-in functions, such as print, input, and others. Also, when you create an object, this object will have multiple attributes. Most of them are inherited. And you could access any attribute of particular object using dot notation. Also, you could find list of the names of all available attributes for particular object. And for that, you could use built-in dir function. Also, there are many other built-in functions which simplify creation of the Python applications. Now let's have a look on practice on functions in Python. Because function is a building block of any program in any programming language. And understanding what is function and how you could call a function gives you an ability to use functions efficiently in your programs. So let's start simple and let's create a function, and functions in Python are created using def keyword. And next comes name of the function. And let's name this function simply hello. Then mandatory, you have to add pair of round braces, like that. And after round braces comes colon. And if you press enter after colon, you'll go into the function body. And notice that ident, which consists of 4 spaces, was added automatically. And here in the function body you could perform different actions. For example, let's simply call built-in print function, which we already used before. And if you want to call a function, you have to add pair of round braces, like that. So similarly, as you add the pair of round braces here after the function name, you have to also add the pair of round braces when you call any function. Print is again a function. And if you hover mouse over print, you'll basically see that print is a function. Here is also def keyword. And here is description of this function. You might see what this function does. So let's call print function here. Again, pair of round braces, it is mandatory. And here we could pass, for example, a string. And let's, in double quotes or in single quotes as you want, let's type hello there. And it means that here we call built-in print function, and we do that inside of the hello function. And let's try to run this code. Let's run this code. And here in the output I see nothing actually. Because in this example we actually created a function which has name hello, and we don't call this function. And if you don't call this function, it is not executed. Therefore, we don't call this print function if we don't call hello function. And before calling this hello function, I would like to mention that hello is basically a variable name. And such variable holds actually a function in this particular program. Now let's call hello function. If we simply type hello here and run the code, nothing happens. Because we simply access variable hello and do nothing with it. If you want to call a function, you have to add pair of round braces, like that. And here you see a hint that this function doesn't have any parameters. Because here in the function declaration, this block is empty, so there is nothing in the round braces. It means that there are no parameters in the function. Because that's that place where you have to specify parameters of the function. So let's simply call hello function like that, and let's run the code. And now, here in the output, I see hello there.
It means that now function was actually executed, and therefore Python executed this block of code, and we got hello there in the output. We could call same function again and again. If I run the code now, I'll get hello there twice in the output, which means that this particular function might be called as many times as you want. Also, inside of the function body, you could perform multiple actions, not just call print function once. Let's add, for example, one more print function call, and here I'll type hi there. Let's run the code, and now I get such outputs from each function call. This is from first function call on the line 6, and this one from the second function call on the line 7. But as we just saw in this particular function, each time when we execute it, we get the same result. We get hello there and hi there in the output. But it is possible to impact how function actually executes its code by using parameters of the function. And that's the place where you have to put parameters. And function might have no parameters like in this example. Function could have one parameter or multiple parameters. And let's add a single parameter here in this function, and let's give it a name, simply name. And let's temporarily remove function calls from here. So now this function has single parameter, and you could consider parameter simply as a variable which is available inside of the function. So name is a variable which is available here in the function block. And I could simply print name like that, and in such a way I will access a value of this particular variable. And such special variables inside of the functions are called parameters. And parameters get their values when you actually call a function. And if I call function here again and add round braces, I will see hint that function now expects from us name. And we could, for example, pass here a string. I'll type here, for example, Bogdan. And this is called argument. So when you call a function, you pass some arguments in the function call. And then this argument will be actually a value for specific parameter. Because this function has just one parameter, which is name, this parameter will be assigned a value Bogdan. And now if we access value of the parameter name inside of the function, you'll of course get such string in the output. Let's run the code, and here I see Bogdan. And afterwards, same as before, I see hello there and hi there. And now we are able to call this function with different arguments. For example, here I could write hello and pass here another string, for example, Alice. And if I run the code, I'll get here Alice. And now outputs which are produced in different function calls differ, because now we impact how function actually works inside by using different arguments. And please also notice that such variable as name is not accessible outside of the function scope. It is available only inside of the function. And if I try to, for example, access variable name outside of the function and run the code, I get name error. Name is not defined. So, again, please consider parameters as local variables which are available only inside of the function. That's how parameters work. And also it's possible to have multiple parameters. And let's for that purpose create one more function. And we are done with this example. So let's create a function and let's call it add numbers. And now inside of this function there will be two parameters. And let's call them a and b. Of course, it's not recommended to use short names for parameters or variables, but in this example let's simply use a and b. And now in this function we could perform some actions with those two parameters. And let's assume that values of those two parameters should be integers. And inside of this add numbers function, we want to add those two integers, and then print result to the terminal. So we could create here a variable and we could call it, for example, sum. And then using assignment operator, we could assign to this variable sum of a and b. And of course, a and b are available here because this line of code belongs to the function body. And in the function, we have access to values of those two parameters. And also inside of the function, we create now new variable, which is called sum. And now, for example, using print function, we could print value of the sum variable to the terminal. And we again do that inside of the function body. Here are those idents. And now let's call this function add numbers. And if I call this function without arguments, like that, and run the code, I get type error. Add numbers missing two required positional arguments, a and b. Which means that if function has parameters, like here in Python, you must call this function with two arguments. For example, if I call add numbers function only with one argument, for example 5, and run the code, I get type error again. Now I'm missing one required positional argument, which is b. That's why let's add also second argument here in this function call, for example 2, and run the code. And now I get no errors and I get result which is 7. That's a result of this print function call. Now sum has actually a value which is sum of two parameters, a and b. A gets value 5 and b gets value 2. And a plus b gives us 7. And 7 is assigned to new variable sum, which is defined here on this line 2 inside of the function. That's how you could add parameters in the function. And in this particular example, there are two parameters, a and b. And now we must call this add numbers function with two arguments, for example 5 and 2. And definitely you could call this function again and again. And here could be, for example, 150. Let's call again add numbers. Here will be, for example, 8 and let's say float number 10.5. Let's run the code and I get correct results, which are sums of corresponding pairs of numbers. And here we have just one block of code inside of the function, and this block of code gets executed as many times as we call actual function. And here are three different function calls. That's it for this example where we added two parameters, and now we call this particular function with two arguments. So here are two arguments, here are two arguments, and here are two arguments. And please keep in mind that when you call a function, you specify arguments. And when you define a function, you specify parameters. And parameters are variables which are available only inside of the function body. In the next example, let's explore how you could return specific value from the function using return statement. Let's create a function and let's call it multiply numbers. And this function will have two parameters, similar to previous function. And now inside of this function, we want to multiply those two parameters, a by b. And let's create a variable and let's call it result and assign to result a multiplied by b. Here we use multiplication operator, which is simply a star. And let's assume that we don't want, for example, to print result to the terminal here inside of the function, and we want to return such result from the function and use this result somewhere later in the code. For this purpose, there is return keyword, and it is a statement in Python. It performs an action. And you could return, for example, result here. So here we create a variable result and assign to it result of multiplication of a by b, and then using return keyword, we return result from the multiply numbers function. And after this return statement, function stops its further execution. And we will prove that a bit later. For now, let's try to call multiply numbers function. Multiply numbers, and here will be two numbers, 20 and 5, for example. And if I run the code now, I'll see nothing here in the output. Because at the moment there is no print function call, and this function is simply called here, and we don't use actual result which is returned by the function. And in order to be able to use result which is returned by the multiply numbers function, we should, for example, assign result of the function call to the variable result of multiplication, for example. And now this variable will actually hold this result which is returned by the multiply numbers function. And now afterwards we are able, for example, to print result of multiplication. Let's run the code, and now we see 100. So again, how does it work? Here we defined a function. It multiplies two numbers and then returns result using return statement. Here we call multiply numbers function and pass two arguments, 20 and 5. This function returns a value. And this value, which is returned by the function, we assign using assignment operator to new variable, result of multiplication. And now we are able to perform different actions with such variable, result of multiplication. Of course, we could call the same function multiple times, and let's call multiply numbers once again. We could use tab in order to autocomplete name, and here let's type, for example, 15 and 2, and we want to multiply those two numbers. And let's assume that we don't want to assign result of this function call to any variable, but we want to print result of this function call to the terminal. If we want to do so, we could simply add here two round braces like that and call print function. In such case, Python first will call multiply numbers function with such two arguments, get result, and this result will be obviously 30, and this integer 30 will be passed as argument in another function call, in print function call specifically. And now if I run the code, I get here 30 in the output. Which means that you are able to use result of the function which is returned by the function. For example, by assigning it to the variable or by passing directly in another function call. Both ways work actually. And also I would like to show you what function returns in case there is no return statement. If we remove return result from here and run the code, we'll get none. Because that's that value which is returned by any function if function doesn't have return statement. So please keep that in mind. None is default value which is returned by any function. And in some cases, if you don't need to use result of the function, you could go ahead without assignment, for example, of the function call to the variable, because you know that result is none. That's why there is no need to use such result. But if function has return statement, then of course you could use result of the function call and assign into the variable or use in another function call like that. But by default, if there is no return statement, function returns none, which is just single value of the built-in none type in Python. And also I would like to show you that if function returns result, it stops its operation. And for example, if I add here a print function call and type here this line is not executed and run the code, I will not see this string in the output. Because as soon as function returns result, it stops further execution. And Python does not look at this line of code. And you see that this line of code is underlined, and if you hover mouse over it, you'll see message this code is unreachable. And this proves what I just told you. this line is unreachable inside of the function because of this return result line of code. But if I move this line under the print function call like that and run the code, I will see this line is not executed here in the output, because now return is located after this line. Let's get back to previous order. And now print will not be called here in this function. That's it about the concept of the returning specific value from the function. And for that, you should use return statement. And by the way, it is possible to use return statement in several places inside of the function. And we will have a look at various examples of different functions throughout this course. For now, you already have strong knowledge about functions. You know that each function has a function name. It has block of parameters, and there could be 1, 2, multiple parameters, or function could be without any parameters. And parameters are simply variables which are available inside of the function body, and they are not available outside of the function. Also, inside of the function, you are able to create other variables. For example, result is the function local scoped variable, and it is also available only inside of the function. And when you call a function, and if function has parameters, like in this example, you have to pass arguments in the function call. And Python is very strict in terms of quantity of arguments. And if such a function has 2 parameters, then you must pass here exactly 2 arguments. Not less and not more, exactly 2 arguments. It is very important. And also function might return result. And you could do that by using return statement. And if there is no return statement in the function, function anyway returns result, which is none. None is an instance of the built-in none type. And in this example, we decided to return a result of multiplication of a by b. And for that purpose, we use return statement. And after that, we could assign result of the function call, for example, to the variable, or use in another function call, as we do here. That's all about basics regarding functions in Python, and again, we will have many further examples dedicated to functions in this course. And for now, you should remember difference between parameters and arguments. Here are parameters and here are arguments. And you should know that function body must be indented. 4 spaces here before each line. And this is function body or function block. And it gets executed each time when we call a function. Here we call a function on this line and on this line. So this function gets called 2 times in this particular example. Now let's explore some of the built-in functions in Python on practice. And let's first simply type print. And if you then click here on 3 dots, you'll see possible options such as quick documentation or quick definition. Let's click first on quick definition. And here you'll basically see definition of the built-in print function. Here is def keyword, then comes name of the function, it is print, and then in parentheses comes list of the parameters of the built-in function. And here, after this arrow, you'll see type of the value, which is returned by this particular print function. And this function always returns none, no matter what you pass to this function in the function call. Now let's again click on 3 dots, and now let's check quick documentation. Also, it's possible to press F1 to see documentation about specific function. So let's click on this, and now we see complete description of this particular function. We see that it is a built-in function, and here is list of the parameters of this function. And here is description of the function. It prints the values to a stream or to sys std out by default. Std out is standard out, And basically in each terminal there is standard in, standard out, and standard error, shortly stdr. And basically if I go to the terminal, let me open up built-in terminal here and type here, for example, Python. You send input via standard input in the terminal, via stdin. And this text was printed via stdout, standard out in the terminal. Again, I type, for example, exit and call this function, and I just send again input via standard in, and here I see result via standard out. That's how it works in terminal. Alright, let's go back to the documentation. Again, click on three dots and go to quick documentation. And here in documentation you could also find description of all parameters in the print function. And there are such parameters as values, sep, separator, and file flush. And in the print function call you could pass multiple arguments, multiple expressions. And print will print results of all expressions to the terminal. And by default there is separator between different values which are printed to the terminal, and default is a space. If you want, you could replace space with other separator. Also, at the end there is by default a new line. And this new line is added automatically by print function. If you want, you could add another string at the end after all values. So that's description of this particular function. In similar way, you could find description of other functions in Python. For example, let's type here dir. Go to documentation, quick documentation, and here is description of built-in dir function. And here at the top we see function definition, and on the right we see type of the value which is returned by the dir function. And it returns a list of strings. So that means that this function always returns a list, and each element in the list is a string. And below comes further description of this particular function. Let's have a look at one more function, for example, input. Let's go to documentation again. And here is description of the built-in input function. And as you might notice here, type of the value returned by this function is string. So, built-in input function always returns a value of type string. And here is description of this particular function. Alright, let's now simply print to the terminal print. So print is a variable, it is name of the built-in function, and now we will see in the output value of this particular variable. Let's execute this code, and here I see that print is a built-in function, and here is name of this function. Similarly, you could print, for example, input. Let's execute code, and now I see that it is a built-in function input. Let's print dir, execute code, and again, similarly as before, I see that dir is a built-in function. Notice that here I don't call print. Because if I call print here and execute code, I'll see none. Why I see none? Because as we saw in documentation, and that is visible also here, print function always returns none. And basically here we first call print function, it returns none, and then we pass none to the print function again. And that's why here in the output we see simply this value, none. It's a value of the none type. But how we could see basically list of all built-in functions? Let's simply do following. Let's print dir, and here let's call this function like that, without any arguments. Let's also add here a new line as a pep document suggests, and now let's execute this code. And here in the output I see a list. Because as we saw in documentation, dir function always returns a list of strings. Here we see that again when we hover mouse over the dir function. And that's the list which we actually see here. And this list contains different strings, such as 2 underscores annotations 2 underscores, 2 underscores built-ins 2 underscores, and so on. Several strings are available here in this list. And all of them have prefix 2 underscores and suffix 2 underscores. What is that? We will discuss a bit later. And if you want to avoid this horizontal scrolling and make all text visible on the screen, it's possible to click on this icon, which is called Soft Wrap. And now text will be visible on the screen. But what do we actually see here when we call a built-in dir function like that? We see list of the names which are available in the current scope. In simple words, we see list of the variables which we are able to access directly here in this main.py program. And for example, I could simply type print, then 2 underscores, name 2 underscores. And let me also add the line break and execute the code. And here I see value of the name variable. And it is a main. This proves that this variable with such name, 2 underscores name 2 underscores, is available here in this file. There is no need to create such a variable. Now let's have a look at the value of the built-ins variable. I'll copy this name from here and replace name with built-ins, and let me temporarily comment out this line. For that, I'll use key combination command /. On Windows, it is Ctrl/. And let's execute this code. And now I see a value of the built-ins variable with 2 underscores in front and at the end. And I see that built-ins is a module called built-ins. And basically this module is built-in into Python, and it contains all built-in functions such as print, dir, and so on. But how we could see which actually functions are built into Python? For that we could use following syntax. Let me remove all that, and here I'll type print dir, and now I'll call dir function with argument built-ins. Let's execute this code, and I see very long list in the output. Here where this list ends, and here is start of the list. And similarly as before, this list contains only strings such as base exception group, buffer error, and others. And if I scroll down, here, starting from ASCII, I'll see basically names of the built-in functions in Python. And among others, you could find such function as dir. And this function we just used here. Also, if I scroll down, I'll see such a function name as print. And this is this function which we just used as well. Also, there are other built-in functions for creation of different objects. And they are dict for creation of the dictionaries, int for creation of the integer numbers. Then there is a list, and list is used for creation of the list, and so on. So this list contains all built-in functions. And also it contains list of built-in classes, such as, for example, name error. Alright, let's hide this output and let's summarize. We just explored with you several built-in functions, such as print, dir, and input. We will talk about input in the next lecture, and we will try that on practice. But here we saw that when we call built-in dir function, it basically gives us a list of names which are available in the current scope. In other words, they are variables which are ready to use. And you could access such variable as built-ins or, for example, name with 2 underscores in front and at the end. And built-ins is basically a module. And using such function call dir, and here we pass built-ins as argument, you could get a list of all names which are available in the built-ins module. And this module contains, for example, all built-in functions and all built-in classes. And we saw a very long list with the names. And here we actually call one function, we get result from that function, it returns list of strings, and then we pass that list of strings to the print function. And therefore, in the output here, we see result. And this basically is the same as we just copy this list and put it here and pass this list in the print function call like that. If I execute this code, I'll get the same result. And basically you have access to all variables with the names listed here, such as arithmetic error, assertion error, and others. I could copy this part without single quotes, and then I'll delete this line and type here print and pass arithmetic error as argument. And if I run this code, I'll see that arithmetic error is a class. It is one of the built-in classes. And if I hover mouse over arithmetic error, I'll see description of this variable. And here I see that it is a class. And by clicking here, I could go and read details about this particular built-in class. Here is this class description. Exception, arithmetic error. The base class for those built-in exceptions that arise for various arithmetic errors. And it means that you have access to many different variables out of the box, and they are classes or built-in functions. For example, print is a built-in function and arithmetic error is a built-in class. And please keep in mind that you could always get details about particular function or class by going to documentation, either built-in description of particular function or external documentation, as we just saw for this particular arithmetic error class. If you want to become data science or machine learning specialist, I welcome you to the full Python course, which covers such packages as NumPy, Pandas, and scikit-learn. Now let's have a closer look at the built-in input function. And we already explored documentation about the built-in input function, and basically here you could see that this function expects from you a prompt. And it is a string, and here let's write please enter your name. And let me also add a new line. And let's run this code. And here in the output I see this prompt, please enter your name. This is the string which we passed here as argument in this input function call. Also, I'll disable soft wrap here in order to avoid two lines instead of one here. And now let's simply enter here name. I'll enter mine. And notice that text which you enter here in the terminal is entered directly after this prompt, without even space. Let's press enter here. And now I see that program finished. Process finished with exit code 0. But until I pressed enter, program was running. It was waiting for the input from the user. That's what input function does. It prompts user to enter some input and waits for this input from the user in the terminal. In order to add here space, you could add here, for example, colon and space. And if I run this code again, I'll see here colon space, and now I could enter my name like that. And again, process finished with exit code 0. What just happened? We actually entered the value, this one, it is a string, and Python actually didn't use this value, because we didn't assign result of this function call to any variable. And if I hover mouse over input variable, you'll see again what we discussed already before. We see type of the value which is returned by this built-in function, and it is str, string. And we could assign it to the variable, for instance. And assignment to the variable happens like that. Name, it's name of the variable. You could use, for example, other variable name. Let's use, for instance, my underscore name. And in such a way, we get value which is returned by this function, and using assignment operator, we assign it to this variable. And this variable will be, of course, created by Python. And after that, here, let's below print to the terminal value of the my name variable. You could always use tab in order to autocomplete name of particular variable. For example, you could type here my and then press tab, and name was autocompleted. Great, let's run this code again. Again, I see prompt, please enter your name. I'll enter mine, and after that, I see Bogdan in the output because of this function call. Value of the my name variable is printed here to the terminal. And afterwards, process is again finished with exit code 0. Program finished successfully. That's why code is 0 here. There were no errors. That's how this built-in function works. But please notice that it always returns string. Not integer, not boolean, always string. And now quick task for you. Please, in similar way, ask user to enter his favorite number and print that number to the terminal. Let's do that together, and here I'll add one more call to the built-in input function, and here will be prompt, please enter your favorite number, colon, and then space. And we have to save a result which is returned by the input function in the variable. And let's go to the beginning of the line by using key combination command left arrow. On Windows it is control left arrow. And here let's create new variable, my favorite num. And here will be assignment operator. And similarly as we did with my name, let's print to the terminal my favorite num. Let's run this code. Here I see prompt, please enter your name. Here is my name, enter. I see output in the terminal, that's my name. And now let's enter my favorite number, 777. And here I see output in the terminal. And afterwards, process finished. But please notice that here is a string, it's not an integer. And here is string as well. And we could verify that this is a string by doing the following. Print type of my favorite num. Let's run code again, quickly enter here name and favorite number. And I see that type of the my favorite num is str. It is an instance of the built-in string class. And certainly in Python it's possible to perform conversion of the type of the value. And you could convert, for example, such string to integer. But for now we will not do that. Alright, that's how we asked user to enter some values in the terminal, and for that we utilized built-in input function. And here we got value for my name variable, and here we got value for my favorite num variable. So here in this program we have two different variables, my name and my favorite num. Also, as we just discussed, my name and my favorite num are basically strings. And you could perform different actions with strings. And let's, for example, do following. Let's print my name, then I'll add dot, and after dot you'll see bunch of different names. And notice here M, near almost all names. M stands for method. And it means that each string has access to different methods, like for instance lower, or for example upper. Here is upper. And let's call for instance upper method. Because it is a method, it is actually a function, we have to call it using parentheses. And let's run this code now and see what happens. Again, I enter my name, then enter my favorite number, and afterwards, at the end, I see result of this print function call. I see Bogdan all uppercase letters. And that's what this particular method did. It converted string which I entered here to string with all uppercase letters. And result was returned by this method, upper. And the result was passed as argument in the call to built-in print function. And that's why we saw here Bogdan with uppercase letters. And except upper, there are many other methods available for strings. Alright, that's all for those examples related to built-in input function. Now let's talk about indentation in Python. Idents in Python programs play an important role. Because thanks to idents, Python understands where is start of particular block of code. For example, if you create a function, you have to ident function body. If you create if statement, you have to ident block inside of the if statement. If you create a loop, you have to also ident block inside of the for loop. That's mandatory in Python. Let's have a look at the correct code in Python. Here we define a function, and function name is print name function. Here it is. This function has single parameter, which is name. And also in the function body here, we call built-in print function and pass to it name. And we expect that the value of the name parameter will be printed in the terminal. And notice here this indentation. Usually, in Python there are 4 spaces for each ident, but it's also possible to use 2 spaces. But if you don't ident function body here, it will be an error. If you write code like this, def print name function name colon and afterwards without indentation you write print name, it will lead to mistake in case you execute such code. And actual error will be indentation error expected and indented block. Because here on this line of code, Python expects from you function body, and function body must be indented. In Python, you don't need to use any curly braces or round braces in order to surround block of code. There is no need for that. Indentations are single hints for Python in order to make Python understand where specific block of code starts or ends. So please be careful and use indentations properly. And usually each ident is 4 spaces. And most code editors and IDEs are configured in such a way that you could use tabs. And each tab is automatically converted to 4 spaces. But it's also possible to use 2 spaces for each tab. But please be consistent. Use either 4 spaces everywhere in your Python application or use 2 spaces. 4 spaces is preferable and more widely used. Now you know that indentation is very important in Python. And using idents, Python understands actually where you want to start specific block of code and where block of code ends. And anytime when there is a colon, Python actually expects block of code after this colon. And inside of the function body, you must add at least 1 line of code. It is mandatory. Same applies to other blocks of code. For example, for blocks of code in if statements or in the for loops in Python. Now let's have a look at the indentations on practice. And let's define a function and let's call this function print num. And this function will have just 1 parameter, for example, let's call it num. Then comes colon, and if I press enter after colon, you'll see that PyCharm will automatically add indentation. And basically this indentation consists of exactly 4 spaces. And this is a recommendation of the PEP document. 4 spaces for each ident. And here in this function, let's simply print to the terminal value of the num parameter. And below we could call this function, and notice that if I press enter again, I will remain in the function body, so cursor is blinking here. But if I want to move out from the function's body, I have to press delete on Mac keyboard or backspace on Windows, like that. And now I am underneath def keyword. And if I press enter again, I will remain here. And let's here call print num function. Let's add parentheses, which represent function call. And let's add here argument, for example, number 5. And let's execute this code. Code was executed, and here I see 5 in the output, which means that our function works correctly and there are no errors. But here I see that print num is underlined, and if I hover mouse over this line, I see that it is expected to add 2 blank lines after class or function definition, according to PEP 8. We will discuss PEP 8 very soon. But it's a convention to add 2 blank lines after function declaration and before function declaration. It means that I have to add 1 more blank line here. And now this warning disappeared. So that is a correct syntax. And Python understands that here is a function body, because of indentation here. But if I remove this indentation and make it like that, I immediately see that there is an error. But let's try to execute the code. And now I see here indentation error, expected an indented block after function definition on line 1. And here is exact line where this error actually occurred. And this proves that function body has to be indented. And function body must have at least 1 line of code. And that's because this function doesn't have a body right now. And this line of code is located on the same level as function definition. That's why I have to put cursor here and press tab. And if you press tab, PyCharm will automatically convert it to 4 spaces, 1, 2, 3, 4, making correct ident. Let's try to press tab once again, like that. 4 more spaces were added, and now I see that there is a warning. Over-idented. It means that I added too much idents, too much spaces. But if I execute this code right now, I will not see any errors. This means that you could potentially use more spaces than 4, but it is recommended to use just 4. And if I place cursor here and press delete, I'll see that 4 spaces were deleted. That's correct indentation for this function definition. Also notice that if I add here ident like that and execute code, I'll basically see nothing here in the output, and there is no error. Why is that? How do you think? Because now this function call is basically located in the function body, because of indentations. And those empty lines are basically allowed here. So this is technically the same as this. I create a function and call this function inside of it. But outside of this function I never call it. That's why in the output we see nothing. So output is empty. So please be careful with indentations. Also, let's add one more example here with idents. And let me type here if. For example, here will be if 10 greater than 5. It is conditional statement. And next will be colon, and after colon, same as here, Python expects from you indented line of code. And if I press enter here, I'll see that 4 spaces were added. And here I could simply, for example, call print function and type here true. So if 10 is greater than 5, then simply print to the terminal true. Let's run this code, and here I see true. Because this condition is truthy. 10 is greater than 5. So there is no error. But again, if I remove this indentation here, I'll see notification here, ident is expected. So Python expects from you here an indented block of code. And it means that each indented block must have at least one line of code. Function body must have at least one line of code. This block must have at least one line of code after this condition and colon. And general rule is that indented block should come always after colon. Here, for example, or here. That's all about indentation in Python, and such IDE as PyCharm or such code editor as Visual Studio Code automatically add those idents for you when you write code.
Now let's talk about PEP8, which is Python Enhancement Proposal. What is that? And how it is used in Python applications. PEP8 is just a document, text document to be precise. And this text document has a set of recommendations for writing Python code, nothing else. And you could navigate to following URL peps.python.org/pep308, and you'll find there this style guide, which contains multiple recommendations regarding styling of the Python code. Here is this website, and this document was created long ago, and it has a bunch of recommendations regarding styling of the Python applications. For example, you should use 4 spaces as single ident. Also, you could find which is wrong and what is correct. And next, for example, you could find that you should use spaces, because spaces are preferred indentation method. Also, maximum line length should be 79 characters, and so on. There are many different recommendations regarding styling of the Python programs, Python files actually. And if you have some time, I recommend to you to read briefly through this document and find what is wrong and what is not wrong. For example, when you perform imports, it is recommended to split imports to different lines. Don't do like this. 2 modules in this example are imported on single line. Use 2 imports for that. And so on. There are many different recommendations. Also, there are many other documents, PEP documents. For example, you could modify here 8 to, let's say, 10, and you'll see another document, voting guidelines. And each document has its own purpose, but normally each PEP document is a set of some recommendations. So, PEP8 is a style guide for Python code. And here are some recommendations from the PEP8. Use spaces for indentation, not tab. But as you already know, most code editors automatically convert tab to 4 spaces, because type each time 4 spaces manually is not convenient. And most code editors automatically add 4 spaces when you move to specific block of code after colon. So when you write def, my function, then parameters, colon, press enter, then Visual Studio Code and, for example, PyCharm will automatically add indentation, because they understand that you move to function body. Next recommendation is the recommendation which we already saw in the document. Length of each line should not be more than 79 characters. Don't use long lines of code. If line of code is too long and longer than 79 characters, please split that line into multiple lines. Also, functions and classes must be separated from other lines of code by 2 empty lines. Before each function declaration, 2 empty lines, and after each function declaration also 2 empty lines. Same applies to classes. If you define a class, you have to add 2 empty lines before class definition and after class definition. Module imports, as we already saw in the document, should be on separate lines. Don't import multiple modules just on one line of code. Separated imports are more readable. Comments at the end of the code line should be separated by at least 2 spaces. This means that in case when you use inline comments, which are put on the line of code, and they are put at the end of the line, you have to separate actual line of code and comment using 2 spaces. And you see that most recommendations in PEP 8 are basically styling recommendations. But they make your code actually more readable, and they actually define standard for all Python applications. And it is possible to install special extensions which are able to automatically format your Python files according to the PEP 8 document. And one of such extensions is called AutoPEP8, and you could install it and configure for automatic formatting, and each time when you save the document, it will be automatically formatted according to PEP 8. There are also other formatters available. That's it about PEP 8, and now I recommend to you to go briefly through entire document and read about other recommendations for styling your Python applications. Before we saw multiple times suggestions regarding formatting of the document, and those suggestions were based on the PEP 8 document. And now let's see how we could enable auto-formatting in the PyCharm interactive development environment. Let me print to the terminal my name. And I will add here a few spaces, and also I will add the line breaks here. And if I try to run this code, I will see actually no error, and code was executed successfully. And here I see Bogdan in the output. But formatting of this file is completely messed up, and it is not in accordance with PEP 8 document. And if I hover mouse over this line, I will see informational message from PEP 8, white space after opening paren. This means that in the function call, you should not add any white spaces before actual arguments, because here is argument in the print function call. I could add here one more argument, I'll add here comma, and I'll add some spaces before comma, after comma, and here I'll add, for example, number 10. And again, if I run this code, there will be no error, and I'll see Bogdan and 10 separated by space. Space, recap, is default separator for separation of different values which you pass as arguments in the print function call. So again, this code is completely valid in terms of Python, but its formatting is messed up. And now let's see how we could enable auto-formatting of the files in the PyCharm. In order to do that, we have to open up Settings, let's go to Settings, then expand Tools, and find here Actions on Save. And this option, Reformat Code, basically enables reformatting of the code automatically each time when you save the file. And here you could choose file types, and by default it will be enabled for all file types like HTML, JSON, Python and others. Now we are mostly interested in the Python files, so that is enabled. And now let's press OK and see what will happen if we save the file. You could save changes in the file by going to File, Save All, and here is also key combination. On Mac it is Command S. Let's use key combination because it is always faster to use key combinations. And now I see that code was automatically formatted. But this empty line is still present here. This means that PEP 8 allows actually to use empty lines when you call a function. And it is possible to split arguments even to different lines like that, if you want to do so. Let's save the file again, Ctrl S on Windows, Command S on Mac, and now I see that
this function call remains on multiple lines and empty line is allowed here. And there are no more warnings. And if I run such code, I will see correct output here. But now there are no warnings from the PEP8. Let's remove this code and let's now define a function def myfn, and this function will not have any parameters. And now let's in this function simply print to the terminal true. And if I add function call here below myfn like this without any arguments and hit run the code, I'll see that code will be also automatically formatted. And according to PEP8, there have to be 2 empty lines after function definition and before it. And here you see that 2 empty lines were automatically added. And here is result of this function call. True is printed to the terminal. It means that each time when you run code here in the PyCharm using this button or corresponding key combination, on Mac it is Ctrl+R, on Windows Shift F10, PyCharm will actually automatically save the file and correspondingly apply auto-formatting, because we enabled it here in the settings. Recap, it is located in the Tools, Actions on Save, Reformat Code. And now each time when you will execute Python program, code inside of it will be automatically formatted. And you don't need to care about, for example, empty line at the end of the file. You could leave code like that, run it, and you'll see that empty line will be added here automatically. This is how auto-formatting works in the PyCharm. And these are a few examples how you should format code in the Python files according to the PEP8 document. Now let's talk about comments. Using comments, you could add some blocks of text which are ignored by interpreter. So, Python simply ignores comments. And you could add a comment anywhere in your code. And I recommend to you to add comments in order to describe purpose, for example, of specific function or of specific class. And avoid adding comments which describe actual code. Code must be self-explanatory, and you have to write your Python code in such a way that other people, other developers who potentially will look at your code in the future, will be able to understand what it actually technically does. But you should answer the questions, for example, why, in comments, and explain, for instance, how to use particular function or class. And in Python there are 3 different types of comments, and in all cases you have to use hash sign. There is single line comment like this. There is multi-line comment. Simply use hash sign at the beginning of each line. And also there are inline comments. Inline comment comes after specific line of code, and according to PEP8 document, here you have to add 2 spaces. Also here after hash sign you could add 1 space or more. There are no recommendations regarding that. So here is inline comment, here is multi-line comment, and here is single line comment. If you describe purpose of specific file in Python, and each file in Python is basically a module, you should put multi-line comment at the top of the module and explain what is this module for and how to use features in this module. That's recommendation which simplifies life of other developers, of other users of your Python application. But please don't explain each line of code. You should not write here a comment, print number 10 to the terminal, because it's clear from this command actually. So don't add meaningless comments. Try to answer why questions in the comments. That's all about comments in Python. Now let's have a look on practice on different types of comments in Python. And they are single line, multi-line, and inline. And let's start with single line comment. I'll add the hash sign, then type any string, for example, single line comment. Next, let's add multi-line comment, and I could use hash sign on each line, multi-line comment. And if you want to uncomment specific section, for example, specific multi-line comment, you could press Shift button and using up and down arrows select a particular block of code and then use key combination. On Windows it is Ctrl/, on Mac it is Command/, and section will be uncommented. And of course now I see multiple warnings, because Python now treats this block of code as actual code, not as a comment. And I could do the same by commenting out this section by using same key combination. On Mac again Command/, on Windows Ctrl/. And now there is again a multi-line comment. Now let's add inline comments, and for example there is line of code print 777, and after this line of code inline you could add inline comment. And it has to come after 2 spaces. But let's add only 1 space for now. Then comes hash sign, and here we'll be printing 777 to the terminal. That's description of this line, for example. And if I add here line break and go to the next line, I'll see here warning from PEP, at least 2 spaces before inline comment. Because according to PEP 8, you have to use 2 spaces before actual comment, which is inline on particular line of code. But if I run this code now, I'll see that this line of code will be automatically formatted, because before we enabled auto-formatting on save. And each time when you run the code, PyCharm saves the file automatically. And here we see this value in the output. That's a result of this function call. That is first inline comment, and next let's add one more function call print, and here will be my name, and next to it let's add one more inline comment printing my name to the terminal. If I run the code, I will see that formatting will not be modified, and here I see results of 2 calls to print function. That's where 2 inline comments, and here is multi-line comment, and here is single line comment. But please notice that it's not recommended to describe actual lines of code like I did here. Code should be self-explanatory, and you should use comments in order to answer the questions why and how. And if you create, for example, a module in Python, it's a good idea to add a multi-line comment at the top and describe that module. And also, sometimes developers do like this. Select few lines of code and then comment them out, and leave such comments in actual files. And it's not a good practice. If you don't plan to use those lines in the future, please delete them. Don't comment them. So that's where inline comments, multi-line comments, and single line comments in Python. Now we will talk about 2 important concepts in Python. And we will talk about expressions and statements. And we will discuss differences between them. And let's start with expressions in Python. Expression is specific part of code which produces a value. So result of each expression is a value. And let's have a look at some examples of expressions in Python. 5 plus 3 is expression in Python. And here we use plus operator. And result of this expression is 8. In this example, we don't use result of this expression. We simply write expression and that's it. So result of this expression is not used. But it's a common practice to assign result of the expression, for example, to the variable. And here we get 8, which is sum of 2 values.
Next example. In the next example, there is comparison operator greater than, and we compare values of two variables, a and b. And here we get true or false as a result of entire expression, depending on the values of the variables a and b. And certainly, we could use result of expression. For example, we could use such expression in the if statement or in the while loop. Next example of the expression, where we concatenate two different strings. Here is first string and here is second string. And we use plus operator in order to create one string from two strings. And the result of this expression is hello world. One more example of the expression in Python is function call. Each function call in Python is an expression, because each function returns specific value. And in order to return value from the function, you have to use return statement. If you don't use return statement, then function will return by default none. Here we call myfunc and pass two arguments in the function call. And this function returns specific result. And that is result of this entire expression. To summarize, each expression in Python produces a value. Or we could say that each expression is evaluated to specific value. And that value could be, of course, reused later. For example, we can assign result of any of those expressions to the variable and use that value later in the code. And most operators like plus, greater than, less than, not in, is, and others are used in the expressions in Python. Function call is also an expression in Python. And next, let's talk about statements in Python. We just talked about expressions in Python, and you know that each expression gives us specific result. And now let's talk about statements in Python. Statement performs an action or different actions. Let's have a look at some statements in Python. Creation of the variable and assignment of the value to that variable. Here we do that on just one line of code. Python creates new variable with name myName if such variable was not created before, and using assignment operator assigns such value to this variable. So Python performs an action, creation of the new variable. That's why this line of code is statement in Python. Next example. In this example, we use conditional statement. And this conditional statement consists of the reserved keyword if, then comes condition, in this example simply name of the variable, myName, and then after colon comes block of code, which is executed in case this condition is truthy. Otherwise, this block of code is not executed. And here, where Python expects from you condition, here on this place, you must use expression. You cannot use statement here on this place. You could write here if a greater than b. It is acceptable. But you cannot write here if, and so on. Or if and then assign value to the variable. It is not possible. Here you must use expression. Next example of the statement. Import. Imports allow you to import other modules or specific variables from other modules. And you already know that according to PEP 8, you have to place all imports at the top of the file. And import actually performs an action. It imports from other module. And it does not produce any value. It performs an action. And for example, import datetime basically creates new variable in this file where you use import. And this variable will be called datetime. So here you see examples of the statements. There are also other statements in Python. For example, return statement. Using return statement, you could return result from the function. While loop or for-in loop, they are also statements because they execute same block of code multiple times. So, statements perform actions. Expressions produce values. And very often expressions are used in the statements, for example, in the if statement, or in the while statement, or in the for-in loop. That's the difference between statements and expressions in Python. And recap that, for example, assignment of the value to the variable is statement in Python.
Let's now explore some expressions in Python on practice. And let's start with a simple expression where we divide 10 by 2, for instance. This is an expression and it produces a value, and this value is 5. And we could assign this value, for example, to the variable, for example, variable a. Here is assignment operator, and here is name of the variable. And now we could perform different actions with this variable, and we could, for example, print value of the variable to the terminal. This is also an expression. So what you see here in the parentheses is expression, and expression consists only of one single variable. Alright, let's run this code and see what we'll get in the output. And we get float number 5.0. Because anytime when you divide even integers, you'll get float value. And this is a result of this particular expression. Let's have a look at another expression, and let's simply call here print function without any arguments. And let's assign a result of print function call to the variable, for example, variable res. And now let's print to the terminal value of the variable res. Let's run the code, and we see none. That's what we actually discussed a bit before, and if you hover mouse over print function, you'll see that this function always returns none. And actually each function call, for example this one, is expression. And that means that result of any function call you could assign, for example, to the variable, like we do here. Or you could use that result in another function call. And we could omit this line of code, let's remove it, and replace res here with call to print function. That's the same as was before. We get result of this expression and pass this result in another function call here. And if I run the code, I'll get the same result, none. Let's now here use a built-in input function which returns a string, and here will be prompt enter any number. And we also could assign result of the input function call to the variable, for example, num. And then let's print num to the terminal and run this code. Enter any number, for example, I enter 100. And I get 100 in the output. But recap that this value is actually a string. And it's possible to convert this value to integer by calling built-in int function. How we could do this? Simply by wrapping result of the input function to the call to int function. Simple as that. And now if we run the code and enter here, for example, again 100, I'll get here already an integer. How we could ensure that it is an integer? By printing type of the num. Run the code again, enter any number, again 100, and here I get class int. So this number is an object which is an instance of the built-in int class. And here again we use the fact that this is an expression. And after calculating result of this expression, we call this built-in function, which obviously expects from you an expression as argument here. But what about statements in Python? Let's, for example, define here a function myFn. This function is without any parameters, and here in this function let's simply print to the terminal test. It is a string. And we could ensure that function declaration is actually a statement by doing following. We could call any function, for example, print function, and paste here this block of code, like this. And I'll remove block of code from here. And immediately, if I hover mouse over letter D here, which is underlined, I'll see that expression expected. This proves that function declaration is actually a statement, and we are not allowed to use statements where Python expects from us expression. And that's why we get here such error. Also, for example, if I decide to use here if statement and write, for example, if true, colon, and here I'll do something, for example, print again test. Here I'll get same warning. If I hover mouse here, I'll see that expression expected, because if statement is statement in Python, and we are not allowed to use statements here. Also, if I try to assign value to the variable, for example, like this, so here is variable name and here is its value, I'll get also an error, unexpected argument, because this is a statement in Python. Alright, that's where expressions and any expression produces a value. And you could use that value anywhere in your program. For example, you could call another function and pass to it that value. Or, for example, you could assign a value to the variable. You already know the difference between expressions and statements. Expressions produce specific values, and statements perform specific actions. For example, assignment of the value to the variable is statement in Python. It performs actions. It creates a variable or assigns new value to existing variable. There is also if statement. If, for example, 10 greater than 2, perform some actions. Print true. This is statement in Python. Function declaration is also a statement. Def print name. Here will be single parameter name, and here let's call print function and pass to it name. So here is a statement in Python. We create new variable, print name, and this variable holds a function as a value. And therefore later we are able to call this function. Also, when you import, for example, built-in module, let's import datetime, you also create a statement here. You perform an action, you import another module to current module. And afterwards, you get access to different attributes of the datetime object, because it's an object. And here are such attributes as max year, min year, time, date, and so on. And I could, for instance, access a value of the max year attribute. And now we could, for instance, print value of the max year to the terminal. Let's run the code, and here I see such a value. It's a value of the max year attribute of the datetime object. And when we perform import, Python basically creates an object which holds all available variables in that module. And max year is one of such variables. So this is a statement. It performs actions. And the same as before, we could ensure that it is a statement by trying to pass it here in the print function call, for instance. And immediately I get here a warning, expression expected. And if I run this code, I'll get here syntax error, invalid syntax. You are not allowed to use import where Python expects from you an expression. Alright, that's where expressions, and now small task for you. Please create a function and use in the function return statement. And before using it, please ensure that return is indeed a statement, not an expression.
Now it's time to talk about variables in Python. Variables make it possible to keep values for future access. They are like storage for particular values. But technically in Python each variable is just a pointer to specific object in memory. But via specific variable you could always go to that object and, for example, read it, or modify value of specific variable if you want to do so, and point it to another object. Let's see an analogy. At home, you usually have multiple boxes, and you put different stuff in those boxes. For example, you could put your favorite toy in the box. And afterwards, you could put this box on the shelf. But if you have many boxes, you have to write something on the box, for example, my toy, in order to be able in the future easily find this box and take the bear, your favorite toy, out of this box and use that toy, play with this toy, and then put it back in this box. And also you could take out this bear and put another toy, another thing in the same box, and keep the same name, my toy. That's what you usually do at home, and name on the box is needed in order to find specific box and take contents from that box. Similar picture is with variables in Python or any other programming language. You take specific value, for example Bogdan, or any number for instance, and put it into the box, put it in the memory of the computer. And then in order to be able to find this value, you put name on the box. And in this example, name on the box will be my underscore name, its variable name. And then we close the box. And anytime knowing this variable name, my name, we could go to this box and check its value and use this value for other purposes. Also, it is possible to take out one value, for example Bogdan, and put another value in the same box, in the same variable. That's what is variable, and now let's talk about naming conventions for different variables in Python. And most common notation is snake case. All lowercase letters with underscores between different words. And snake case is used in Python for variables, functions, methods, or modules. So in most cases, in 90% of cases, you have to use snake case notation. And in my opinion, it is the most readable notation in the world. You could very easily read any variable name which is written in snake case notation. Also, there is Pascal case notation, where there is no separation between different words, and each word starts with capital letter. And such naming convention is primarily used in Python for classes, and primarily for user-defined classes, because there is a bunch of built-in classes in Python, such as int, str, dict, bool, and others, and they are written in lowercase notation, not in Pascal case notation. But you should use Pascal case notation for your user-defined classes in Python. Also, when you create a package in Python, package is a set of different modules. You could basically name it whatever you want, but it's common to use dash between different words when you create and choose name for specific package. Package is created when you need, for example, to publish it publicly on py.org website, where there are many different packages which could be used in your Python applications. And also you could create packages which you will use in your own Python programs. And one more naming convention which is used in Python programs and in other programs in other programming languages is uppercase snake case. And such naming convention tells that we have to use all uppercase letters and separate words using underscore. And such naming convention is used for constant variables. Constant variables are variables which hold, for example, usernames, passwords, and other data which is not modified during life cycle of the application. And that applies to any application in general, not just Python applications. And usually such constants get their values before programs start. And they usually contain sensitive data. And it's an indicator for other developers and for you that you should not modify value of such constant variables. If you see somewhere a variable which has uppercase notation, which is used for constant variables, never assign new value to that variable, because it might break your application. So here are 4 naming conventions, and the snake case is most oftenly used. And it is used for all variables, functions, methods, and modules. For classes, please use Pascal case notation. For constant variables, uppercase notation with underscores between different words. And please also wisely choose names for the packages. But usually in the package name, different words should be separated by a dash. And the key idea is that each variable name in your program must be clear and easy to understand. Don't use meaningless variable names like foo, bar, test, xyz, a, b, c, d, and so on. Those names are meaningless. They tell nothing about the purpose of the variable. From the variable name, anyone should understand what is the purpose of that variable, what that variable holds, or what, for example, function does. And you should understand that from the variable name. Alright, let's now examine how we could create a variable and assign a value to it. In the Python, it is done on a single line of code. So on one line, we declare a variable, here is the name of the variable, and on the same line, using assignment operator, we assign a value to this variable. And what Python does in this case, it creates new object, and this object will have type integer, and it places this object in the memory. Then it creates variable with such name, my number, and puts into this variable name reference to specific object in memory. It is basically ID of that object. And you could always find ID of specific object using built-in ID function. But is it possible to reassign value to already defined variable? Of course, in Python is possible, because Python is dynamically typed language. And you could assign different values to the same variable in different parts of your application. For example, here we define new variable, it is my variable, and assign initial value to it. It is number 10, integer 10. And then later you could assign value of other type to the same variable. And that's not a mistake in Python. And then you could again assign another value to the same variable. And Python will never complain about that. So same variable could have different values in different moments of time in your application. And of course, type of the variable is determined by the type of the assigned value. And we can say that if you assign, for example, integer to the variable, we can say that variable is integer, or variable holds an integer. So type of the variable is defined by the type of the assigned value. Here in this example, you see that it is possible to pass variable name in the function call. And in such case, you'll see in the terminal 10, because Python will go through the reference to specific object in memory, find this object, and print its value to the terminal. Here we create one more variable, for example my boolean, and also print value of this variable to the terminal. And we'll see true. It is value of this variable. But always please keep in mind that every entity in Python application is an object. And here, when you create a variable and call it myNumber and assign 10 to it, Python creates an object which is an instance of the built-in int class. If you do the same, for example, and assign string to other variable, then you create an instance of the built-in str class. And for strings in Python, you could utilize either double quotes or single quotes. And please be consistent. If you decided to use double quotes, then use double quotes. If single quotes, then use single quotes everywhere. I prefer to use double quotes for long text strings, which have multiple words. And in all other cases, I use single quotes. That's it about variables. And what you have to remember is that variable name is just a reference to specific object in memory. And using variable name, you could always get back to specific value and perform some actions with that value. You could read a value, you could assign another value to the same variable, and it is possible in Python because Python is dynamically typed language. And when you create specific value, for example, integer or string or boolean, Python always creates brand new object, which is an instance of specific built-in class.
Let's now create few variables. And let's start with variable favorite city. And notice that here I use snake case notation. It's the most commonly used notation in Python. And value for it will be, for example, New York. And later it's possible to reassign value to any variable in Python, because Python is dynamically typed language. So here we are able to print favorite city to the terminal, and later we could assign new value to the same variable, for example, London. And then we could print value again, and after this operation we will get another value in the favorite city variable. Let's run the code, and here I get New York and here I get London. That's how we could reassign values to the variables, and notice that name of this variable answers the question what variable contains. It contains city. And now let's create a function, and let's call this function, for example, print city. This function will have single parameter city, and let's simply print city in the function. And now we could move function definition to the top of the file here, and instead of calling print function here, let's call print city function. Let's select it here in the dropdown and pass favorite city in this function call. And now let's copy this line of code and remove this line and paste print city function call again here. Let's run this code, and I'll get same results as before. So function print city was called 2 times. Here we get New York and here we get London. And notice how I named this function. I named it using snake case notation, and the first part of the function name basically answers the question what function does. It prints city. And such names as print city for function or favorite city for string make your code readable. And you will avoid even occasional reassignment of the value, for example, to this variable. You will never do like this, print city, assignment operator true, because you know that print city contains a function. It performs an action, it prints city. Therefore, you will never do like this, even though Python allows you to assign new values to the variables. And in case we run this code, we will see here type error, bool object is not callable. Because here on this line reassignment happened correctly. But now if we try to call print city function, obviously we get an error, because print city is no longer a function, it is a boolean. That's why in the output here we get type error on the line where we attempt to call a print city function. But again, if function has a name print city, you will never, even occasionally, reassign a value to the variable print city, like this. But if a function has a name, for instance, simply a, like this, of course you could not guess what this function actually does. You could not even guess that it is a function, because from the function name it's not obvious. That's why I highly recommend to you to always use meaningful names. Avoid using short names like this one. Use longer names, but meaningful names. Also, for instance, if you want to create some constants like, for example, my password, you have to use uppercase snake notation. And value will be, for example, ABCD here. Next will be, for example, my username, and username will be here admin. So if values of some variables don't change during life cycle of your Python application, you should use uppercase snake notation, like my username or my password. That's an indicator to you and other developers that such variables contain actually constants, which will never change while the program is running. And of course, if you see somewhere such variable names, you should not assign new values to such variables, because those variables should be treated as constants in your Python application. That's all about variable names and approach to naming variables, including functions, and also we discussed how to properly name constants in Python applications.
I already mentioned that Python is dynamically typed language. And now let's dive a bit deeper into that and talk about difference between dynamic typing and static typing. And let's have a look at this example. In this example, there are prefixes before variable names. And there is string, int, on those two lines. And if we use such an indicator, it means that variable a must hold a string as a value. And here we tell that variable b must be always of int type and must have integer as a value. And if in this example we assign, for example, string to the variable b, we'll get an error, because string is not allowed as value for the variable b. And that is called static typing. And this is not Python. Python is not a static typed language. And in Python, you could perform reassignment of the value of any variable. And initially, for example, this variable has value of type string. It is instance of the str class. And then we assign another value to the same variable. And now it is integer. And in Python, it's totally fine. Python is dynamically typed language. And this could be treated as advantage, because it is easier to create Python applications. You don't need to care about types of the variables. But on the other hand, there is also disadvantage, because you could, for instance, occasionally reassign value of the critical variable. And to summarize, Python is dynamically typed language. And in Python, it is normal to assign different values to the same variable. And those values could be of different types: integer, boolean, string, none, and so on. Any type works. And anytime you could assign new value to existing variable. Now let's see this example. In this example, we define a function, and here is this function definition. This function has a name, print name, and basically what Python does here, it creates a variable with name print name and assigns a function to this variable. And same as other entities, functions in Python are also objects. Then we could call this function using round braces and pass, for example, Bogdan, its value for this single parameter. and function will print Bogdan to the terminal. We'll see Bogdan here. And afterwards, occasionally, for example, you decided to assign new value to the print name variable. And you do this like that. And afterwards, again, you try to call print name function, because you know that it is a function. But now you get type error. Int object is not callable, because we reassigned value to the print name variable. And that's possible because Python is dynamically typed language. Alright, let's now talk about rules for working with variables. And if you follow those rules, you will avoid even occasional reassignment of the value to the variable. First, always choose meaningful names for all variables in your applications. This will help you to understand what is the purpose of specific variable, and that will also help other developers, which work probably together with you on development of the same Python application. Next, in variable names, use a noun, such as name, comments, new photos, my favorite animal, my favorite fruit, and so on. In case such variables hold, for example, string or integer. In case a variable holds, for instance, a sequence of elements, list, then call such variable my favorite photos or new photos. This means that noun variables should answer the question what does it contain. So what does variable contain? Variable contains my name. Variable contains best comments. Variable contains top responses, and so on. So, such variables should answer the question what does it contain. Names of functions and methods should begin with a verb. For example, get data, create request, adjust size, resize, merge names, and so on. And each function and each method should answer the question what it performs or what it returns. And when you will structure variable names in such way, then you will avoid even occasional reassignment of the values to the variable. If variable has name, for instance, create request, you will never assign a Boolean value to such variable, because this variable should create a request, should perform an action. It is a function. So please follow those rules and you'll be pretty fine with dynamic typing in Python. Now it's time to dive deeper into types and data structures in Python. Before, we briefly talked about most commonly utilized types in Python, such as strings, integers, booleans, lists, and dictionaries. And now let's dive a bit deeper. First, there are no primitive types in Python. You know that each value is actually an object. That's it. There are, on the other hand, mutable and immutable objects in Python. The object is mutable if we are able to modify this object. The object is immutable if we cannot modify this object. For example, string in Python is immutable object. Or integer, it is also immutable object. List or dictionary are mutable objects. So let's have a look at the types of immutable objects in Python. First, string. Each string is instance of the str class. It is a built-in class. Next, boolean. This is an instance of the bool class, and this is also built into Python class. And there are just two possible values, true and false. Next, integer. Each integer is instance of the built-in int class. Decimal numbers. Decimal numbers are instances of the built-in float class. One more immutable object is tuple. Tuple could contain actually different elements. But tuples are immutable in Python. You are not able to modify tuple after it is created. And each tuple is an instance of the tuple class. It is also a built-in class in Python. Also, none, there is one more type in Python, and corresponding class is called none type. It is built-in class in Python. All values of such types, strings, booleans, integers, decimal numbers, tuples, and none, are immutable. You are not able to modify any object of such types in Python. But you could create another object of the same type. Let's have a look at the mutable objects in Python. They are lists. Each list is an instance of the list class. Dictionary. Each value is an instance of the built-in dict class. Next, there is one more mutable object type in Python. It is set. And set could contain sequence of the elements. And in the set, each object is an instance of the built-in set class. And also user-defined classes, which you create in Python programs, are also mutable. You can modify any instance of the user-defined class. And in general, using built-in classes such as list, dict, and set, you could create sequences of elements. And you could modify such sequences, add new elements, remove elements, modify elements, and so on. That's why objects which are of such types as list, dictionary, or set are mutable in Python. And also objects of user-defined classes are mutable in Python. And for instance, you could easily add a new attribute to any instance of the class which you created. Other objects, which are not shown here, are immutable in Python. You cannot mutate, for example, a string, or you cannot mutate Boolean object. That's it about mutable and immutable objects. And also you have to remember that in Python there are no primitive values. All values are objects, and each object is an instance of specific class. Now let's discuss how variables and objects are stored in the memory. So, there is memory on each computer, and when you create a variable, you assign specific value to that variable. And of course, you give a name to the variable. And as you know, every value in Python is actually an object. And such object is created in the memory of the computer. Afterwards, when you create another variable, for example, profile photo, and assign another value to this variable, another object is created in the memory. And variable names, are actually just pointers to specific locations in the memory. They point to specific objects. One more variable, other name, it also points to another object. So in this example, there are 3 different objects in the memory, and there are 3 different variables which just point to specific locations in memory. And also each object in memory has its location, and it is called ID. It is place in memory where an object is stored. It means that each variable contains just a reference to specific object. And this applies to all variables in Python, because each value in Python is an object, and each variable is just a reference to specific object. You could very easily get an address of specific object in memory using built-in ID function. And you have to pass either variable name or specific value to this function. And this function returns actually a number, and it is an address of specific object in memory of your computer. You could also print a result of the function call to the terminal, and in such case you will see ID of specific variable, ID of specific object to which variable points, and you will see such a result in the terminal. And this example clearly shows that you could pass result of one function call, here is one function call, to another function, in this example print function. Because here in rectangle you see expression, and as you know, each expression actually results in specific value. And that's why we could pass such a value to another function. Of course, you could create a separate variable, for example, ID of the variable, and assign result of this function call to that variable, and afterwards call print function and pass to it another variable which you created. But you could go on without creation of a separate variable and do like this. So call one function and pass result of that function call to another function. Let's have a look at such two examples where we create two different variables, my number and my string. These variables contain different pointers to different objects, because these objects are different. And that's why when you try to find the location in the memory of each object, you will see different numbers. Here are numbers on my computer. On your computer, of course, you will see completely different numbers. And these numbers are addresses of the objects in the memory. And again, in such example, such IDs are different, because objects are different and they are stored in different locations in memory. And the variables my number and my string simply refer to specific objects in memory. They contain pointers to specific objects in memory. Let's have a look at this example, where in memory there is just single object, and different variables point to the same object in memory. It is possible in Python. It is possible that multiple variables refer to the same object in memory. They contain same pointers to the same object in memory. How it might happen? Let's have a look at this example. We create again a variable my number and assign 10 to this variable. And ID of my number will be like that. It is location of this object in memory. If you create one more variable and assign to it my number is this variable, you will get same location of the object in memory. Because here you simply copy a pointer to specific object in memory. It means that object addresses for two different variables, my number and other numbers, are exactly the same. Two different variables point to the same object in memory. And we achieved that by simply copying one variable to another. That's that simple. Later on, we will get back to this topic when we will talk about mutable objects in Python, like lists and dictionaries. But for now, you should keep in mind that each object is stored in memory, and each variable holds just a pointer to specific object in memory. That's it. And when you copy one variable to another, you simply copy just a pointer. You don't copy actual object. If you want to learn how to create games in Python, I welcome you to the full course, where you'll create several games using Pygame package. We already discussed with you some built-in functions as print, input, and dir. And now let's explore in action built-in ID function, which allows you to get ID of any object in Python. And basically, even print is an object. And we could print to the terminal ID of the print object.
Let's run the code, and here I get such a value. Of course, on your computer you'll get completely different number. And let's now create a variable, for example, my name, and here will be my name. And next to it, I'll print to the terminal ID of the my name object, because everything in Python is an object, and this variable is not an exception. My name is an object. It is an instance of the built-in str class. It is a string. Let's run the code, and here I get such ID for this particular object, which holds this string. Next, let's create one more variable, for example, my num, my number, and here will be my favorite number. And let's print ID of the my num. Run the code, and here I get two completely different IDs. Those IDs represent locations of those two objects, my name and my num, in the memory of my computer. Next, let's try to do following. Let's try to copy my num to other num. We create one more variable, other num, and copy to it my num. And let's now print ID of the other num. And see what is the difference between ID of my num and ID of other num after such copy operation. Run the code, and here I get two identical IDs. It means that those variables, my num and other num, hold the same ID. They point to the same location in memory, where this number is basically located. It means that in the memory of my computer, there is only one number, 777, in one place of the memory. But there are two pointers to that number, my num and other num. And this proves that. So IDs of those two variables are the same. Also, it's possible to use comparison operator if you want to compare IDs of two different objects. Let's remove this line of code, and let's remove this line of code, and after assignment of the my num to other num, let's print result of the comparison of ID of my num and two equal signs ID of other num. And how do you think what we'll get here as a result of this expression? Because here is expression. We'll get true, because that is a result of comparison of ID of my num and ID of other num. Results of those two expressions, this one and this one, are the same. That's why when we compare two exactly the same numbers, we'll get true. And that's what we see here in the output. Alright, that was built-in ID function, and this function returns always an integer, and here we see that in function description. Return the identity of an object. And Python is responsible for guaranteeing that different objects have unique IDs. It does that internally. And we ensure that the ID of my name variable and ID of my num variable are different, because those variables contain different values. Here is string and here is integer. And if necessary, you could always compare IDs of two different objects in order to check whether they are equal or not. If they are equal, you'll get true as a result of such expression. Otherwise, you'll get false. Now I want to take some time and talk about such built-in variables, which we saw actually before, and that they are str, int, bool, list, and for example dict. Such built-in variables are used in order to create new instances of specific built-in class. For example, here is built-in class which is called str, and it is used for creation of the strings. And if you hover mouse over str right now, you'll see that it is a class str. And here below you could read that this class is used for creation of the new string objects from the given object. And also it's possible to perform conversion of different values from one type to another using same classes. List is also a built-in class, and if you hover mouse over list, you'll see that as well, class list. And it creates mutable sequence. Alright, now let's check how you could verify whether a specific value is instance of specific class or not. Let's create here, for example, my num. And this value will be my favorite number 777. And next to it, let's print to the terminal type of my num. Let's now run the code. And here in the output, I see that type function returns us a class, which is named int, because this value is basically an object, which is an instance of the built-in int class. And now let's perform following comparison, using comparison operator to equal signs. And here I'll simply type int, and it is name of the built-in class. I don't use here single quotes or double quotes. It is not a string, it is a variable, int. Let's run this code. And here I see true, because type actually returns an object. Here we see that the object's type. And in our example, type of my num is int. And if I add here double quotes like that and run the code, of course I get false, because result of this function call is int. It is name of the variable. It is built-in class int. Now let's do following. Let's simply print to the terminal type of int. Int is again a built-in class for creation of the integer values. Let's run the code, and here I see class type. Anytime when you see such output as class type, it means that specific object, for example int, is a class, and it is used for creation of instances of that class. Let's also check type of other values, and let's copy this line multiple times, and on Windows you could use key combination Ctrl-D, on Mac it is Command-D. And here let's replace int with str. It is also built-in class. Here will be, for instance, bool. Here will be list, and here will be dict. Let's run this code, and here everywhere in the output I see class type. That proves that all those variables represent actually classes, and they are built-in classes for creation of different objects of different types, such as integers, strings, booleans, lists, or dictionaries. There are, of course, other built-in classes, and we will soon discuss them one by one. But now I want you to get an idea of built-in classes, such as int, str, and others. And notice that names here start with lowercase letters. But in fact, all those variables represent classes. And we just verify that with integer as an example. Of course, in Python you could create user-defined classes, and we will do that later in this course as well. And for user-defined classes, you should usually use camel case notation, so start with capital letter. To summarize, you could always use built-in type function in order to check type of a specific variable. And for example, if I put here string, Bogdan, and execute code, I'll get here class str. And I could always use comparison operator here in order to compare result of the type function call with name of specific class. And here I could put str. And if I run the code here, I'll get true, because type of this object is actually string. Built-in class for that is str. And next, let's talk about built-in isinstance function. We just talked about such built-in function as type. And type is useful when you want to check type of a specific object, and the type function returns basically class of specific object, which is used for creation of that object. And there are plenty of built-in classes like str, bool, and others. And now let's discuss one more built-in function, which is called isinstance. And if you hover mouse over this name, you'll see that this built-in function returns whether an object is an instance of a class or not. And let's here call this function, and first argument will be, for example, my favorite number, and second one will be class. And if I type here int, I will check whether this value is an instance of this class. Let's print result to the terminal, print, and run the code. And here I see true. It means that this object is an instance of this built-in class. Similarly, I could perform other check, and here will be, for example, str, and here I'll put quotes, and now here will be string, and here will be int. Let's run the code, and I get true for both checks. It means that this is an instance of the built-in str class, and this is an instance of the built-in int class. Let's do one more check. And I'll copy this line, recap key combination Ctrl-D on Windows and Command-D on Mac. And here, instead of int, I could delete entire word with pressed Alt, button, or Option. And here I'll type object. Object is a root class for all objects in Python. And int or str are subclasses of this class. And let's perform such check. And here on the second line, I get true. So this value, this object, is also instance of the built-in object class. I could perform check for this value as well. Let's type here Bogdan, and I'll copy this line, and here will be object as well. Let's run the code, and everywhere I get true. Because in Python, all objects are instances of the root class, which is called object, from lowercase o. And we could verify that the object is basically a class by printing type of the object. Let's run the code, and here I get class type, which, as you already know, is an indicator that this is a class, and this is a built-in class. Alright, so we checked that this value is actually an instance of int and object classes, and this value is an instance of the str and object classes. In similar way, you could check whether other objects are instances of specific class, either built-in class or user-defined class. And for that, you have to use built-in isinstance function.
Now we start exploring most commonly utilized types and data structures in Python in great details. And we will start with strings. Remember that each string is actually an object, and it is an instance of the built-in str class. And string is just a sequence of characters. Let's have a look at the structure and syntax of the strings. In this example, we create a string and assign it to the variable myName. And string is Bogdan. But you could also utilize double quotes. PEP 8 doesn't have any specific recommendations regarding usage of the quotes. But please be consistent. If you use single quotes, use them everywhere. If you use double quotes, use them everywhere as well. My personal recommendation is double quotes for long strings and single quotes for short strings. And next, in this example, we print value of the variable myName to the terminal, and we see Bogdan in this example. One more example. In this example, we utilize long string, and I put it into double quotes, and we assign such a long string to this variable greeting. And afterwards print greeting to the terminal, and we see here hello from Python. And again, as I mentioned, double quotes are usually used for natural strings, which contain multiple words. Now, how we can verify that actual object is an instance of specific class? For that, we could utilize built-in function which is called type. And here, if we create a string Bogdan and assign it to this variable, we could pass this variable to function type. And in order to see result in the output in the terminal, you have to pass result of this function call to the print function. That's what we will do multiple times in this course. And in this example, you will see in output class str. And this proves that value of this variable is actually an object, and it is an instance of the built-in str class. Also, we could call id function, and in such a way we could find location of the object in the memory. And actually this variable myName holds such pointer to location of the object in memory. And this object, which is string, is immutable, as we discussed before. Strings, integers, are immutable in Python. And each string, as we prove here, is an instance of the built-in str class. Also, it is possible to create multi-line string using 3 double quotes or single quotes. If you create a long string, usually it's a natural string, it's a block of text, and it's common to use 3 double quotes. And here we assign such a value to variable info message. And if you print info message to the terminal, you will see that it will be printed on multiple lines of the output, like this. And all line breaks will be also visible here. That's how you could create multi-line string, using 3 double quotes or 3 single quotes. Let's now have a look at the other built-in functions which you could utilize with strings. And also we will see how you could get specific part of the string. If you want to get quantity of the characters in the string, you could use built-in function which is called len. And in this example, I'll see 6, because there are 6 characters in this string. We can get just first character in the string using square brackets notation. And this means that every character in the string has actual index. Index of the first character is 0, index of second character is 1, and so on. In total, there are 6 different characters, and indexes range from 0 to 5. And if I specify here just one number, for example 0, I'll get first character from this string. It is also possible to specify a range of the indexes. And here I put 2 different numbers, 3:6. And in such case, I'll get symbols from this string, starting from index 3, it is this symbol, D, and till this index. But this index is not included. And it means that in this example I get 3 last characters from this string. That's how we can get a substring or specific character in the string. Because string in Python is actually sequence of characters, and each character has its unique index. Let's have a look at the methods which are available for each string. Because each string is an instance of the str class, in this class there are multiple methods, which are obviously inherited by all instances of the class. And these methods are, for example, upper, replace, count, index, capitalize, lower, and so on. And you could use dot notation in order to access specific method. And for this variable you could write myName dot, then name of the method, for example upper, and then call that method. In such case, function, which is actually available in the class, will be executed for specific instance of the class, for such string in this example. And such method will create actually new instance of the string, new object, and now in that object will be uppercased string. And this happens because in Python, objects like strings are immutable. We cannot modify an object, but we can create new object. That's, for example, what this specific method for strings does. Other methods perform other actions. For example, capitalize makes first letter of each word in the string uppercased. That's it about strings, and now you know that each string is actually an instance of the str class. It is a built-in class in Python. Also, you know that for strings there are many methods available, and all these methods are inherited from the str class, and there are such methods as upper, replace, capitalize, lower, and others. Also, using built-in function len, you could find the length of the string. In other words, quantity of the characters in the string. Also, using square brackets notation, you could access specific character in the string using its index. And also, you could get a substring using range from specific index to specific index. And you have to separate such index numbers using colon and put them between square brackets. That's basics about strings in Python. Now let's explore strings in Python on practice, even though we already used strings in Python multiple times before in this course. And let's define a variable called long_str, and the value for this variable will be in double quotes, and here I'll write this is a very long string. And below let's print to the terminal long_str. And also let's print type of the long_str, and let's also print ID of the long_str. Let's run the code, and here I get following results. I get string itself. I see that the type of long_str is class str, and also I get ID, which is location of this particular object, this particular string in the memory. Also here I could perform comparison of the type function call with specific class, and I could check whether type of long_str is equal to str. Here, recap, I type str without double quotes or single quotes. It is built-in class in Python. And if I run the code, definitely I'll get here true, because type of long string is string. Now let's try to modify this string, and let's, instead of double quotes, use single quotes here and there. As I mentioned before, for strings in Python, it doesn't matter which quotes you use. You could use either double quotes or single quotes. Let's run the code, and there are no errors, and I still get this is a very long string here in the output. But I prefer to use double quotes for long strings, but that's matter of choice. But what if a string here will be, for example, following? It's a great day today. And here will be closing single quote. So here is opening quote and here is closing quote. And there is also quote inside of the string. In such case, I'll get an error here. Unresolved reference great in this example. But this means that actually formatting of this string is wrong. And if there is a quote in string itself, you have to use either double quotes here. Here will be closing double quote and here will be opening double quote. In such case, there will be no error. So you are allowed to use single quotes in case your string is embedded into double quotes. There is no error in this case. But what if you want to stick to single quotes here and leave single quote here? In such case, you have to use escape character, which is \, in Python. In such case, this string will be completely valid.
And if I run the code, I'll see such a string here in the output and no errors. It's a great day today. That's how you could escape different characters in strings in Python. But what if string which you create is really long and you want to split it to multiple lines for better readability in the code itself? For example, let's get back to the string. This is a very long string. And let's try to split it to multiple lines, for example here. And if I do that in PyCharm, it will automatically add backslash, and here technically will be two different strings, this one and this one. And if I run the code, I'll get following output. This is a very long string, everything on one line. I could split the line here again here backslash was added. Let's run the code again, and I get exactly the same result. This is a very long string, without any line breaks. It means that using backslash here, you could split a string into multiple lines, and idents here are not taken into account. And that's nice because now parts of the string are located underneath each other. So it's good to read such a string. And you could use backslashes in order to split specific string to multiple lines. And that works basically with double quotes and single quotes. So here I could put single quote, and this double quote was replaced with single quote automatically. And result will be exactly the same. This is a very long string. So that's first option, to split long string into multiple lines of code for better readability. Because according to PEP8 document, which we discussed already before, there is a recommendation not to exceed 70 line characters as a length of each line of code. And if I write here a very long string, let's do that. This is a very, let me copy this and paste here multiple times, very multiple times, and here will be long string. And notice here this vertical line, and this string is already underlined. And basically here I get following error, line too long. And here the limit is set as 120 characters. But if you check PEP8 document, you'll basically find there are 79 characters as a recommendation regarding line length. We could quickly check that together, and here let's find PEP8 document, line length. And here I see 79 characters. And if I go directly to PEP8 document, I'll basically will be able to find same information, 79 characters. Limit all lines to a maximum of 79 characters. So that's the recommendation. Let's try to find here 120, and there is no mention about 120 characters as a line length. So you have to stick to 79 characters. And in PyCharm this limit is a bit bigger. So if I try to run this code, let's do that. This file was automatically saved, but it was not automatically formatted for us. I still see this warning. PEP8 line is too long. And you have to format this line yourself if you want to adhere to recommendations of the PEP8 document. And you could either do like we did before, like that, and there is no more warning, or you could use 3 double quotes or 3 single quotes. Let's do that together, and here I'll replace single double quote with 3 double quotes. Let's count them, 3 opening and 3 closing. And now we could split this string to different lines. And notice that backslash is not added here. So let's split that like this. And if I run the code right now, I'll see such string in the output. And now here line breaks are kept. So here is line break and here it remained. And this space is this space from this string. And if I attempt to add here tabs in order to format string nicely, like that, for example. And if I add here tabs as well and run the code, I'll see that those tabs are kept in actual string. So here are those tabs. This means that this formatting is kept and you are not able to format this multi-line string like that. And in my opinion, 3 double quotes are not convenient if you want to make a string more readable. So I prefer to use previous approach with backslash. But if you want to keep line breaks, for example here or here or here, you should use such approach with 3 double quotes or 3 single quotes. So here could be 3 single quotes, and let's check and replace double quotes with single quotes here. So that's not a mistake. But if we want such formatted string, we have to remove those tabs. And now, of course, readability of this string is not as nice as it was with backslashes. Because now here there is no indentation, just spaces if we need such spaces here. Let's run the code and we will see such multi-line string, with all formatting kept in place. And usually such long strings with single quotes or double quotes are used as a doc string. Let's get back to double quotes here and here. And we will discuss what is docstring a bit later, but using docstrings you could describe functions, classes or modules in Python. And for now that's it about strings, formatting of strings and different approaches of using single quotes, double quotes and 3 pairs of double quotes or single quotes in strings in Python. But of course any such value is an object which is an instance of the built-in str class. And here we verify that. As you already know, each entity in Python is basically an object. And each object is instance of specific class. And the strings are not exceptions. Each string is an instance of the built-in str class. And therefore each string has access to different methods which are defined on the class level. And those methods are inherited by each instance of the built-in str class. And let's now explore that on practice. Let's create a variable and let's name it my comment, and its value will be following. This is my short comment. And below let's first use built-in len function. Let's print result of the len function call, and if you have a look at the description of the built-in len function, you'll see that this function returns number of items in a container. And basically len is used to check length of any sequence in Python. And string is also a sequence in Python. And let's here call built-in len function and pass to it my comment as an argument. And let's see length of this string, and length is 24. So this string consists of 24 different characters, including spaces. And now let's try to access methods of the myComment object, which is an instance of the str class. For that you have to simply type myComment and then add dot. And if I add dot, I could access any attribute of this particular object. And if attribute contains a function, such attribute is called a method. And here you'll see m letter near the name of specific attribute, which is an indicator that this is a method. Find, join, count, index are methods which are available for all strings. And if I scroll down the list, you'll see many other methods available. And let's, for example, use such method as replace. Let's select it here in this drop-down list. And here we see which arguments are expected from us. Old string and new string. And let's say that we want to replace short with long here. And in such case, first argument here will be short, and second argument will be long. And let's after that below print my comment. And also let's print my comment here after first line. So we print my comment twice, here and here. Let's see results, let's run the code. And here I see in both cases this is my short comment, here and here. But we replaced actually short with long. What happened? In fact, this replace method does not modify existing string. And if you hover mouse over replace here, you'll see that it returns a copy with all occurrences of substring old replaced by new. And it means that if you want to get result of the replace method call, you have to assign it to the variable. And if you want, you could create a new variable, for example, long comment. And then here, instead of my comment, will be long comment. Let's run the code. And now I see here new string, where short was replaced with long. And here we have two different variables. One is my comment and another is long comment. And after this method call, original variable, my comment, was not modified. So replace doesn't modify existing string. But if you want, you could assign result of the replace method call to the same variable, my comment. And here will be my comment as well. Because reassignment of the value is allowed in Python because of dynamic nature of Python. And if I run the code now, I'll see here original value from this variable my comment, and now here I see new value for the same variable my comment. And that's completely fine. We replaced short with long and assigned new value to the same variable. Now let's try in action other built-in methods, and here I'll remove this part, and here I'll again access all attributes of the myComment object, and let's use this count method. Let's select it, and let's see what it does. And it counts number of non-overlapping occurrences of substring in string. And here we could, for example, count quantity of spaces in this string. And in such case, I will simply put here space in single quotes or double quotes. And let's print result of count method call to the terminal and see how many spaces there are in this string. And there are 4 spaces. We could also count other substrings. For example, here instead of space could be is. Let's run the code, and here I get 2. Because this is first is and here is second is. So is appears here in the string twice. Also, it is possible to access specific character in the string by its index. For that, you have to utilize square brackets notation. Write my comment, then put pair of square brackets, and here could be index of any character. For example, let's put here index 4. If I run the code, I get here space, because here is this exact character. Let's replace 4 with 5, and let's run the code, and now I get I, which is this I. Also, using square brackets notation is possible to get substring of this string, and for that you have to utilize colon, and put here, for example, 2, 7. Let's run the code, and I get such substring of this string. And we get characters from index 2, which is inclusive, because index of the first character is 0, index of second character is 1, index of I here is 2. Then 3, 4, 5, 6, 7. But here I got is without this space. Let's basically replace 7 with 9 in order to see the difference. And here I get is m. So it means that this last number is not inclusive. So we get substring from index 2 inclusive to 9 non-inclusive. And also it's possible to omit one of those numbers. And if I remove 9 like that, I'll get substring starting from the index 2. So this section of the string. Similarly, you could write here colon, and here will be, for example, 10. Let's run the code, and I get first 10 characters. Also, it's possible to use negative numbers here. And -1 is index of the last character here. Let's run the code, and I basically get entire string except just one last character. So this number is not inclusive. Also, you could use other negative numbers, for example, -10. Run the code, and I get such substring. For example, here could be 3, and here could be -10. We could count either from start or from end of the string. Let's run such code, and I get such substring. That's square bracket notation, and you could use it in order to get a specific character by its index if you put here only one number, or you could get range of characters, for example, from 3 to 7. Let's have a look at some other methods for strings, and for that let's again add here dot, and let's, for example, find something in the string. Let's select find, and here let's write, for example, short as a string. Let's run the code, and we get 11, which, as you might guess, is index of this substring in this string. So it's index of this character. It shows us where such substring starts in this string. But what if substring is absent in this string? And instead of short, let's put here, for example, long. Let's run the code, and in such case result will be -1. So if specific substring is absent in the string, you'll get always -1. And in your programs you could use find method for strings and compare result with -1. If it is equal to -1, it means that specific substring is absent in the string. So if I add here comparison operator and put here -1, I'll get true. It means that such substring is absent in this string. That was find method, and also there are many other methods available. Let's put here dot, and let's scroll down the list, and let's, for example, have a look at split method. Let's select it, and if we look at the documentation for this method, it will show us that it returns a list of the substrings in the string. And let's assume that we want to split this string by spaces, and we want to get all separate words from this string. And in such case, we have to call split method and pass to it string with just single space. Let's see what we get. And we get a list. So those square brackets indicate that it is a list. And this list contains all separate words from this string. And afterwards, if you want, you could perform different actions with such words. For example, you could iterate over such list, because each sequence supports iteration. Alright, let's now check how we could make this string in uppercase, and for that there is a method which is called upper, and we could call it without arguments, and if we run such code, we'll see this is my short command, all uppercase. Also there is lower method. Let's run the code, and I now get this string with all lowercase letters. This is my short command. These are few of the methods available for strings, but as you saw, there are many other methods available. Here is a long list. And all those methods are inherited from the built-in str class. If you want, you could always get list of names of all attributes of particular object. And for that, if you remember, there is a built-in dir function. And in the dir function call, you have to simply pass name of specific variable. And if we run the code, we'll get such long list. Let's wrap it to see all names of the attributes. And some of them have 2 underscores in front and at the end. We will discuss what is that later. Those methods are called magic methods. And below there are other regular methods such as isUpper, join, partition, replace, and we already used some of those methods available for strings. That's all about methods for strings, and if you want, you could also try some other methods yourself.
Let's move on, and now let's talk about strings concatenation, how it is performed in Python. In order to concatenate two different strings, you could use plus operator in Python. And if you do that for such strings as hello space and Python, you will get a string hello Python. Very easy. You could, of course, utilize variables in the strings concatenation process, and if you have two variables hello and world, and before you have assigned such strings to those variables, like hello and world, you could utilize variable names here and utilize also plus operator. And of course here we add a space between two different words, and afterwards when you print value of the greeting variable, you'll get hello space world. That's how you could concatenate strings in Python. And here we just added space between two different words. You could say that such process is not really convenient, because we have to use plus operator twice, and if you want to create a longer string based on, let's say, 4 or 5 different variables, it is not a good approach to utilize plus operator, because it's very easy to make a mistake. That's why there is a feature in Python which is called string formatting, and instead of plus operator, you could use f strings. And the f string starts with letter f, then double quotes or single quotes, and here you could write different Python expressions in curly braces. And this feature is called f strings in Python. There are, of course, other methods for formatting strings, but this way is the easiest in my opinion, and it is most commonly utilized. So here, where you want to put an expression, you need to add curly braces, and here are two different expressions. We simply utilize values of the variables hello and world, and here is space. And the result will be the same, so we will see in the output hello world. That's how you could use string formatting, and I recommend this feature instead of plus operator. Of course, if you have to combine just two strings, it's normal to go just with plus operator. But for longer strings, use f strings in Python. And certainly you could utilize any expression you like. For instance, you could call even a function, or you could use expressions with operators such as greater than, less than, equal, and so on. Any expression could be used between curly braces in f string. And you could use as many expressions as you like. That's all about strings formatting, and you could format strings using f strings, or you could use plus operator. Plus operator creates a new string based on other strings. That's it about strings formatting in Python.
Let's now in practice have a look on strings concatenation, and let's first use plus operator for that. And let's create several variables like my name, and its value will be Bogdan. Then let's create variable my hobby, and my hobby is running. And let's say that I like running at 8 o'clock in the morning. And here will be one more variable time, and its value is 8. And now I would like to construct a string. Bogdan likes running at 8 o'clock. And for that, let's utilize plus operator. And let's create a new variable, let's say info. And here I will use plus operator and such variables as my name, my hobby, and time. Let's start. My name plus, then here will be string, space, likes, then again space, then plus my hobby. We'll get Bogdan likes running, plus, Here will be again string, space, add, space, then again plus, then I would like to insert time. Let's write here time, then plus, and here will be o'clock in the morning, or simply o'clock, at 8 o'clock. Therefore, here I'll add string and type here o'clock. But if I type o'clock with single quote and also use single quote here, then here definitely I'll get an error. Therefore, there are two options. Either escape single quote here and close this opening quote here like that, so this is a valid expression, or use here double quotes. And then I could keep single quote inside. Both ways work. And don't pay attention on those underlines right now. And here let's try to print info to the terminal. So again, here in this expression, we used plus operator. And plus operator allows us to concatenate different strings. And you could use strings and variables which hold strings. For example, my name holds string Bogdan. And we expect to get string Bogdan likes running at 8 o'clock. Let's run the code and see what happens. And now here I get type error. Can only concatenate str, not int to str. And this mistake appears on this place. Here you see this caret sign. It is an indicator where exactly error happens. And if you hover mouse over time here, you'll basically see this error as well. Expected type str got int instead. It means that when you form a string like this, you have to use only strings with plus operator. But here is integer value. That's why in order to get rid of error and get correct result, we have to convert time from integer to string. We could do that actually here, type simply 8 as a string, or we could keep integer here, but call here built-in str function. Str is actually a built-in class which creates new instances of the str class. It creates strings. Therefore, now this warning is gone. And if I run the code, I'll get desired string, but here is one space missing. That's why I should add it here, before O, in this string, o'clock. Let's run the code again, and now I see correct result. Bogdan likes running at 8 o'clock, and there are no errors anymore. That's the first way how we could combine different strings together using plus operator. But you will agree with me if I say that such approach is not really convenient, because here we have to take care about those spaces, and notice that I actually just made an error, not intentionally. I forgot about this space here in front of o'clock. And therefore, such formatting is not the best way to create new strings from other strings and variables, like we do in this example. But if you need to combine just two strings in one string, then plus operator is quick and easy. And now let's do the same, let's create new string, but using f-strings syntax in Python. And in the f-strings you don't need to use plus operator. Let me comment out this line and let me create info variable again. And here we will use f-string. And you could use either single quotes or double quotes here, up to you. I'll use double quotes because inside of the string itself there will be single quote here. And in the f-string you could use different expressions. And if you want to insert a specific expression, you have to use pair of curly braces. And here will be my name, it's name of the variable, then space, likes, space, then pair of curly braces, my hobby, then again space, add, space, then we have to put time, and let's add here also str of time, like we did here. Then let's add space and type here o'clock. Let's run the code, and result is the same as before. Bogdan likes running at 8 o'clock. But now we achieved such result using f-string in Python. And here are three expressions. First one, second one, and third one. And you will agree with me if I say that such syntax is much cleaner and much easier than such syntax with plus operator. And this expression is much longer than this expression. And of course, I recommend to you to use f-strings instead of plus operator if you need to combine multiple expressions just in one string. And more than that, you don't need to convert integer, for example, to string explicitly as we do here and as we must do here when we use plus operator. If I remove this from here and keep simply time, which holds an integer here, and run the code, I will get no errors. Because Python now tries to convert to string this value itself. And it was successful, and therefore there is no error. But what if here is, for example, a list of two elements? Let's run the code. I will see that list was also converted to string. No issues at all. Therefore, when you work with f-strings in Python, you could use different value types, not necessarily strings, on places where Python expects from you an expression. And of course, here, here, or here could be any expression. And if you want, even a function call, if you need to insert into the string result of specific function call. That is f-string. And actually in Python there are also other possible ways to format a string, but this one is obviously most popular. But let me demonstrate you also other ways to create a string. And I'll add here also other options. And here will be option with format method of the strings. I'll use the same variable info here. And next I have to use regular string syntax. Double quotes or single quotes. Then here I will put simply a pair of curly braces like that, and they will be empty, so nothing here inside. Then likes, then again pair of curly braces like that, then space, add, space, again pair of curly braces, space, clock. So same as we wrote here, but without actual values in curly braces. So keep them empty like that. Then add dot and call format method of the string. If you hover mouse over this method, you could read about it in the description. Format returns a string, and it returns formatted version of string using substitutions from args and kwargs. Therefore, in this method call, we are able to supply values for those empty spots. There are three empty spots, this one, and this one. Therefore, we have to supply here three arguments. My name, comma, my hobby, and time. Three values for different places. This one, and this one. And let's again print info to the terminal, like we did before. Let's run the code, and I get exactly the same string. Bogdan likes running at 8 o'clock. And for that we used strings format method. Here we call such a method. And idea is very simple here. We add here actually placeholders for different values. And expressions for those values we supply in the format method call. But again, you should agree with me that such f-string syntax is much easier and more convenient to use than this format method call. Also, there is one more old-fashioned, old-styled method of the strings formatting, which is called string interpolation. And let's use it here just for informational purposes. I don't recommend to use it anyways, but let's create such a string. And here, where we used curly braces in the previous case, we will put following: %s, then likes, again %s, add, %s, clock. Then, after end of the string, we will add space, %, And here in round braces I'll put names of the variables: my name, my hobby, and time. And let's print to the terminal value of the info. Let's run the code, and here I get exactly the same result. Bogdan likes running at 8 o'clock. But that's old-fashioned way to format strings in Python. Therefore, here you see three approaches how you could create new string based on different expressions. And I recommend to you to use f-strings everywhere. It is the most easiest and obviously the shortest way to create new strings. Compare the lengths of 4 different options. This one is the shortest. And you know that here, where Python expects from you expressions, you could basically use different value types, not necessarily strings, as results of the expressions. But here, when you use plus operator, you have to explicitly convert all values to string in order to get result correctly without errors. So that wraps up different strings formatting techniques, and I recommend to you to use this one, and don't use any others. This is called f-string in Python, and here you could put string into double quotes or single quotes.
We just talked about strings, and now let's move on to the next type in Python, which is called integer. And every number which doesn't have decimal part is an integer, and each integer is actually instance of the built-in int class. Let's have a look at the structure and syntax of the integers. Here you see integer number 50, which is assigned to the variable friends quantity. And if you print to the terminal type of the variable friends quantity, you will see class int, which proves that this value, this object, is an instance of the built-in int class. Also, you could prompt user to enter a number, but as we discussed before, any input which is entered by the user from the keyboard is treated as a string. And that's why if you print type of any num which you entered after this prompt, you will see actually string str. And if you want to use value of the any num as integer, you have to perform conversion from string to integer. How this could be accomplished? Using built-in function which is called int. We prompt user to enter a number, then user enters, for example, 10, 50. After that, we try to convert this value to integer. If conversion was successful, we assign integer to this variable, any num. And afterwards, if we print any num to the terminal, you will see specific number. And now type of the any num will be obviously int, not str. And in such way, we converted string to integer. Also, it's possible to get rid of additional variable and perform the same task just on the same line. We get input from the user, and then result is passed to the int function. And we assign result of the conversion of the string to int to variable any num. And these outputs will be the same as before. So we convert result which is returned by the input function. Now let's have a look at this example where we utilize built-in pow function. Pow function allows you to bring specific integer number to specific power. And if base here is 5 and power is 3, we get 125. So 5 to power of 3 is 125. Also, it's possible to use 2 stars operator for the same purpose, base 2 stars power, and you will get the same result, 125. So, to these expressions, call to function pow or usage of the 2 stars operator are exactly the same. They produce the same result. Also, if you work with long numbers like millions, thousands, it is possible to split numbers using underscores. So such numbers are completely valid integers in Python. And you could add underscores where you want, and usually if you use, for example, 1 million or other number, you add underscores between thousands. And here, in this case, you could add underscore after 3. And such approach just makes numbers more readable. That's it about numbers, and basically with integers in Python you could perform different arithmetic operations like multiplication, division, subtraction, addition and others. Also, there are built-in and external modules which allow to perform more mathematical operations with numbers in Python.
Let's now see what we can do with integers in Python. And let's create a variable mynum, and its value will be, let's say, 1000. And here let's type mynum and add dot. And here, as usually, you'll see names of attributes which are available for this particular object. And there are not so many methods available for integers as for strings, and here you could find such methods as bitCount, bitlength, conjugate and some others. But we will not use any methods right now for integers, because usually different mathematical operations are performed with integers. And for example, if here is other num and its value is, for instance, 100, you could, for example, sum mynum using plus operator, so mynum plus other num, and assign result to the variable res. And let's print res to the terminal. And here in the output we'll see 1100. And also it's possible to divide numbers. For instance, you could add here divide operator, or you could add here multiplication operator, or you could deduct other num from mynum. And now you'll get 900 as a result. Also, you could use numbers in many other mathematical operations. Also, it's possible to use negative numbers like minus 100, and if here will be plus operator, we'll get again 900 here as a result of such operation. And also it's possible to use underscores if you want to highlight parts of the number. For example, you have such a long integer. And you could add underscores here between thousands, and that's completely valid syntax in Python. And here will be, for example, 1000. Let's perform some operation again, and we'll get such a number without any underscores. So you could use underscores to distinguish parts of a particular number if you want to make number more readable, but you are not allowed to use two underscores, one after previous. In such case, you'll get an error. And the error will be syntax error specifically, invalid decimal literal in this example. But such syntax is completely valid when you work with integers in Python. But please notice that if you use divide operator here and run the code, you'll get a float number as a result of operation. And we'll talk about floats very soon. Also, I would like to mention that you should be cautious when you work with numbers and use input function. Because, as you already know, input function always returns a string. So let's add here prompt, enter any number, colon, space, and let's assign result to the variable input str to highlight that it is a string. And let's print here type of input str. Let's run the code, and here let's enter any number, for instance 10, and as expected here we see class str. And if you want to convert string to integer, you have to use built-in int class, and if you call int like that, you basically create a new instance of the built-in int class, and Under the hood, Python actually calls init magic method, which is a method of the int class. We will get back to that later. But int allows you to create a new instance of the int class. And here we have to pass input str as argument. And now we could assign result to input num variable. And afterwards, let's print type of the input num. And we expect to see int. Let's run the code, let's enter a number. First we see class str, and after conversion to int, we see class int. So now this object holds an integer as a value. But what will happen if we enter, for example, a string instead of number here? Let's try to run the program again. Enter any number, I'll type ABC. And now here I get value error, invalid literal for int with base 10. And error happened on the line where we attempt to convert string to integer using built-in int class. And such error will happen anytime when Python will not be able to convert a specific value, for instance, to integer. And it's possible to handle such errors using try-except blocks. And we will talk about try-except a bit later, but now I would like to show that quickly to you. We could add here try, colon, and then add here indentation, and afterwards we will add except value error. And after colon, we could, for example, print following notification message to the terminal, not able to convert to int. And also we have to move this last line to try block as well, and for that you could use key combination Ctrl-Shift up or down arrow on Windows or Command-Shift up down on Mac, like that. So I moved print type input num to try block. And if I run this code now and enter any number as ABC, so I make mistake here, and now I will see no error here in the output, and process finished with exit code 0, and here I see this message, not able to convert to int. And that means that now we correctly handle error, which might happen if user enters not a number, but something else, and Python is not able to convert user input to integer. That's how we could handle that. But again, we will get back to try-except blocks later in this course and discuss in details how you could handle different types of errors. In this example, we get value error because of incorrect value which is passed as argument in the int function call. And now let's run the program again and enter valid number which we will be able to convert to int. Let's run the code and let's enter my favorite number. And here we see no error, and we also don't see this string not able to convert to int because there was no value error here in the try block. And we also see result of this print function call here. It means that Python was capable of converting input str to int using built-in int class. If you want to learn how to create web applications using Django Web Development Python framework, I welcome you to the complete Python course, which is more than 50 hours long. Now let's talk about other built-in class in Python, which is called float. And based on this class, you could create numbers with decimal points in Python. Let's have a look at the structure and syntax of the decimal numbers. In this example, we create a number 17.25 and assign this number to the variable average price. If you print value of this variable to the terminal, you will see 17.25. And the type of this variable is float. This means that average price is an instance of the built-in class which is called float. But what if you have float number and you want to create an integer number from it? It is possible to do using built-in int function. And here we have a float number, and
in order to convert it to integer number, we could simply call built-in int function like that. And here on this line, you'll get 28 as a value for price variable. And type of the price will be integer. Also here you see that there is a string 14.5. For instance, we got such a value from database or from user input, and now you need to convert such string to float. For that you could use built-in function float and simply pass variable str temperature to this function. Basically, float, int, and other built-in functions related to different objects create specific instance of the class. Because you know that int, float are actually built-in classes in Python. And here we simply create new instances of corresponding classes. Here we also create an instance of the string, but we use double quotes or single quotes notation. But you could achieve the same result simply writing str function call, and there will be 14.5. So here, after conversion of the string to float, you will see 14.5 as a value of the temperature, and type of this variable will be float. We converted a string to float. And in case you need that, you could also convert, for instance, Boolean to integer, integer to decimal, and so on and so forth. So it is possible to perform different types conversions in Python. And for that you have to utilize corresponding built-in classes like int, float, bool, and others. And such conversion is called explicit conversion. You perform conversion explicitly specifying specific class. And Python actually doesn't perform implicit type conversion. It cannot convert, for example, string to integer or string to decimal without actual call to corresponding built-in function. Let's have a look at the rounding of numbers. If you have a decimal number like that, 17.25, you could call built-in round function in order to round this number to 17 in this example. Round rounds a number to nearest integer. And if you have, for example, such number 0.78, then round will return 1. It is nearest integer number. And the type of the value which is returned by the built-in round function is integer. Here we see that. So we round decimal number, float number to nearest integer. And that's it about decimal numbers. And they could be easily converted to integers, or you could, for example, make a decimal number from string. To summarize, there is a built-in float class, and using this class you could create numbers with a decimal point. And you could, of course, perform different mathematical operations with such numbers, and if needed, you could convert float number to integer, or for instance, make float number from the string. That's all about decimal numbers in Python. Let's see now on practice what we could do with float numbers in Python. And let's create here a variable, for example, average rating, and its value will be, for instance, 4.85. And here you see float number, and let's first print to the terminal type of the average rating. Let's run the code, and here, as expected, we see that this object, this one, is an instance of the built-in float class. Let's see which methods are available for average rating object. Average rating dot, and here are several methods, and one of them is integer. Let's call this method and see what it returns as. Let's run the code, and here I see false.
It means that isinteger checks whether this specific float number could be converted directly to integer. In other words, whether it has decimal part or not. In this example, this number has decimal part. But if we make average rating, for instance, from .00 and then run the code, we'll see true. Because this value is basically an integer but represented as float number. So that's one of the methods available for float numbers in Python. Of course, you could perform different mathematical operations with float numbers in Python. And let's do, for example, following. Let's try to round this number, which is, for instance, 4.35, to integer. And for that, we could utilize built-in round function. And let's immediately print result to the terminal. So let's call round function like that. It is not a method of the float object, it is built-in function. And here let's pass average rating as argument. And let's see what we get. We get here 4. So this float number was rounded to closest integer. If float number is, for instance, 4.65, let's run the code, we'll see 5. That's how round works. It rounds to nearest integer value. Also, it's possible to convert any float number to integer using built-in int function. And here let me add a comment. So in case we use round function, we get 5 because we round to nearest integer. But if we use built-in int class and create new object like this, so here will be average rating and print result, we'll get 4. Because now we don't round a number and we simply remove decimal part, like that. And vice versa, we could convert any integer to float if you need to do so. Let's do that, print float, and here will be, for instance, integer 100. Let's see what we get, and we get 100.0. So that's a float number. Let me add it here as a comment. And also let me add comment here, because in case average rating is like that, isinteger method will return false. That's some operations which you could perform with float numbers in Python.
In Python, you could also work with complex numbers. And complex numbers are utilized in different data science calculations and in different mathematical operations. So, complex number consists of two parts, and the first part is called real part, and the second part is called imaginary part. Let's have a look at the example. Here we have two different complex numbers, complex A and complex B, and in this number, real part is here and imaginary part is here. You could add here spaces, or you could write a complex number without spaces. Simply 3 plus 5j. Same applies to another complex number. Real part is 4 and imaginary part is 7. And it is possible to perform different mathematical operations with complex numbers, and here is the most easy task. It is addition of two complex numbers, and in this case we add 3 to 4 and add 5 to 7, and we get such result. 7 plus 12j. 7 is real part and 12 is imaginary part. And type of the variable sum is complex. It's name of the built-in Python class for complex numbers. You could, of course, perform other operations with complex numbers, not only addition. Now let's discuss Boolean type, and corresponding class is called bool. And there are just two possible values, true and false. And in Python, true and false are written starting from the uppercase letter. And here we create a variable which is called isAuthorized, and we assign value true to this variable. And when we print such variable, we will see true in the output. And type of this variable is bool, boolean. And my recommendation to you, when you create variables which hold boolean values, you should name them accordingly. For instance, variable name isAuthorized says that it is expected to have a boolean value as a value of this variable. So, each logical value is an instance of the boolean class, and there are just two possible values, true and false. Also, bool is often used to check whether specific expression is truthy or falsy. How is it performed? For instance, if we have an expression 100 greater than 24. This number is greater than this one, that's why this expression is evaluated to the boolean value true. If we look at this expression -5 greater than 0, then we get false, because this expression is falsy. -5 is less than 0. That's why here we get false. And with numbers, it's relatively easy to understand and predict result. But what if we, for instance, compare two different strings, such string and such string? And we use for that greater than operator. And in this example, result of this expression will be true. Why is that? Because this string starts with long, and here we also have long. And this string has other characters. And this means that basically this string is substring of this longer string. And in this case, Python will return true as a result of such expression. If here will be short string and here long, then result will be false. Next example shows how to compare two lists. We have not yet talked about lists in details, but here we see two exactly the same lists. They have same quantity of elements, 3, and all elements are the same, 1, 2, 3, and order of the elements is the same. That's why if you use comparison operator, two equal signs, Python will return true as a result of this expression, because those two lists are the same in terms of Python, even though those lists are two different objects. We will get back to that a bit later. So here you see that results of different expressions with comparison operators, like greater than, equal, or less than, is a Boolean value, either true or false. Also, you could perform conversion of any value to Boolean value using built-in function bool. And that is the name of the built-in bool class. And you could pass here actually any variable with any value. And using such approach, you could evaluate whether specific value is truthy or falsy. And similar operation is done by Python internally when you utilize, for instance, if statement. It takes expression and under the hood converts it to Boolean. And if result is true, then block inside of the if statement is executed. Otherwise, we go to next lines of code. That's all about Boolean values, and each Boolean value is an object which is instance of the built-in bool class. In Python, Boolean values are utilized very often. And for example, result of a comparison of any pair of objects is always true or false. Also, there are falsy or truthy values in Python. And for instance, any empty sequence is falsy, any non-empty sequence is truthy. And we will talk about that in details soon. But now let's create a variable
For example, let's call it db is available, and its value, let's assume, is false. And notice how I've chosen name for this particular variable. From its name, it's immediately clear that its value is Boolean, either true or false. I don't write name like that, available. And I don't use this variable name without is. So, db is available, true or false, or is authenticated, are connected, and so on. Those names are good names for variables which contain Boolean value. Let's now print db is available to the terminal, and also let's print type of the db is available. Let's run the code, and we see here false, its value of this variable, and also type of the db is available variable is obviously bool. It's an instance of the built-in bool class. And we could verify that by using isinstance function, and here will be db is available, and next argument will be obviously bool, without single quotes or double quotes. We put name of the built-in class, bool. Let's run the code, and here we see true. So db is available is an instance of the built-in bool class. Of course, if needed, we could assign another value to the db is available variable using assignment operator, and let's assume that at this moment this variable should have value true. And afterwards, if we print value of the db is available variable, we will obviously get true. Now let's see how we could convert values of other types to Boolean. Let's remove this, and here let's print to the terminal result of following expression, bool, and here will be, for instance, number 10. Let's run the code, and here we see true. So if number 10 is converted to Boolean using built-in bool class, we get true. But what if we convert to Boolean value 0? And let's see also what we get if we convert 0.0, it's float number, and this is integer. Let's run the code, and we get false for both cases. So here is false, and here is false as well. And here is true. It means that such numbers as 0 and 0.0 are treated as falsy values, because they are converted to false if you explicitly use bool function. And now let's, for example, convert to Boolean non-empty string, for example, ABC. I assume you guessed the result, it is obviously true. And if we convert to Boolean empty string, let's do that, we expect to get false. And yes, here is false. Let's add here comment false. So if you convert any non-Boolean value to Boolean, you will get either true or false. And if result is true, then specific value is called truthy value. Otherwise, like in this case or this case or this case, value is considered as falsy. Now let's see results of the expressions where we use comparison operators. And let's print, for example, result of the expression 100 greater than 50. Let's run the code, and we obviously get here true, because 100 indeed is greater than 50. But if we compare 100 and 50 using comparison operator like that, we'll get false, because 100 is not equal to 50. Let's now compare, for example, two lists. List with elements 1, 2, 3, and list with elements 1, 2, 3, 4. Let's run the code, and here we get false, because this list is different from this list. Let's now copy this line, and I'll remove last element from this list. Let's execute code now, and here we get true, because this list is equal to this list. Length is the same, and the elements are the same in both lists. But by the way, those lists are actually two different objects. But Python is capable of comparison of different lists, as we see here. We will discuss soon how exactly Python performs such a comparison. But key idea here is that anytime when you use comparison operators like greater than, equal or less than, you'll get Boolean value, true or false. Also, there is one more operator which always returns either true or false, and this operator is not. Let's create a variable, for example, is available, and its value will be, for instance, true. And here let's print to the terminal not is available. So not is prefix text operator. If we run the code, here we get false. It's opposite to this value. Also on this place could be object of any other type, like string, for instance, or integer or any other value. Also, Python evaluates whether a specific expression is truthy or falsy in the if statements. And here we could create if statement, and condition will be is available. And if is available, we could print to the terminal text is available. Let's run the code, and here we will see is available at the end, because this condition is truthy, and basically value of this variable is directly true. But here could be also other value type. For instance, here will be, let's say, my name, and here will be my name, and I could add here AND operator and add here my name. So here is expression in the if statement, if is available and my name. And if I execute code now, I get is available, because result of this condition is basically truthy. But if I take this expression and simply print result of such expression to the terminal, print is available and my name, what I get? I get my name. It is a result of the second operand here in this expression. And we will discuss in details such operators as AND or NOT a bit later in separate section, but here you see that result of such expression is not true or false. It is string. In this example, Bogdan. But Python under the hood converts a result of this expression to Boolean. It does following: bool and passes to it result of this expression. You could do that explicitly, but there is no need to do that. Python does that automatically. So here, same as before, we get is available. So Python performs conversion of the result of expression, for example, in the if statement, to Boolean value automatically. Alright, that was built-in bool class with just two different values, true and false, and Boolean is a very widely utilized type. And for example, result of any comparison is either true or false, as we checked here. Also, under the hood, Python implicitly converts results of some expressions to Boolean. For example, it happens in the if statements.
Now we came to the very interesting topic, and we will talk now about conversion of types in Python. And we will start with the fact that Python does not implicitly convert value types. Python doesn't perform any types conversion itself. You have to do that explicitly. And for that there are many built-in functions for explicit conversion. And you already know some of those functions, and they are str for conversion to string, float for conversion to float number, tuple for creation to tuple. We haven't yet talked about tuples, but we will get to them very soon. Int for conversion to integer, list for conversion to list, and set for conversion to sets. We will also talk about sets in the separate section. There are also other built-in functions for conversion to specific types. And what each function actually does, it creates new instance of specific class. Because all these functions are actually built-in classes, str, float, tuple, and others. And each function is used to create new instance of the class. And if you have specific variable and you pass that variable to any of those functions, you don't modify variable itself, because you get completely new object, which is returned by one of these functions. Okay, let's now have a look at such expression. We add string 10 and number 5. 5 here is integer. What will be result of such operation? How do you think? We will get error, type error, and error tells that we can only concatenate string to string. We cannot concatenate string to integer. This code would work, for instance, in JavaScript, but in Python you will get such type error. And if you modify order of the operands here in this expression and write first integer 5 and then string 10, what do you get? How do you think? Again type error. But other type error, unsupported operand type for plus, int and str. So depending on the order of the operands in this expression, you get different type errors. And in both cases, Python was not able to perform implicit type conversion on your behalf. That's the behavior of the Python. And let's now dive deeper and try to understand what actually happens under the hood and why Python produces two different type errors. But first, let's see how we could actually get correct result of the conversion of one value to another. We have to explicitly call one of the built-in functions. And if you want to add number 10 to number 5, you have to convert string 10 to number 10. That's what we do here. And then we add two numbers, two integers, 5 and 10. And result will be 15. And now there is no type error. But in some cases, there are no errors. Let's have a look at this example. In this example, there is integer 5, which is assigned to this variable int num, and there is also a float number 4.5, which is assigned to variable float num. And then we use plus operator for those two variables, int num and float num. And in such example, we get such result, 9.5. And Python was capable of adding two numbers of different types, integer and float, and no type error happened in this case. Same applies to this example. Here we have Boolean value, which is true, and we have integer value, for instance 7. And when we add bool val and int val, we get 8, and again no error. And it seems that now Python actually has converted true to integer 1, and afterwards added 1 to 7. And that's why here we got 8 as a result of this expression. And in those examples, we don't get any errors from Python. But also I said before that Python doesn't perform any implicit type conversion. But why this happens? Why in case of string and integer we get type error, and with case of float and integer we get no error and we get result? Or we are able to add Boolean value and integer value. So what happens? In order to answer this question, we have to discuss how actually plus operation is performed under the hood. In this example, when we add integer and float number, and when we use plus operator, under the hood, Python actually calls one of the methods of the int num object, because int num is first operand here in this expression. And you know that each method could be called using dot notation. So basically, for int num object, Python calls add method. And notice two underscores before name of the method and after the name. And such method is called magic method. And it is expected that you, as a user of Python programming language, will not call magic method directly, because Python calls it under the hood. So in this example, Python calls magic method add and passes to it second operand of this expression, and it is float num variable. So what it basically does, it tells, please try to add 4.5 to the integer number. And this method is located in the int class, because int num is instance of the int class. And in such case, when you try to add decimal number to integer, this method add returns string not implemented. It means that inside of the int class, it is not implemented to add float to integer. And in such case, Python, again under the hood, tries to perform opposite operation. It takes second operand, this one, it is instance of the float class, and tries to call another magic method, which is called radd, right add, which technically says that for this number, try to add from the right another number. And we pass in this method call int num. And basically we say, please try to add integer number to float number. And this magic method, right add, is located in the float class. And in the float class, inside of this magic method, there is a support of addition of integer to float number. And now this method actually returns the result 9.5, not implemented, like this method. And this says that basically functionality of addition of integer and float is implemented inside of the float class. And Python doesn't perform any implicit type conversion. It simply uses magic methods of corresponding classes and asks them to perform specific operation, in this example, addition of two values. That's why in this case we got result and no type error. So let's summarize. 2 underscores add and 2 underscores is a magic method. And this method is located in the int class. And number 5 is actually instance of the int class. And of course, every instance of specific class inherits all methods. And that's why method 2 underscores add 2 underscores is available for object int num. And also right add is a method, also magic method, but now it is a method of the float class. And inside of this method, there is possibility to add integer to decimal. And that's why this method returns result 9.5. And this happens inside of the Python. You don't need to call magic methods yourself. But that's what happens when you utilize, for instance, plus operator and write such expression. But what happens if you change order of the operands and first you write float num and then int num, then this will not happen. So this is skipped, and Python directly calls add method for float num variable. And inside of add method, it is also supported to add integer to decimal. And that's why we will get result immediately. That's what is magic method. And next, let's talk about magic methods in greater details. Now you know that Python doesn't perform any implicit type conversion. And if you want to convert one type to other type, you have to utilize built-in functions like float, int, and so on. Also, you know that in some cases, when you try to perform operations with values of different types, Python generates type error or other error. And in some cases, Python is capable of performing specific operation, like adding float number to integer number. And that happens because of magic methods. And let's now talk about magic methods in greater details. Magic methods are internal methods of the classes, and they are usually not called explicitly. And there are many magic methods like add, equal, and str not equal, or, and so on. And these methods are implemented in different built-in classes differently. They have different logic. And when, for example, you compare two different variables using two equal signs operator, Python under the hood calls this built-in method equal. And that is responsibility of this magic method, which is actually a function, to return specific result. Python doesn't do any other action. It simply calls specific class method, and that's it. And for example, when you perform operation with AND operator, Python calls such built-in magic method. You could, of course, call any of these methods directly, but usually it is not recommended to do. But such methods don't differ from other methods, which don't have such prefixes and suffixes. They are just normal methods which are defined in corresponding classes. And next, let's have a look at the magic methods on practice. We already discussed the difference between regular methods and magic methods. And normally magic methods are not called directly. They are called implicitly by Python under the hood. And let's first explore how you could get list of the names of all attributes and methods of specific object. And let's create a variable myStr, which is string, and its value will be, for example, string ABC. And you could always get access to all available methods and attributes using dot notation. And here you'll see different names, such as split, capitalize, center, and so on. Also, you could use dir function, and you could, in the dir function, call pass name of any object, for example, myStr, and let's print result to the terminal. And here, in such case, you'll get list of strings. And here you'll see all available methods and attributes, including magic methods, such as add, doc, equal, jt, and so on. And also after that you'll see regular methods, which are usually called explicitly by the user. And for strings there are such available methods as isNumeric, join, lower, and so on. And before, in the practice section dedicated to strings, we used with you several of those methods, including replace. That's how you could get a list of all available attributes, including methods, for particular object. In the same way, you could actually get access
to all available methods of specific class using actual class name, for example, str. So here is built-in str class. Let's comment out this line and execute code, and here I get very similar list with same magic methods like jt, le and others, and other regular methods including replace, upper and so on. This means that all those methods including magic methods are actually defined at the class level, and they are inherited by all instances of the string, including my str object. Let's now hover mouse over str, and as usually you'll get information about this particular object. It is in this example class. And here is documentation which describes this class, create a new string and so on. But where is this information? Where is it stored by Python? It is stored using doc attribute, this one. How could we check that? Let's type here my str or simply str dot and then add two underscores doc. And as you might notice here, there is small letter f. Let's finish and select doc from this list, and if you hover mouse over doc, you'll see that it is a class attribute. Here it is. And the name of this attribute is two underscores doc two underscores. If it is an attribute, you don't need to call it. It is not a method. And here you could see type of the value of this attribute. It is either string or none. Let's print value of the doc attribute to the terminal, and I'll remove those two lines. Let's run the code, and here I see long text output. And this text starts here. str object str create a new string object from the given object. And we just saw this text together with you when we hovered mouse over str. Here is exactly the same text. That's where this text is stored, and it is stored on the class level, and it's a value of the doc magic attribute. Simple as that. And such magic method is basically available for all built-in classes, including, for example, bool. Let's replace str with bool, and let's remove this line. Let's run the code, and here I see information about the built-in bool class. And same text we see when we hover mouse here over bool variable name. Great. Let's remove this and let's create variable mynum, and its value will be 10. And now let's see which magic methods are available for integers. Let's add here two underscores, and here is a list of different methods. So you already know that doc is actually an attribute and its value is simply block of text. And here below there are different methods such as equal, greater or equal, greater, add, and others. And let's, for example, try to use equal method. Let's call it equal, and let's see what this magic method actually expects from us. It expects an object, and we call it for mynum object. Let's create other variable here, for example, other num, and its value will be, let's say, 20. And let's pass name of other num variable in the equal method call. Recap that we should not call magic methods directly. And let's print result to the terminal. Let's run the code, and we see here false. This means that those two objects are not equal. Those two integers are not equal. And this result was returned by this magic method. And it is basically the same as doing following. Print mynum, comparison operator, other num. Let's run the code, and we get here false. And in this example, when we use comparison operator, Python implicitly under the hood calls this magic method, exactly like this. And therefore we get result in such way. Also, if you hover mouse over this magic method name, you'll get actually definition, short description of this particular method. Return self equal to value, so it compares to different objects. And in Python it's possible also to get this text if you need it. And for that you have to use built-in help function. Let me show you. Print help, and here will be my num dot two underscores equal to underscores. But here we don't call this method. We simply pass name of this method to the help function. Let's run the code, and here we see description of particular method. Here is this description. And basically this description is exactly the same as we see when we hover mouse over this magic method name. Return self comparison operator value. Here is this text. And that's how you could get help regarding any magic method you like. Let's replace equal with other magic method. For example, let's use add method here, and we don't need to call it. Let's remove call to this method and let's run the code. And here is description of this particular method, which is obviously a function. It returns self plus value. It is used when you utilize plus operator. So that's overview of several magic methods, and recap that you should not call such methods directly. And you have to utilize different operators instead. And Python will invoke specific corresponding magic method under the hood, implicitly. And you have to remember that magic methods always have two underscores in front of them and two underscores at the end. Throughout the course, we will of course talk about other magic methods in Python. Let's now talk about lists. Lists are very popular in Python, and very often list is chosen as a data structure for storing different elements. And the list is an ordered sequence of elements. This means that each element in the list has its unique index, and index starts with 0. Let's have a look at some examples of the list. Here you see a list which contains 3 elements: apple, banana and lime, and in this sample list all elements have the same type. They are strings. Index of this element is 0. In next example there are 4 elements and they are integers, and this list is assigned the variable post IDs. Notice that from the variable names it is clear what actually variable contains. For example, this contains IDs of the posts, this contains my fruits, and this contains user inputs. And in this sample list there are values of different types like Boolean, string and float. This means that you could mix different value types in the list. So, usually list contains values of the same type, for example list of dictionaries or list of strings, but if needed you could store values of different types in the list. And please notice that in the list order of the items matters. And if we look for example on such two lists, my fruits and other fruits, you could notice that order of the elements is different. Banana, for example, is here, and apple is here. And those two lists are completely two different lists. And if you try to compare those two lists using comparison operator, you'll get false. You already know that when you use any operator in Python, corresponding magic method of the class is called. And in such case, we call equal magic method of the list for this object. My fruits dot equal, and then to the magic method equal we pass other fruits. And inside of that magic method, in the list class, there is a logic
which compares two different lists. And it compares length of the list and compares elements. This to this, this to this, and this to this. And of course, in this example, those two lists are two different lists, because order is different. That's why here you'll get false when you try to compare those two lists. Of course, you could get length of the list. It means you could get quantity of the elements, quantity of the items in the list using len function. Similarly, it works for strings. But for strings, len returns quantity of the characters in the string. For lists, len returns quantity of the elements in the list. And for instance, here is empty list. It contains 0 elements. Here are 3 elements in the list, here are 4 elements in the list, and here are also 4 elements in the list. Also, you could use square brackets notation in order to get specific element in the list, because each element has its unique index, and index of the first element is 0. Index of this element is 1, and this has index 3 in this example. So, post IDs square brackets 0 gives us first element in the list. Post IDs 1 gives us second element in the list, 245. And also it is possible to use negative indexes. And when you put -1 as an index, you'll get last element in the list. In this example, it is number 167. You could also use, for instance, -2 or -3 as index and count from the end of the list. That's how you could get values of the elements from the list. It is also possible to change values in the list using same approach. Square brackets, then you put index of specific element, for instance 0 or 2, and then assign new value to that element. And technically, in this example, we reassign value. For instance, here was value 151, and then you put this value on this place. And afterwards, post IDs will contain 4 different elements, starting from 555 and ending with 167. That's how you could change values using square brackets notation. Also, you could very easily delete elements from the list. And for that, you could utilize del statement. Here is sample examples where del statement is utilized. So initially, there were 4 elements in the list. Length of the list is 4. Then, using del statement, we delete element with index 1. And after such operation, list will have 3 elements. Here they are. Then we could delete one more element using same statement, del. And here we use -1 as index. And in such case, we will remove last element from the list. And after this operation, list will contain only 2 elements. Here is length of the list. And please notice that when you modify any element in the list, or when you delete element from the list, or when you add element to the list, no new object is created. Python mutates existing object in memory, because each list is mutable object in Python. And here we work with same object, user inputs. No creation of the new objects in these examples. That's how you could delete elements from the list. And now let's have a look at such example where a list contains actually dictionaries. Here is first dictionary in the list, and here is second dictionary in the list. Each dictionary has 2 key value pairs. And of course, length of this list is 2. Here we see that. And if you want to access, for example, this value, which is actually value of this property in this dictionary, you could use 2 pairs of square brackets. Users square brackets 1. In such way, we access this element in this list, and then for this dictionary we could access this value again using square brackets. And in square brackets we put name of the property, name of the key in this dictionary. It is user ID. So that's how you could work with list of dictionaries in Python. Let's have a look at this example where we utilize variables and then form list based on the variables. So here there are three different variables: my fruit, other fruit, and new fruit, and we assign three different strings to those variables. And afterwards, using such syntax, we create new list with three different elements. And in place of the elements, we simply put names of the variables. And when we print all fruits, you'll get such output: apple, banana, and lime. And definitely after this operation you could even change values of those variables, but contents of this list will not change, because those strings will remain in the list. And the reason for that is that strings in Python are immutable. That's how you could use variables while forming new list. And now let's have a look at such example where we try to access element by the index, but we use index which is out of range. So in this list there are only 4 elements, and index of the last element is 3. And that's why in this example, when we try to access, for example, element with index 10, we'll get index error, list index out of range. And in order to deal with such errors, you should avoid using such access element technique when you don't know what is the actual length of the list. And most commonly, when you have a list as a data structure, you iterate over all elements of the list. And you could perform some actions with each element of the list. And it's not a common task when you access specific element in the list by its index. But you should keep in mind that in such case you'll get index error.
Hey guys, this course is part of the big Python course, which is more than 50 hours long. Link to the complete course you'll find in the description under this video.
Lists inherit a lot of different methods from the list class. And all those methods are available for each instance of the list. And there are such methods as append, add new element to the list, pop, remove element from the list, remove, it also removes element but works differently from pop, insert, insert specific element at specific index, sort, you could very easily sort list, and so on. Many different methods are available for each list, because list is mutable, and you could mutate list as you want. Change the order of the elements, remove elements, add elements, and so on. That's what you could do with each list. And that happens because objects inherit list methods from the list class. Let's have a look at some of the methods which are available for lists. And let's start with append. We could create an empty list here and then call append multiple times. And I pass different strings in append function calls. And finally I'll get 4 elements in the list, here they are, and length of the list will be 4. And it's important to mention that append method adds new elements at the end of existing list. That's why this element is first element in the list, and this one is last element in the list. So we add elements at the end of the list. Next method is pop, and with help of pop we could remove either last element in the list or element at specific index. So if we have such a list with 4 elements, pop removes last element. And after this operation, In the list, there will be only 3 elements. Last element was removed. Also, if you supply index in the pop method call, you'll remove element at specific index. And in such case, we remove first element in this list. And after this operation, inputs contains only 2 elements, hi and the smile. And if we call pop again, like we called here, without any argument, then we will again remove last element from the list. And here I wanted to show you that pop method basically returns element which was removed. So if you want to perform further actions with specific element which was removed, then you could assign result of the pop method call to the variable. And finally, after all those operations, inputs list will contain only 1 element. That's how you could delete elements using pop method. And you could either delete by specific index or delete last element in the list. Let's have a look at the sort method, which helps you to sort elements in the list. And it usually works good when all elements have the same type, like in this example. All elements are actually integers. And here we simply call sort method, and it performs sorting, and after such call, order of the elements in the list will be like this. So we start from the smallest number and end with largest number. It is also possible to supply named argument. Named argument has name, reverse, it is actually name of the parameter of this method, and after equal sign, you say which value you want to assign to this parameter. So in Python, such arguments are called named arguments or keyword arguments. We will talk about keyword arguments a bit later. So here in this example, we could say that we want to put elements in reverse order, so in descending order. And after such sort method call, you'll get such list. First element will be the largest one across all elements in the list. So sort without any arguments will sort elements in ascending order, and with keyword argument reverse true, it will sort elements in descending order. Also, it's possible to perform conversion to a list. And for instance, if we have a string, hello from Python, we could call list function in order to create new list, because this expression creates brand new object from this object. And in this example, you'll get a list with characters from the input string. Each element is a separate character, including space. Also, it's possible to convert, for instance, a dictionary to the list. Here is a dictionary with 2 key-value pairs, and the property names are A and B, and if you convert such dictionary to a list, you'll get a list only with key names A and B. That's how list function works when you supply a dictionary as argument for it. You could of course convert other value types to list if you want to do so. As you already know, there are a bunch of methods available for lists, but also you could use built-in functions for lists. And there are such built-in functions as min, max, and sum. And you could simply pass a list to those functions and get results. Here is minimum value across all elements in the list, here is maximum value across all elements in the list, and here is sum of all elements in the list. You could also very easily find what is the average value of all elements in the list. And you need to sum all elements and then divide the result by the length of the list. And in this example, average value is here. You see how easy you could perform different operations with, for example, lists in Python. And for that, you could utilize either built-in functions or methods of corresponding class. But what if you want to combine two different lists? For that, you could utilize simply plus operator, simple as that. So here are two lists, here are two elements, and here are three elements, and here we utilize plus operator. And in this expression there are two operands, first operand and second operand. And as a result, you'll get list with 5 elements. We add to those two elements 3 elements from another list. And this operation is obviously performed by the magic method, which is called add, and this magic method is located in the list class. This is how you could perform operation of merging two different lists in one list, and you could either use plus operator, or if you want to do so, just call magic method 2 underscores add 2 underscores. You could also copy a list, and you could also copy part of the list if you want to do so. And this operation is called list slicing. If you have such list with 5 elements, you could use square brackets notation and put here range of the elements. And if you put colon 2, this means that first 2 elements will be extracted from this list to the new list. But this operation doesn't modify this list, and you'll get completely new list with 2 elements. Notice that this second index here is not inclusive. And in this example, 1 colon minus 1, you'll get all elements in the list except first one and last one. So we start here from index 1, this index, and we end up at index minus 1. But this index is not included. That's why we stop here. And as a result of this slicing, you'll get 3 elements in resulting list. Here they are. Also, you could omit second index, and in such case, you'll get all elements to the end from specific starting index. In this example, minus 2. And here we get just 2 last elements from the list, because we start here at index minus 2. This has index minus 1 and this has index minus 2. This feature is called index slicing, and you could also copy list to the new list using square brackets and colon inside, without any indexes. But we'll get to list copying a bit later.
Let's now have a look at the lists on practice, and what you have to remember is that lists are ordered sequences of elements. It means that such list is different from such list, because order of the elements in those lists doesn't match. And now let's create a variable and let's call it, for instance, my_nums, and let's assign such a list to this variable. There will be few elements which will be numbers. And now let's print my_nums to the terminal. Let's also print type of the my_nums, and also let's print result of the isinstance function call. Here will be my_nums and here will be list. And also let's print ID of the my_nums object. Let's run the code, and here I see the list, and notice that order here in the output is exactly the same as order here. Also here I see that my_nums is an instance of the built-in list class, and also we see that my_nums is indeed instance of the list class. Here we get true as a result of the isinstance function call. And here is ID of the my_nums object in my case. It's the location of the object in the memory of the computer. In lists it is possible to access specific element by its index. And let's print my_nums square brackets 0, my_nums square brackets -1, and for example my_nums square brackets 2. 0 is index of this element. -1 is index of the last element. You could use also -2, -3, and so on. In such case, we will count from the end of the list. And 2 is index of this element. Let's run the code and we see 10, this element, 35, this element which is last one in the list, and 100, its element with index 2. Another thing which you have to remember about lists is that lists are mutable in Python, and you could very easily mutate existing list, add new elements, replace elements, delete elements, and so on. Let's first add a new element to existing list. mynums.append, that's that method which you have to use in order to add new element to the list, and let's add element 50. And before doing that, let's print again ID of the mynums, and let's do the same afterwards, print ID mynums. And let's also print actual list, print mynums. And let's do that before, after creation of the mynums list, print mynums. Let's run the code, and here we see original list, then we see ID of original list, then we appended new element to existing list, and notice that ID of the object was not changed, so ID remains unmodified. And here we see that new element appeared in existing list. That's how we mutated existing list. We added new element to it. So it's very important. We don't create new list. We change existing list. And such methods as append modify existing list. Now let's remove element from the list, and for that we could use pop method, mynums.pop, and let's simply call this method like that. And now let's print mynums to the terminal, and let's do that before this operation. Run the code, and here we see original list, and here we see modified list. Last element was removed. But if you hover mouse over pop method, you'll see in its description that it removes and returns item at index, and default is last. This means that in the pop method call, you could basically supply specific index of the element which you would like to remove. For instance, if you want to remove this element, you have to call pop method with index 2. Let's run the code, and you'll see that this element was removed from the list. Also, it's always possible to check length of the list, because list is a sequence. And for that, you have to utilize built-in len function. Let's print length of the mynums before pop method call, and let's print len of the mynums list afterwards. Run the code, and original length was 4, and after pop method call, length became 3. So length is modified, of course, automatically without your intervention. Great. Now let's have a look at one more method, mynums.extend. And using extend method, you could extend one list by elements from another sequence. And here you could pass, for example, another list. Let's add here a few elements, and let's print mynums afterwards. Run the code, and here I see 2 new elements in existing mynums list. So this list was extended by elements from this list. And what is interesting, here you could basically use any sequence, even string, like ABC. Let's run the code, and here I see 3 new elements in the list. And they are separate characters from the ABC string, because each string is a sequence. That's how you could extend one list by elements from another sequence. And let's have a look at other methods available for lists. mynums, dot, and here are a bunch of other methods. For example, using index, you could find index of specific element. If I pass here 100 and print result to the terminal, I'll get 2. It's index of this element in the list. But if list has few the same elements like that, you'll get again same index, which is 2. It's index of the first element, which appears in this list. Also, it's possible clear existing list and remove all elements from it using clear method. Let's call it. And afterwards, if you print my nums, you'll see empty list. Here it is. Usage of this method is useful when, for example, in the list you store some tasks. And let's say that you process those tasks one by one. And at some moment of time, processing failed and you have to, let's say, clean the queue and afterwards start processing of the tasks again. In such case, you could use clear method and afterwards you could add again elements to the list using append method, and let's add here element 50 and let's print my nums to the terminal. And now list will have just one element. Also, it's possible to merge two lists using plus operator. Let's add here new variable other nums, and here will be several elements in this list. And let's now create merged nums list, and here will be simply expression my nums plus other nums. And also let's print to the terminal merged nums. Run the code, and here I see a list which contains elements from both sequences, from this list and from this list. And definitely order of the operands here in this expression matters. First we see elements from the my nums list, here they are, and next we see elements from the other nums list. But those lists were not mutated. And if you print here my nums and print other nums, you'll see original list. Here they are. And here is merged list. And as you already know, if you use such operator as plus, under the hood Python basically calls one of the magic methods. And in case with plus operator, Python calls magic method which is called add, this one. And previous expression is equivalent to this expression, my nums add other nums. If I run the code, I get exactly the same result. So that's how Python performs addition of two lists. Let's get back to plus operator here, and that's how you could merge two lists together using plus operator. And also it's possible to replace specific element using square brackets notation. Here you specify index of the element which you would like to replace, for example index 2, and here I use assignment operator. And on this place, let's say I want to add element 0, so replace 100 with 0. Let's print my nums afterwards, run the code, and here I see that element 100 was replaced with element 0. Also notice that in the list you could have elements of different types. For example, here will be variable myList, and in the list you could, for example, put element true, none, string ABC, then number, float number, and so on and so forth. So, lists are not strict in terms of the types of the elements, and you could use any types, even embedded dictionary, for example, like that. And also, if you want, you could add a dictionary, for example, dictionary like that. Let's print to the terminal such a list, print my list, run the code, and here I see this list which contains different elements of different types, including list and even dictionary. Alright, that's it about lists, and lists are very powerful data structures in Python, and you could perform many different operations with lists. And what you have to remember is that first, lists are ordered. Each element has its unique index, and index starts at 0. And also lists are mutable. And you could mutate or change existing list, add elements, remove elements, modify elements, and so on.
And now let's have a look at this example. Actually, here we copy list, but we copy one variable into another variable. So here is a list with two elements, and we assign this list to the variable myCars. And afterwards we assign variable myCars to the variable copied cars. And afterwards, to the copied cars list, we append new element. And after that copied cars variable, will contain a list with 3 elements. But this variable, myCars, will also contain a list with 3 elements. And if you enter such expression, id myCars, comparison operator id copied cars, you'll get true. This is because here we copy object by reference, and we talked about that before. Those two variables, copied cars and myCars, actually point to the same object in memory. And that object is modified when we perform, for instance, such operation. And it is modified through copied cars variable. And that's why after such modification, this variable also changes, because it still points to the same list in memory. And here we mutate a list in memory, because lists are mutable. And here is a proof that IDs of two different objects are the same. Those variables point to the same place in memory. That's why if you want to avoid such behavior, you should not copy variables like that. You should not copy variables by reference. But how you could create brand new list? Let's have a look at few examples. This is example which I already mentioned, and here we simply use list slicing, square brackets and colon inside, and in such case we will get completely new list and assign it to the variable copied cars. And after that, when we modify, for instance, copied cars list, it modifies only this list, and here you'll get Audi at the end of the list. And myCars variable will still contain just 2 elements, because after this operation, we have 2 different objects in memory, even though they contain same elements, those 2 elements. But afterwards, we could modify each list separately. And now, when you compare IDs of 2 different objects, myCars and copied cars, you'll get false. And this proves that those 2 objects are located in different places in memory. And those variables, myCars and copied cars, point to different objects in memory. That's option number 1, how you could copy list to the new list. And for that we utilize slice. Very easy and very short. Another option is to call copy method of the list. Like that. So here we use myCars object and call copy method, which returns brand new list. And now remaining part is the same. We append new element to copied cars, and after creation of the new copy, we modify only new list. Here we see Audi at the end. And old list myCars is still unmodified. There are only 2 elements. And of course, IDs of the objects are different. This is method number 2, where we utilize copy method of the list class. And there is also one more obvious option, and we could simply create new instance of the list using built-in list function. Very easy. And we pass a list to this function. And of course, it returns brand new list. And afterwards, we could work with that list same as before. And we don't modify previous list. So 3 options: slice, square brackets and colon. Second option, call copy method. And third option is to call built-in list function. And you know that lists are mutable in Python, and the list is an ordered sequence of elements. You could add elements to the list, you could add elements inside of the list, you could remove elements, you could modify elements. And all of that is possible because lists are mutable objects in Python. And when specific variable contains a list, and when you copy such variable to another variable, you simply create copy by reference. You copy only link to specific object. And in such case, you could modify that single object using any of those variables. And one object in the memory will be modified. And in order to make, let's say, full copy of the list, you have to utilize one of three techniques. Either use list slice, square brackets colon, or use list method, which is called copy, or utilize built-in list function, which creates new instance of the list class. These are key features of the list in Python.
Let's now explore how we could copy lists on practice. And let's create a list, and let's name it my list, and here will be few elements. And I'll use elements of different types, like that. And now let's create a copy of my list. And let's simply type here my list. So we assign my list to copy of my list. And let's afterwards add new element to copy of my list using append. And here will be, for example, none. It's new element for the list. And let's print my list, and let's print copy of my list afterwards. And if we run the code, we'll see that both actually variables were modified and none appears in those lists. And technically we work here just with the same list, because my list and copy of my list point to the same object in memory. And we could prove that by printing IDs of those objects, or by simply comparing two IDs. Let's print result of the expression ID my list, comparison operator ID of copy of my list. And if I run the code, I'll see true. This means that IDs of those two objects are the same. They point to the same location in memory. If you want, you could add also here print ID of my list and print ID of copy of my list. Run the code, and here I see exactly two same numbers. And if you want to avoid such behavior of the list, when you are able to modify list via any of the variables, either this variable or this variable, you have to copy a list. By the way, I see here that none is underlined, expected type int, str or bool. And basically here I see this warning, because here I used only integer, string and boolean as types of the values for this list. And here PyCharm tells me that probably I made a mistake and I should add, for example, an integer to the list or string. And if I add here an integer, then this warning will disappear. But again, that was just a warning. You could add elements of different types to existing lists. So here in this example, we are able to modify this list via any of those two variables. If you want to avoid such behavior, you could copy the list and create new object. And for that you could use, for example, copy method of the list and call it like that. And if I run the code now, I'll see two different IDs for variables. And now if I modify one list, another stayed unchanged. And here is the result of comparison of two IDs. They are obviously different. That's first way how to create a copy of the list, and then you could work with two different lists independently. Second way to create a copy is to use list class and call here initialization function for list class like that. And result will be same as we just saw. Two independent objects, and we could work with them independently. Also, you could use list slicing in order to create new list. And it is the most shortest way to create a copy of the list, and here you have to add square brackets and simply colon. In such a way, we will take all elements from this list and put it to the new list. Let's run the code, and here I see two different IDs, and lists are independent, same as in last two cases, where we create a copy of the object. So these are different ways to create copies of the list, and you could use either copy method of the list, or create new instance of the list using built-in list class, or use list slicing, like I did here. But please always be very careful when you copy variables like that. In such case, you will work with the same object via different variables, and you could occasionally modify another variable without even knowing that. So please keep that in mind and properly copy lists if you need to create different independent objects.
Now it's time for tasks for you guys, and tasks will be dedicated to lists. And first task is following. Please create a list with 5 elements. And those elements must be of different types. Next, delete third element in this list. Print the length of the list to the terminal. Next, change order of the items in the list. So, reverse order. Afterwards, please create one more list with 2 elements. After that, expand the first list with elements of the second list. So you have to modify first list and add to it 2 more elements from the second list. And finally, display extended list, which contains 6 elements, in the terminal. This is task number 1, and second task is following. Please create 2 lists. Combine 2 lists using plus operator. Then determine which magic method of list is called when you use plus operator. Merge lists using this magic method instead of plus operator. And finally, print result to the terminal. I wish you good luck. Now let's discuss dictionaries in Python in greater details. And every dictionary in Python is an instance of the dict class. And this is a built-in class in Python. So what is a dictionary? Dictionary is a set of elements, key value. And dictionary could contain multiple elements. And I say set because dictionary is an unordered sequence of elements. This means that order of the key value pairs in the dictionary doesn't matter. Let's have a look at the structure and the syntax of dictionaries. In this example, we create a variable called myMotorbike and assign dictionary to it. You could write dictionary just on one line of code if dictionary contains just 2 or 3 keys. But if a dictionary is larger, I suggest to you to split it to multiple lines. It is completely acceptable in Python. And here in this dictionary you see 3 different keys: brand, price, and engine volume. And you see that the keys are in single quotes, but it is also possible to use double quotes. But single quotes are preferred. And after colon comes value for a specific key. For example, here you see a string. Here you see integer number, and here is float. And the key value pairs are separated using commas. So, on the left side you see keys, on the right side you see values. And the order, how you add key value pairs to the dictionary, doesn't matter. What does matter is actually key, because using key you could access specific value in the dictionary. So, thing to remember, order of the elements in the dictionary does not matter. And if we look at 2 different dictionaries, myMotorbike and otherMotorbike, you could notice that those dictionaries contain same key value pairs, but order of those key value pairs is different. But technically, those 2 dictionaries are completely identical. But how we could verify that those 2 dictionaries are actually identical? For that, we could utilize comparison operator. And if you compare my motorbike to other motorbike, you'll get true, because those dictionaries contain same quantity of key value pairs, 3, and keys are the same and corresponding values are the same. And of course, such operation, comparison operation, is performed using magical method equal, which is located inside of the dict class. And inside of that method, it is described how to compare different dictionaries. And here you'll get true. But for instance, if you add one more element to this dictionary, one more key value pair, and compare dictionaries again, you'll get false. So order of the key value pairs in dictionaries doesn't matter, and here we see completely two identical dictionaries. But if we compare IDs of the objects, my motorbike object and other motorbike object, we'll get false. And the reason for that is that here we see two different objects, and they are stored in two different places in memory. And therefore, my motorbike and other motorbike point to different locations in memory. IDs of those objects are different. But as we just discussed, if we use comparison operator, we get true, because comparison of those two dictionaries is performed using equal magic method from the dict built-in class. Now let's explore how we could add new key value pairs, how we could change value of specific key, and how we could remove specific key from the dictionary. In order to get value of specific key, you have to use square brackets. Like this. Square brackets and name of the key inside of the square brackets. Very important notice. You cannot utilize dot in order to access specific value of the key. You cannot write my motorbike dot brand. Because dot in Python is used in order to access attributes of the object. And keys in the dictionary are not attributes of the object. Therefore, if you try to access any value of the key, for example brand, using dot notation, you'll get an error. There is no such attribute in the object. There are key value pairs in the dictionary, but there are no such attributes in this object. Please keep that in mind. That's why, in order to perform different actions with keys in the dictionary, you have to utilize square brackets. So here we print value of the brand key and we get Ducati, and here we print value of the price key, and for that we use square brackets. In similar way, you could change values of specific keys using same approach, square brackets, then name of the key, and afterwards you could assign new value to specific key. Here initial value was 25,000, and here we change value to 20,000. And afterwards, if we print value of the price key in my motorbike dictionary, we'll get 20,000. This is how you could change values, and here we mutate existing object. Because dictionaries in Python are mutable objects, same as lists. Therefore, after this operation, Python does not create a new object. It mutates existing object. It means that ID of this object remains unchanged, and you could easily verify that. So, how you could add new elements to the dictionary, new key value pairs, using same approach, square brackets. So let's assume that initially we have a dictionary with 3 keys, brand, price, and engine volume. And afterwards, using square brackets notation and putting here name of the new key, we could create new key and assign value to it. And after this operation, in the My Motorbike dictionary, you will see 4 different keys: brand, price, engine volume, and is new. And again, same as in previous case, we mutated existing object. We added new key to existing dictionary. And therefore, we could also delete specific keys in the dictionary, but for that you have to utilize del statement. Del and then simply refer to specific key in the dictionary. In this example, we delete engine vol key from this dictionary. And also we mutate existing object, and after that, in the My Motorbike dictionary, you'll see only two keys, brand and price. That's how you could delete specific key from the dictionary. And in this example, we deleted engine vol key. How you could use variables in order to access specific key. Same approach is applied here. If you have, for instance, name of specific key assigned to the variable, for instance, key name, you could use key name in the square brackets. So technically, in square brackets, you could put any valid expression. And here, if we perform such operation, we will assign new value, BMW, to the key with name brand. And here, in resulting operation, when we print my motorbike to the terminal, you'll see that value of the brand key is BMW. Such approach is useful when you perform such operations inside of the function, and you get name of specific key, which has to be changed via parameter of the function. And you could refer in square brackets name of the parameter, and in such a way you will work with specific key name in the dictionary. But keep in mind that here in square brackets you could use any expression. Let's now together create a dictionary, and we will create dictionary with few keys and values, then we will access values, then we will add new keys and delete keys. So let's create a dictionary, and I'll name it my bike. So recently I bought a custom electric bike, and here let's assume that I want to put all properties of this bike. Here will be dictionary, pair of curly braces, and I could put all keys either on the same line or on different lines. Let me put them on the same line, and here will be first brand key. I'll use single quotes for all keys. It is also possible to use double quotes. Then comes colon, and after colon comes value for the key. And let's assume that brand here will be custom. And the next key will be price, and let's say price is 2000, like that. And now let's print my bike to the terminal, and also let's print type of my bike, and let's run the code. And here I see such a dictionary in the output, and this dictionary has two keys. It's also possible to check length of the dictionary using built-in len function. Print len my bike. Run the code, and length is currently 2. There are just two keys in this dictionary, brand and price. Now let's access one of the keys in this dictionary. For that, we could utilize square brackets. Let's print my bike square brackets, and here will be as a string name of the key, for example brand. In similar way, we could access another value of another key. Let's copy this line, and here instead of brand will be price. Run the code, and here I see custom, its value for the brand key, and 2000 as value for the price key. And please notice that here you are not allowed to use dot notation. So if I write my bike dot and try to type here brand, I will definitely get an error. And if I hover mouse over this line, I'll see that there is unresolved attribute reference brand for class typed dict. Because as we discussed before, you could use dot in order to access attributes and methods of the object. My bike is an object here, but it doesn't have such attribute as brand.
Brand and price are keys of the dictionary. They are not attributes of the myBike object. So that is very important. You have to always utilize square brackets notation when you want to access a value of specific key in the dictionary. Now let's add one more key to the dictionary, myBike, and here we will use same square brackets notation. And let's say that I want to add a key max speed. And this value will be, let's say, 50 kilometers per hour. And let's print myBike afterwards. And I should see dictionary with three keys: brand, price, and max speed. And basically same as with lists, we just mutated existing object. Python didn't create a new dictionary. We modified existing one. And we could prove that by checking ID of the myBike variable. And here let's print ID of the myBike. And let's print the same afterwards, after adding new key. Print ID of the myBike. Run the code. Here is one ID and here is another ID. They are the same. It proves that we just modified existing object. Also, it's possible to replace value for specific key by other value using same square brackets notation. myBike square brackets, here will be price, and let's say that I want to modify price to 3000. Let's print myBike afterwards, run the code, and here I see that value for this key was modified. Here I see a warning, and the warning is following: this dictionary creation could be rewritten as a dictionary literal. And if I click here replace dictionary creation, you'll see that this new line where I replaced the price value was removed, and here is this value as initial value for the price key. So PyCharm is clever enough and gives us an option to optimize code where possible. But I would like to get to this syntax in order to demonstrate you again how to modify value for existing key. Also, if you want, you could split dictionary creation to different lines of code like that. Let's run the code, and Python is pretty happy with such syntax. Now let's ensure that the order of the keys in the dictionary doesn't matter. And we could change order here, but dictionary remains the same. Let me replace this with other bike, and here will be same keys with same values, but first I'll put this one and next I'll put brand custom. And now let's compare those two dictionaries. And it is possible to compare dictionaries same as other objects in Python using comparison operator. And here will be expression myBike comparison operator other bike. And let's see results, and here I see true. Because in terms of Python, those two dictionaries are the same. They have same keys with same values. But if I modify here 2000s to, let's say, 3000s and run the code, I'll get false, because now those two dictionaries are different. But in such case, they are the same. Here, again, I get true. This proves that order of the key value pairs in the dictionary doesn't matter. Dictionaries are unordered in Python. Let's see which methods are available for dictionaries. myBike, dot, and here you see already familiar to you method copy, and you could create new dictionary from existing one. Also, it's possible to clear dictionary, remove all key value pairs. There are also two nice methods which are called items and keys. And let's try keys first. And let's print result to the terminal. Let's run the code, and in the output I see such interesting structure. Dict keys, and here is similar to list output, which contains two strings, brand and price, which are obviously names of the keys in this dictionary, brand and price. But this is not a list. it is an instance of the dict keys class. And we could ensure that it is in fact instance of the dict keys by creating a new variable keys, let's say, and I'll assign result of the keys method call to keys variable. And next let's print type of the keys. And also let's again print keys. Run the code, and here I see that keys is an instance of the dict keys class. This is a sequence, and it is similar to list, but class is different from the list. That's why here we see such output when we print keys. But same as for any other sequence, it is possible to iterate over all elements in this sequence, using, for example, for-in loop. We will talk about for-in loop later. Also, it's possible to convert dict keys to the list very easily by calling list function like that. Let's run the code, and here now I see that keys is an instance of the built-in list class, and here I see list with 2 elements. So to summarize, keys method returns a sequence which is an instance of the dict keys class. And if you hover mouse over keys, you'll see that in description of this method. So it returns set-like object providing a view on dictionary's keys. And it is an instance of the dict keys built-in class. But it's possible to convert a result to the list or any other sequence. Now let's have a look at another method of the dictionaries, which is called items. So let's call for my bike dictionary items method. And as usually, let's print result to the terminal. Run the code, and here I see another structure. And it is dict items structure. It is instance of the built-in dict items class. And here we see list of 2 pairs. And such pairs in Python are called tuples. We will talk about tuples very soon. And tuples in general are very similar to lists, but tuples are immutable in Python. You are not allowed to add new elements, for example, to this tuple. But key idea here is that we get list of pairs, and each pair represents key and value. Key and value. And it's also possible to iterate over such sequence. In such a way, we will be able to iterate over all key-value pairs in the dictionary. And we will of course do that later in the course when we will talk about for-in loop. Now let's see how we can create a copy of the dictionary. Here I'll create new variable other bike and copy to it my bike. And now afterwards let's add new key to the dictionary other bike square brackets notation. Key name here will be, let's say, color, and its value will be, let's say, red. And now let's print my bike and let's print other bike. Run the code, and I see that both variables were modified. And reason for that is the same as was when we talked about copying of the list. Now those 2 variables, my bike and other bike, point to the same dictionary in memory. And basically via other bike variable we modified just one object in memory. And therefore, when we print my bike and other bike, we see the same dictionary with new key, which is color. If you want to avoid such behavior, you have to utilize one of the methods which allow you to create new object from existing one. And for example, for dictionaries, you could use copy method. Let's run the code, and now there are 2 different dictionaries. Here is my bike dictionary and here is other bike dictionary. They are now independent. Also, it is possible to have nested dictionaries in the dictionary. This means that a value of specific key could be dictionary as well. So here for price info key, there is a dictionary as a value. And inside of this nested dictionary, there are 2 keys, price and is available. And you could easily access any key in such nested dictionary
using two pairs of square brackets. So, in such a way, we access a value of the price info key. This means we access this value. This value is also dictionary, and for that dictionary, we access price key. And in such way, we get such value, 25,000. Also, here on the next line, we get value of the isAvailable key inside of the nested dictionary. And of course, if needed, you could nest dictionaries more deeper, again, if needed. And here we could say that there is one level nesting in this dictionary. But it's important to mention that in this example, there are two different objects in memory. One object is this one, this main dictionary, and another object is this dictionary. And this key contains only pointer to that dictionary. So in this main dictionary, key price info contains pointer to another dictionary in the memory. And this is important to keep in mind when you, for instance, copy different dictionaries. And when you copy such dictionary to another dictionary, you technically copy this pointer and this pointer. So, now let's have a look at the example when we use variable names, when we form specific dictionary. It is possible to do same as with lists, and here we create three different variables: brand, bike price, and engine volume. And here we refer to names of those variables when we create new dictionary. So we put names of the variables on the right side after colons. And after such operation, you'll get a dictionary, my motorbike, with key value pairs, which you see here in the output. And of course, names of the variables and names of the keys could be different, but could be same as well. For instance, here, name of the variable and key are the same. Here, name of the variable is bike price, but key name is price. So they are different. But that is completely acceptable for Python, no problem at all. Also, it's possible to get length of the dictionary using built-in len function. And for dictionaries, such function returns quantity of the key value pairs in the dictionary. And we could say that each key value pair is just an element in the dictionary. And there are three elements in this dictionary. If we delete specific key using del statement, like this, del my motorbike square brackets price, after that length of the dictionary will be 2. But what if you want to access key which is actually absent in the dictionary? For instance, there is dictionary with 3 keys, brand, price, and engine volume, same dictionary as before, and you try to access value of the model key. This key is absent in this dictionary. In such case, Python will give you an error. Key error specifically. Because such key is absent in the dictionary. And you have to handle such error correctly in order not to stop entirely your Python application. And this means that usage of the square brackets is not always safe. And before using square brackets, you have to be sure that a specific key is present in the dictionary. And in order to avoid such errors, it is possible to use get method of the dictionaries. And when you use get method, in such example, you will not get a key error. And you will get none instead. So, if specific key is absent in the dictionary, and you try to read value of such key, get method will simply return none. Also, it's possible to specify another value which is returned in case specific key is absent in the dictionary. And in this example, such key as quantity is absent in this dictionary. And in the get method call, you could specify a second argument, which is 0 in this example, and get method will return this value in case quantity key is absent in the dictionary. If it is present, of course, get will return value of that key. Otherwise, it will return, so to say, default value for this key. And you could even utilize only get method in order to get values for specific keys. For instance, in this example, we could use get in order to get value of the brand key. Such key is present here, therefore we get Ducati. Same for price. Price is present and therefore we get 25,000. Quantity is absent, but we supply default value for this key and therefore we get 0. If you don't supply 0 here, you'll get none as a result of the get method call. And I recommend to you always use get if you are not sure whether a specific key is present in the dictionary. If you are sure, of course, you could go ahead with square brackets notation, no problem at all. Now let's have a look at the magic attribute, which is available for most objects. And this attribute is called $_doc2_. I say that it is an attribute because it is not a method. We don't need to call this attribute. We simply access it using dot notation. Again, recap that dot notation is used when you work with attributes of the object. And here in this example, we create a dictionary, it is empty, and we assign this empty dictionary to variable myDict. And as a result of accessing such attribute as doc, it is magic attribute, it is hidden, $_ tell us about that, you'll get following text output. And basically you get help about dictionaries. And you could read how to use dict function. It is a built-in dict class in Python. If you want to create new empty dictionary, you could simply call a dict function. This is basically the same as when you use simply a pair of curly braces. And also it's possible to create dictionary from other mappings. For instance, you could create list of lists, and in each list which is element of the main list, there will be 2 elements. And in such case, Python will be able to convert such mapping to dictionary and create key-value pairs. In such way, using magic attribute doc, you could read about a specific built-in class, for instance, which is dict in this example. Similarly, you could access doc, for example, for string objects or for integers. And also I would like to mention that when you create your own classes in Python, you could also add such magic attribute at the class level and return text, which will help other users of your class. And in this text you could describe what your class essentially does and how to use it. That is magic attribute doc, and that's it about dictionaries in Python. To summarize, dictionary is an ordered sequence of key-value pairs in Python. And each dictionary is mutable. This means you could mutate each dictionary. And this doesn't lead to creation of the new object in memory. Object remains the same, and you simply change it. And using square brackets notation, you could access value of specific key, you could add new key, you could delete specific key using del statement. And you should keep in mind that if you try to read specific value of the key, which is absent in the dictionary, you'll get key error. And in order to avoid such key errors, you should utilize get method of the dictionaries. Get method will return none in case specific key is absent in the dictionary. And you could specify other value, which is default value, which is returned in case specific key is absent in the dictionary. Now let's see what happens if we try to access key which is absent in the dictionary. So here is our myBike dictionary, and let's try to print myBike square brackets color. Color key is now absent in this dictionary. Let's run the code and I get here key error, color.
That's what we discussed. If you try to access value of the key which is absent in the dictionary, you will always get key error, and Python program will crash. Here we see exit code 1. Non-zero code means that Python application crashed. In order to avoid such behavior, you could first either check whether a specific key is present in the dictionary, or you could simply use get method call. Get, and here will be name of the key. For example, same as before, color. And if I run the code now, I will not get any error, and Python application will exit correctly, but now I get none, in case such key is absent in this dictionary. Also, it's possible to supply here a second argument, which is default value for specific key, and let's say that default color is black. Let's run the code, and now I get black, in case key named color is absent in this dictionary. If such a key is present, let's add it, color, and here will be white, and run the code, I'll get white. So if key is present, get method will return its value. Otherwise, if key is absent, you will get this default value for specific key. But most importantly, that when using get method instead of square brackets, you will never get an error, and your Python application will continue. So please keep that in mind. Let's get back to the dictionary without color key. To summarize, if you are sure that a specific key is present in the dictionary, of course you could use square brackets notation. Like, for example, this one. If you are not sure if a specific key is present, please use get method of the dictionary. Let's now on practice explore conversion of other types to dictionary. And let's, for example, create my string variable, and here will be string ABCD. And let's try to convert this string to the dictionary. My dict, and here will be dict. We create new instance of the built-in dict class in such way and pass here my string. Let's run the code, and here I get value error. Dictionary update sequence element 0 has length 1. 2 is required. It means that Python was not able to convert such a string to the dictionary. Because for dictionaries, Python requires pairs, keys and values. Let's do following. Let's create a list, my list, and here will be several elements. For example, A, 10, and B, 20. And let's try to convert such a list to the dictionary using similar approach. So dict my list. Run the code, same error, value error. Dictionary update sequence element 0 has length 1. 2 is required. What happens here is that Python takes first element from this sequence, which is string A, and tries to convert it to the pair, key value. But here is only one value, not two. Therefore, we get type error. But if we wrap those two elements into new list and those two elements to another list, we will get a list of two lists. Here is first list element and here is second list element. And let's see whether conversion succeeds now or not. Run the code, and now process finished with exit code 0. And let's print result of the conversion to the terminal to see resulting dictionary. And here is resulting dictionary. So now Python was capable of conversion of such a sequence to the dictionary, because now it knows how to convert such pairs to key value pairs. Very easy. In similar way, you could convert, for example, list of tuples. So here, instead of list elements, could be tuples. Let me replace square brackets with round brackets. Let's run the code, and the result is the same. And we will talk about tuples in the next few lectures. But now I think you get an idea how you could create a dictionary from other sequence. Key idea here is that sequence has to consist of pairs, like in this example.
Now it's time for the task for you, and task will be dedicated to dictionaries in Python. So, first, create an empty dictionary, and 3 times ask user to enter the name of the key, and you have to do that in the terminal, and then enter a value for this key. So first prompt, please enter first key. Second prompt, please enter value for that key. Then create a corresponding key value pair in the dictionary. And you have to prompt user to enter 3 keys with 3 values. So in total, 6 text input requests. When receiving data from the user, add keys with values to the dictionary according to what user entered. And notice that user enters actual key names, and afterwards user enters values for those keys. And finally print resulting dictionary to the terminal, and in total there should be 3 keys in the dictionary. I wish you good luck.
If you want to become data science or machine learning specialist, I welcome you to the full Python course, which covers such packages as NumPy, Pandas and scikit-learn.
We already discussed in details such data structures as lists and dictionaries in Python. And the list is an ordered sequence of elements, and lists are mutable. Dictionary is an ordered sequence of key value pairs, and dictionaries are also mutable. And now we will talk about tuples in Python. And each tuple is an instance of the built-in tuple class. And tuple is an ordered sequence of elements, same as list. But difference from the list is that tuple can't be changed. So each tuple object is immutable. You cannot mutate tuple object in Python. Let's have a look at the syntax and the structure of the tuples. In order to create a tuple, you have to use round braces. And that is a single difference from creation of the list. And inside of the tuple, you put elements separated by commas. And here you see 3 different elements in this tuple. And order of those elements does matter. Here in the next tuple there are 4 elements, and in the last tuple there are also 4 elements. And of course in one tuple you could put elements of different types, as you see in the last example. But it's common to use values of the same type in each tuple, like in myFruits variable and posIDs variable. So, here are examples of tuples, and let's have a look at the order of the elements in the tuples. If you have 2 different tuples, myFruits and other fruits, you could see that the elements are actually the same, but order is different. And in this case, those tuples are different tuples. And we could verify that by using same equality operator as we used before for dictionaries and lists, and in this example we'll get false, because order of the elements in those tuples is different. And tuples are ordered sequences. Order does matter. That's why those 2 tuples are different in terms of Python. We could very easily get length of the tuple using same built-in function which we used before. It is function len, and for this tuple we'll get 3, for this tuple we'll get 4, and for this tuple we'll get 4 as well. And as we cannot change tuple, length of specific tuple will remain the same until tuple exists. We could very easily access a specific element in the tuple using square brackets notation and ID of specific element, similarly as we do for lists. So here is no difference. Here we access this element, it has index 0. Here we access second element with index 1, and also it's possible to use negative indexes, like -1 or -2. When index is -1, we access last element in the tuple, this one. And of course, you cannot change specific element in the tuple, and if you attempt to do so using square brackets notation, and then assignment operator and new value for specific element, you'll get error. Tuple object doesn't support item assignment. This proves that you are not allowed to modify tuple. You cannot access specific element and reassign value of that element. And of course, you are not allowed to delete specific elements from the tuple. If you attempt to use del statement and put here ID of specific element, you'll get again type error. Tuple object doesn't support item deletion. You are not allowed to mutate tuple in any way. You cannot add new elements, you cannot delete elements, and you cannot replace values of the elements. Let's have a look at such tuple. In this tuple there are actually two elements, and each element is a dictionary. So here is first dictionary and here is second dictionary. And here we try to access value of the dictionary, which is actually second element in the tuple. So this dictionary. And here we successfully get 831. And we used square brackets 2 times. Here we access second element in the tuple, and here we access value of specific key in the dictionary. And if we try to modify this value in the dictionary, it will be modified successfully. So here we use such syntax. And afterwards, if you print value of the user key in this second dictionary, you'll get changed value. And reason for that is very simple. Inside of the tuple, there are just pointers to two different objects in memory. Here is first object and here is second object. And the tuple actually does not change when you perform new assignment to this key in this dictionary. And we simply go to specific object in memory using pointer and mutate that specific object. And this is pretty fine for tuples. You can mutate such dictionaries when you create tuple of dictionaries, so please keep that in mind. And that happens because dictionaries are mutable objects in Python. Let's have a look at another example where we actually use variable names in order to form new tuple. It is possible to do. Here we create 3 different variables, like myFruit, otherFruit, and newFruit, and then create new tuple based on those variables. And afterwards, in this tuple, all fruits, you'll see 3 elements: apple, banana, and lime. And after that, you are not allowed to modify this tuple. Now let's see what happens when you try to access specific element by the index, which is out of range. In this tuple there are only 4 elements, and the last index is 3. This is index of this element, and we try to access element with index 10. In this case, you'll get index error, tuple index out of range. So be careful when you work with indexes and when you use square brackets notation and when you are not sure whether specific index is present in the tuple or not. Same error you'll get when you try to perform same operation with lists. You could also combine different tuples together, but this operation does not change original tuples. So if you have such tuple and such tuple, you could very easily utilize plus operator, which under the hood will call built-in magic method add, and this is method of tuple class. And in this example, you'll get completely new tuple, which is returned as a result of this expression. And in this new tuple, which is all IDs in this example, you'll see 5 elements. we added 3 elements from the second tuple to 2 elements of the first tuple. And again, original tuples were not modified. This is very important. And you could very easily prove that using this example. So simply print internal IDs and external IDs after this operation, and you'll see that those tuples remained unchanged. Now let's examine which methods are available for tuples. And luckily there are just 2 methods, not much to remember, and those methods are count and index. There is no method to add new elements, to delete elements, for instance pop method, it is absent here, because we are not allowed to mutate tuples. We cannot change any tuple. That's why there are just 2 methods. First one counts quantity of specific element in the tuple. You could find how many times specific element appears in the tuple. And the second method, which is index, allows you to find index of specific element in the tuple. And it returns index of the first element, which you'll find first in the tuple. And same as for other objects and classes, all tuple methods are inherited from the built-in tuple class. So let's have a look at the example of the count and index methods. And here we have a tuple with 4 elements. And when you call count and pass such a number to this method, you'll get 2, because such number appears in this tuple twice. If you call count with another argument, for instance 151, you'll get 1, because such element appears in this tuple only once. If you want to use index method, you also should pass specific element in the function call, for instance 245, and in this case you'll get index of this element, this index. But there is also one more occurrence of this element in the tuple, this one, but the index will return index only of the first element. And when we call index and pass another element, for instance this one, we'll get 2. It is index of this number in the tuple. So, if element appears several times in the tuple, the index of the first occurrence will be returned. But what if you need to modify a tuple? If you, for instance, created a tuple before and you have to add new elements to the tuple, modify existing elements or delete elements, what you can do? You could convert tuple to the list, then modify a list, and afterwards create new tuple from the modified list. Let's have a look at this example. Here we create tuple with 2 elements. Then we convert tuple to the list using built-in list function. And this function basically creates brand new object, which is instance of the built-in list class. So posIDs list is now a list. And as for any list, it has access to different list methods, like append. And using append, we could append new element to this list. And afterwards, in the posIDs list, there will be 3 elements, with last element 351. And if you need to do so, after that you could convert list back to tuple by calling built-in tuple function. And this leads to creation of the brand new tuple object. We don't mutate this object, we create new object here. And this new object we could assign to the variable posIDs tuple. And the value of this variable will be now tuple with 3 elements. And technically, you could even assign result of conversion of the list to tuple to the variable posIDs, if you want to do so. And in such case, after such operation, in the tuple posIDs, there will be 1 more new element. But for that, we created 2 more new objects, list and 1 new tuple. If you don't need to convert list to tuple back again, you could continue working with list, no problem at all. You could even do following. Create a list here and assign list to post IDs. So put name of the variable post IDs on the left side here. And in such case, you will reassign value of the post IDs, and it will contain list. That's it about tuples in Python. And tuples are very similar to lists. They are ordered sequences of elements, but tuples are immutable. You are not allowed to modify any tuple in the Python. But you are able to convert tuple to list, modify list, and then convert list back to tuple if you want to do so. But in such case, you create two new objects. One object for list and one more object for new tuple. Also, there are two methods available for tuples, and they are count and index. Now let's explore tuples on practice, and please keep in mind that tuples and lists are very similar. They are ordered, but tuples are immutable. You are not able to modify tuple after its creation. So let's create, for instance, variable which will be called screen resolution. And its value will be a tuple with two elements, 1920, and here will be 1080. And now let's print screen res, and also let's print type of screen res, and also let's check whether screen res is instance of the built-in tuple class, like that. Let's run the code, and here we see this tuple. Those round braces signalize us about that. Also here we see that this object is instance of the built-in tuple class, and here we also get true. Screen res is instance of the built-in tuple class. Now let's see which methods are available for tuples. Let's type screen res and add dot, and here we see just two regular methods, such as index and count, and bunch of magic methods. Here they are. Let's use the index method, and this method expects from you specific element. Let's pass here 1080 as argument, and let's see what we get in the output. Let's run the code, and here I get 1. It means that in such a way, using index method, we are able to find index of specific element in the tuple. And if there are several occurrences of the same element, for example, here we will add 1080 again, and run the code, we still get first index of this element. So we don't move further to next elements in the tuple. Let's remove this element, and let's now use another method, which is count. And we can also pass here an element, for example, the same, 1080, run the code, and I get 1. It means that such element appears in this tuple only once, here on this place. And if I add again this element here, run the code, I'll see here 2. So this element appears now twice in this tuple. These are basically just two methods available for tuples. And what if you need to add new element to the tuple? So what if you created this tuple and then you want to modify it? Or for instance, you want to replace specific element with another element. If you need to do so, it means first that you have chosen incorrect data structure for this variable, because tuples are usually chosen when you don't want to modify this tuple later somewhere in the code. So you create immutable sequence. That's when you should choose tuple as a data structure. But it might happen that you need to modify a tuple. In such case, the easiest way to do that is to convert tuple to the list and afterwards modify a list. How to do that? Let's create a new variable, screen res list, for instance, and here we will create new instance of the built-in list class by using list function, and here we will pass screen res as argument.
And afterwards, you are able to work with list same as you usually do with any list. For instance, you could modify element by its index using square brackets notation. And here, for instance, I could replace this value with another, for example, 1444. And afterwards, I could print screen res list. Let's run the code. There are no errors, and here I see a list where this element 1920 was replaced with this value. And afterwards, if needed, you could convert list back again to tuple using tuple class. And you could do that like that, tuple, and here we will pass screen res list as argument. And result of the conversion to tuple, we could assign even to the same variable screen res, which holded this tuple at the beginning of this code. And let's do that, screen res, assignment operator, and then let's print screen res to the terminal. Run the code, and here we get new tuple. But I want to emphasize that we didn't modify this tuple. We created new tuple here on this line of code and assigned new value to the screen res variable. That's why here we see brand new tuple. And we could prove that by printing ID of this object. Here, after its creation, let's print ID of the screen res, and I'll copy this line and do the same at the end. So print again ID of the screen res after reassignment of this new value. Let's run the code, and here I get two different IDs, which proves that we basically have here two different tuples. Here is original and here is new tuple, which we create by converting list, which we created here, to the tuple. That's how you could modify a tuple if needed, and that is only possible via conversion to another data structure, for example to list, as we did here. Also, it's possible to merge different tuples together and create new tuple. Let's do that, and let's assume that here will be a tuple which is called, for instance, screen info. And here will be few elements, for example, true. Next will be, for example, brand, Samsung, and afterwards will be price, for instance, 150. And we want to merge those two tuples in new tuple. For that, we could utilize plus operator. And let's create a new variable, screen data, for example, and it will be a result of the screen res plus screen info. Let's print screen data to the terminal and see what we get. And we get such a tuple with 5 elements. 2 elements from screen res tuple and remaining 3 elements from screen info tuple. Here I see that screen info is underlined. Let's see what we see here. And here we see actually informational warning about unexpected types. Because here we created a tuple which has only integers, and here we have a tuple with other types. And in such cases, PyCharm will produce such a warning. But you could safely ignore it if you want indeed to combine such two tuples into one tuple, as we did here. But key idea here is that we didn't modify existing tuples. We don't modify this tuple and this tuple when we combine two tuples together. And we could ensure that the tuples were not modified by printing them to the terminal. Let's print screen res and let's print screen info, like that. Run the code and we see unmodified original tuples. And of course, after merging of two tuples into one tuple, you will not be able to modify this tuple, screen data. But of course, you could read information from that tuple. For instance, using square brackets notation. Let's print, for instance, screen data, square brackets, 0. That's first element in the tuple. Let's run the code, and here I get this value. This is the first element in this tuple. Also, it's possible to use negative indexes. Let's copy this line, and here I'll put -1. Run the code, and now I get last element from this tuple. So you could very easily access any element in the tuple by its index. And definitely it's possible to iterate over all elements in the tuple, using, for example, for in loop. And also it's possible to check length of the tuple. Let's print length of screen data. Here we are. And we get 5. Because this tuple has 5 elements. These are operations which you could perform with tuples. And if you don't want to modify specific data structure, which is sequence, in the future, you should use tuple as data structure and avoid using list. So that's where key features of the tuples in Python.
Now let's talk about the most powerful data structure, in my opinion, in Python. And this data structure is called set. Set is an ordered sequence of elements. So order of the elements in the set does not matter. Same as for dictionaries. But sets are completely different from dictionaries. And difference is following. The set contains only unique elements. Set cannot contain two same elements. All elements are always unique. And sets are mutable in Python. This means you can change sets. You could add new elements, you could remove elements, you could merge different sets. All of that is possible for sets. And the sets usually contain objects of the same type. For instance, integers, or strings, or floats. And it's not common to mix different types of values in the sets. Let's have a look at the structure and syntax of the sets. In order to create a set, you have to use curly braces, same as for dictionaries. But inside you put simply elements, not key value pairs: apple, banana, and lime. And order in which you put those elements to the set does not matter. You could change order as you wish. Here is another set which consists of 4 elements. And in this set and in this set, elements have the same type. In the first there are strings, in the second there are integers. And in the last we mix different value types, like boolean, string, and float. Set, of course, could contain elements of different types, but as I mentioned, it's not common practice to put values of different types to the same set. That's how you could create sets, and for that you have to utilize curly braces, same as you do for dictionaries, but sets are completely different from dictionaries. And you could verify that such data structure is actually set using type function. We could create a set here, then output set to the terminal using print function. Here we see set, which consists of 3 elements. And afterwards, when you print type of the myFruits object, you'll get class set, which proves that this object is an instance of the built-in set class. Now let's have a look at the following example. In this example, we create a set, but in this set there are same elements here and here, and also here and here. So there are duplicate elements. And interesting that after such operation, when you print both IDs, you'll get set only of 3 elements. And that's because set contains only unique elements. And here you will not get any error. Python will create a set, and it will not tell you that there are duplicates. But it will remove all duplicates, and that happens automatically. So all duplicates are removed when you create a set. And still, data structure here is a set, as we see as a result of the type function call. Next, as we discussed, order in the sets is not important. This means that those two sets, my fruits and other fruits, are completely the same. And we could prove that by using equality operator, my fruits equal operator, other fruits, we get true. Those sets first contain same quantity of the elements, 3, and elements are the same. Apple, banana and lime. That's why sets are the same. Also, it's possible to use built-in len function for sets in order to find quantity of the elements in the set. Here, for this set, you'll get 3 as a length of set, and here you'll get 4 as a length of this set. And also, please notice that elements have no indexes. You cannot use square brackets notation and put index of specific element in the set, because sets are unordered sequences. And in this case, you'll get simply type error. Set object is not subscriptable. What is subscriptable, we will see on practice. And in general, you are not able to get specific element from the set using square brackets notation, because elements don't have indexes. But what about such set? Is it possible to create a set of lists, for example, or set of dictionaries? No, it's not possible. Because in this example, if you attempt to create such set, you'll get type error, unhashable type list. And this means that you are not allowed to add mutable objects, such as list, dict or other set, to the set. Why is that? Because, as we discussed, each set contains only unique elements. And in some way, Python should have a specific mechanism which allows to check uniqueness of specific element in the set. This is needed when you attempt to add new element to the set, because sets are mutable, you are allowed to add new elements to the set. But how Python will verify that new element is present in the set, or maybe it is absent in the set? For this purpose, Python actually creates special hash for each element in the set, and it compares different hashes. But Python is not able to create a hash for the list or for dictionary, because lists and dictionaries are mutable. You could add, for example, list to the set and afterwards later modify list, and this will lead to modification of the element in the set. And probably there is another list, same list in the set. And in order to avoid such hectic problems, in Python you are not allowed to add mutable objects to the set. And those objects are lists, dictionaries, set, or user-created objects. Objects which you create based on your classes, on user-defined classes. So, general rule. Sets could contain only immutable objects, such as strings, integers, floats, booleans, or, for instance, tuples, because tuple is immutable object in Python. Also, it's not possible to use del statement in order to remove a specific element from the set. Because again, reason for that is that elements in the set don't have indexes. And you cannot utilize square brackets notation in order to access specific element in the set. Sets are unordered. And in case you try to attempt delete specific element in the list using square brackets notation, you'll get type error. Set object doesn't support item deletion. But because sets are mutable in Python, you can add new elements to the set, and you could remove elements from the set, but not with del statement. For that, you have to utilize set methods, which are inherited from the built-in set class. Let's now have a look at the sets on practice, and let's start by creating my set. And here on the right side of the assignment operator will be set, curly braces, and here let's put few numbers, 10, 5, again 5, 100, again 10, and let's add also 20. And next let's print my set, and as usually let's print type of my set, and also let's print isinstance. Here will be my set, and after comma will be set, which is name of the built-in class. Let's run the code, and we see here a set, and notice that any duplicates from this line were removed, and we didn't get any error. So it's acceptable to add duplicates in original line where you create actually a set, but Python will filter out any duplicates, and result we see here. This means that length of the set will be, in our case, 4. Let's print length of the set as well. So here is 4. Also, we see that this object mySet is instance of the set class, and here we see that mySet is instance again of the set class. Alright, that's how we created a set. And now let's try to access specific element of the set by its index. mySet, square brackets, 0. Let's run the code, and here I immediately get type error on this line. Set object is not subscriptable. And process finished with exit code 1, of course. And what does it mean? It means that we are not able to access elements in the set by the index, because sets in Python are unordered. Each element doesn't have its unique index. And if you get such an error, it basically means that specific object, in this example mySet, doesn't have certain magic method, which is called getItem. Let's check that my_set dot two underscores, and let's try to find here getItem method. It is absent here. And that's the reason why we actually got an error, and why we are not able to access specific element by the index. But if we modify mySet to myList, here will be myList and here will be myList as well, and let's replace curly braces with square brackets like that. In such case, if I add dot and add two underscores, I'll see such method as getItem. Here it is. And I could call this method directly, and here let's put 3 as argument, and let's print result to the terminal, like that. Run the code, and I get 100. This is this element in this list. And of course, in this list we have all 6 elements, because lists allow us to use duplicate elements inside of them. But key idea which I wanted to demonstrate to you is that if a specific object has access to the getItem magic method, it means that specific sequence is basically ordered, and we are able to use specific index to get element by this index. Same applies to strings. For example, if I create here my str, and here will be, for example, such a string, next to it I could again try to access getItem method, which is obviously available for strings, and I could pass here, for example, 6 as index of the element which I want to get from the string. Because each string is a sequence of characters, and each character has its unique index. Index starts as usually at 0. And therefore, in such case, we get specific character. This one in this example when we call getItem method. But other objects, like sets, as we already verified, don't have access to such magic method. In other words, such magic method is not defined for specific class. And now quick task for you. Please ensure also that such magic method as getItem is absent for integers. We continue, and let's get back to my set here,
my set, and let's again add several elements like 10, then true, then ABC. It's basically possible to mix different value types in the set, but it's most common to use values of the same type. For example, only integers or only strings. But such set is also acceptable. And if I print to the terminal my set, I'll get, of course, resulting set here in the output. Set with 3 elements. And notice that here in the output, order of the elements differs from the order of the elements here. That proves that order of the elements in the set doesn't matter. And therefore, you are not allowed to get specific element by its index. Alright, now let's try to add to this set, initially add, element which will be, for instance, a list. List with 2 elements. Let's run the code, and I get here type error. Unhashable type list. And as we already discussed, you are not allowed to add to the set mutable objects, like lists or dictionaries. Because Python is not able to create a hash for any mutable object, in order to be able to keep it unique in the future. Let's try to replace this list with dictionary, pair of curly braces, and here will be, for example, key A, and value will be, for instance, true. Run the code, and again same type error, unhashable type dict. Also, if you attempt to add another set as element of the set, like that, you will get same error. Here it is, unhashable type set. Sets, lists, and dictionaries are mutable objects in Python. Therefore, you are not allowed to add them as elements in the set. And we just verified it. Now let's assume that you want to create an empty set and add elements to that set in the future. Let's try that, my underscore set, and here if I simply use pair of curly braces and print my set, and print also type of my set, like that, I'll see that it is an instance of the dict class, not set. Therefore, you are not allowed to create empty set like that, because in such way you create empty dictionary. If you want to create empty set, you have to use set variable. So, create instance of the set class like this. And in such way, you'll create empty set. And now my set is an instance of the built-in set class. And afterwards, you could add new elements to this set. And for that, you have to utilize one of the set methods. And set methods we will try soon. That's it about sets, and sets are first unordered, and sets are mutable. You are able to modify any set in Python. Before moving on to set methods, I would like to talk about different operations which we could perform with sets. And sometimes there is a discipline called Set Theory or Theory of Sets, which is studied by students at the universities. And I personally studied such discipline. And let's draw sets and discuss which operations are available for sets. And let's draw 2 different sets. Here is first set and here is second set. So here is set A and here is set B, like this. And you see here intersection of 2 different sets. And in this intersection there are elements which are present in both sets, A and B. And remember that each set consists only of unique elements. And here are also unique elements. So this part is intersection. Of course, sets could not intersect if they contain completely different elements. But in this example, there is intersection. Also, there is a union. When we combine all elements from one set,
with elements in the second set, including intersection. And of course, when we create a union, when we unite two sets, we remove duplicates, because elements in this section, in intersection, will appear twice in the resulting big set. That's why in that set we simply remove duplicates. But it is a union when we combine all elements from two different sets. Let's move on. Next operation is difference. And we could find difference between A and B. And in this case, result will be following. All elements in the set A which are absent in the set B. So, technically, we remove from the set A intersection of A and B. So this part is removed. Also, we could find difference of B and A. In this case, we leave only elements which are present in set B, but remove elements in intersection. Remove elements which are present in the set A. So this is B minus A. Also, it's possible to find symmetric difference. And symmetric difference is following. That's when we put elements which are present in A and absent in B, and add elements which are present in B and absent in A. So technically, first we perform set union and remove from the set union elements which are in intersection of two different sets. That is called symmetric difference. Alright, but what if two sets are like this? Here is big set and here is smaller set. And in this case, we could answer the question whether this set is subset of this bigger set. And in this example, answer is yes, or true. This is subset of bigger set. But if sets are like this, of course, this set is not subset of this set. And same applies to this set. This set is not subset of this set. And same works in case there are two completely different sets, like this. This set is not subset of this set. Only in this case, when all elements of this set are present in bigger set, this set will be subset of bigger set. And this bigger set, this one, is called in this case a superset, which is actually bigger than this smaller set. These are most common operations with sets, and most commonly it is needed to find union of the sets and intersection of sets. And next we will talk about methods which are available for you in the built-in set class. Keeping in mind that sets are unordered and sets contain only unique elements, let's talk about set methods. And there are a lot of different set methods which are available for you when you want to perform different operations with sets. And those methods, for example, allow you to add a new element to the set. This is add method. Union allows you to find all common elements in two different sets. Remove or discard allow you to remove a specific element. And those methods work a bit differently. Intersection method allows you to find elements which are located in both sets, so intersected part. Difference allows you to find elements which are in one set, but not in another set. Clear helps you to remove all elements from the set. With copy, you could create a brand new set from another set. Because as you already know, sets are mutable objects in Python. And you would want to create a copy of existing set and modify copy. For this case, you could utilize copy method. Also, you could add elements from one set to another set. And for that, you could utilize update method. Is subset and is superset allow simply true or false, depending whether specific set is subset of bigger set, or superset of smaller set. So those two methods return true or false. And also there is one more interesting method which is called pop. And pop removes a random element from the set and returns this element. So let's talk about methods in greater details. And before we start, always keep in mind that methods of specific object are inherited from corresponding class. And in case with sets, all set methods are inherited from the built-in set class. Let's start with add method, and using add method you could add new element to existing set. So here we create a set which contains two strings, two elements, and here we call add method and add new more element to existing set. And because there is no such element in this set, this element is added. And after this operation there are three elements in the set. And all elements are, in this example, unique. If you attempt to add element which is already present in the set will not be changed. Now let's have a look at the method called union. And using union you could find all elements which are either in one set or in another. So you find all elements, you merge two different sets. And here there are two sets, first one and second one, and one element, this one is common, here and here. And this means that when you call union method, you'll get completely new set, those two sets are not modified, and this new set, which is called all sizes in this example, contains all elements from two sets, and of course doesn't contain any duplicates. By the way, it is also possible to unite two different sets, to merge two different sets using OR operator. It is single vertical line. And result will be the same. Either call union method or use OR operator. And next comes intersection method, and using intersection you could find only elements which are in both sets. And here again we work with same sets, and they have only one element in common, this element. And this means that intersection method will return set with one element. And the same as union, intersection doesn't modify existing sets. So here we could find only common elements from two sets. If there are no common elements in two sets, then intersection will return empty set, of course. And instead of intersection method, you could also utilize AND operator. You could write photo S and other S, and you'll get same result. So AND gives intersection of two different sets. Now let's have a look at the isSubset method and isSuperset method. And let's start with isSubset. In this example, all elements from this set belong also to this set. And this set is bigger or equal to this set. And in this case, isSubset method will return true. And we call this method for first set. And we ask Python whether this set is subset of other nums set, whether all elements of this set belong to this set or not. And answer here is true. But if, for instance, here in this set would be 6 instead of 5, then this set will no longer be a subset of other nums set. All elements of one set must be also in another set. Only in such case you'll get true as answer to this question, whether one set is subset of another set. And what is the result of union of such two sets? How do you think? Of course, this set. If one set is a subset of another, bigger set, then when you perform union of such two sets, you'll always get bigger set. if you perform intersection of such two sets, you'll always get smaller set, this one, because it contains elements which are common in both sets. And now let's have a look at the isSuperset method. This method verifies whether one set contains other set. And we could work with same example and ask whether all elements of the nums set are included in other nums set. In other words, whether other nums is bigger or equal to nums set. And in this case, we'll get true, because all elements in the nums set are included in other nums set. So other nums set is superset of the nums set. That's all about primary methods which you could utilize with sets, and you could find intersection, common elements. You could find all merged elements. For that you could use union method. You could find difference of one set and another set. And also it's possible to check whether one set is subset of another set or whether one set is superset of another set. Also, there are many other methods for sets available, and you could perform all available operations with sets. And you should keep in mind that the set is unordered sequence of elements, and also sets are mutable in Python. You could add new elements, you could remove elements, and so on. And also in the sets there are only unique elements. And Python creates special hashes for each element in the set in order to ensure that all elements remain unique. And for that special reason, you are not allowed to add any mutable objects to the set. You cannot add lists, dictionaries, or other sets to the set in Python. Let's now explore different set methods on practice, and we will see how to add new elements to the set, how to remove or discard elements in the set, how to find union, or in other words, how to combine all elements from the two sets together. And next we will also talk about finding intersection and symmetric difference. Let's start by creating my set, and it will be set with different numbers, for example 10, 2, 10 again, 5, and here will be 7. Let's print my set here, and afterwards let's using add method, let's add one more element to the set. Let's call this method, and it expects from you an element which you want to add to existing set. So here is element. And let's say that we want to add element 8. Let's print my set afterwards, run the code, and here I see original set. Obviously those duplicates were removed and only one element 10 remained here in the set, and original length of the set is 4, and afterwards we added new element to this set, and now length of the set is 5. And as you might see here, this element appears in the output before 10. So Python internally modified order of the elements. But again, each element doesn't have its unique index in the set, and we already checked that before. Great. Now let's try to remove element from the set. And for that there are two methods, and they are discard and remove. Let's first try remove, and let's remove element 5 from the set. Here let's pass 5 as argument, and let's print my set afterwards. Run the code, and here we see modified set where this element is already absent. Now let's try to remove element which is basically absent in this set. For example, element 200. Let's run the code, and here I see that we got actually key error 200, and it happens each time when you attempt to remove element which is basically absent in the set. That's what we actually try to do here.
And if you are not sure whether a specific element is present in the set or not, you should use discard instead of remove. So let's replace remove with discard, run the code, and now I get no error. And basically after such discard operation, this set was not modified. There are still 5 elements in it. That's the difference between discard and remove. Discard silently moves forward if there is no specific element in the set. It doesn't produce any error. Remove generates an error. That's how you could add element to the set and how you could remove a specific element from the set. And next, let's add one more set and find intersection and union of two sets. Let's name other variable other set, and let's put in it some elements, for example 34, 1, and here will be 10, and here will be 5. As you might see, there are some overlapping elements. For example, this one is present here, and this element is present here and here. Other elements are different. So let's first try to find common elements in those two sets, in this one and in this one. For that, there is a method which is called intersection. So let's call this method for one of those sets. It basically doesn't matter for which of those sets you will do that, either for this or for this. In both cases, you'll get the same result, and we will see that right now. So my set, intersection, and let's pass here other set as argument. And let's print result to the terminal and see what we get. We get set with two elements, 10 and 5. Those elements, as we already discussed, are common in those two sets. Now let's try to do the same but in opposite way. So let's print other set dot intersection, and here will be my set. Run the code and result is exactly the same. So this operation is actually symmetric. There is no difference how you call intersection, for which of the sets, this one or this one. And what is interesting, here in the intersection method call, you could pass other sequence, for example, list or tuple. Let's print, for example, my set dot intersection, and in the call to this function, as you might see here in the description, you could pass any iterable, any sequence. And let's put here a list with several elements like 2, 100, 200, and let's see what we get. We get set with just one element, because this sequence has only one element in common with this set. And this proves that you could call intersection method and pass to it any other sequence. Tuple also works. Let's use here tuple. Run the code and result is the same, set with just one element. Also, it's possible to do the same using just one operator. And we could find intersection of my set and other set by using ampersand between them. It is AND operator. So my set and other set. Let's see results. And here I get same set as here and here. This is more shorter and cleaner way to find all common elements in two sets. So just AND operator. Alright, that's how to find common elements. And now let's try to find all elements from two sets. Let's merge two sets. And for that you have to utilize union method. Let's print my set dot union, and here let's pass other set as argument. Run the code, and here we get such set. And of course all elements here in this set are unique. Duplicates were removed. We know that this element is present here, and this element is present here and here. And Python takes care about uniqueness of all elements in the set. Also, you could do the same for other set. Print other set dot union, and here will be my set. Result will be exactly the same. But order of the elements here in the output is different, but that does not matter. So sets are the same. And if you want, you could even compare two different sets using comparison operator. And let's do that here below. Print, and I'll copy this part from here, paste here, add comparison operator, and now let's copy this and paste here. So we compare two different sets. Let's see result, and as expected we get true. So those two sets are identical. Length is the same and elements in those sets are the same. Also, it's possible to use OR operator in order to perform same action, find union of two sets. Let's use this operator, my set, then will be OR operator, it's just vertical line, and then will be other set. Let's run the code, and here we get same set as we got here above. Same elements are present in all those sets. And I recommend to you to use OR operator in case you want to find all elements which are present in those two sets, and use AND operator if you want to find intersection. Except methods which we already discussed for sets, there are other methods available. For example, you could create a copy of the set. Set copy, and here we could use other set and then call copy method. And next, let's modify set copy by adding new element to it. And for example, here will be 200. And then let's print set copy, and also let's print other set. Run the code, and here we get two different sets. And when we added 200, we added it just to set copy set. And this set remained unchanged. That's what happens when you create a copy of the set. But if you don't use copy method and copy just variable other set into set copy, you'll end up actually with the case when two variables point to the same object in memory. Similar behavior we observed actually when we worked with lists or dictionaries. So here we modified just single object in memory. Sets recap are mutable in Python, and now in this scenario set copy and other set point to the same object in memory. Also, there are other methods available for sets, and you could get entire list by pressing dot here and looking at this list. There is difference, difference update, and others. Let's check those two methods, isSubset and isSuperset, and let's check whether my set is subset of the other set. Let's print result to the terminal, print, run the code, and here I see false. It means that my set is not subset of other set. But if I keep in this set only those elements, 10 and 5, and run the code, I get true. Because now my set is subset of other set. In other words, all elements from this set are present in this set. And in opposite way, other set now is superset of the my set. Let's check that. Other set dot is superset, and here will be my set. Run the code, and in both cases I get true. So my set is subset of other set, and other set is superset of the my set. And same result you'll get if sets are equal. For example, if here are just two elements, like that, you'll get true in both cases. So set has to be bigger or equal in order to get true here as a result of those method calls. That's where most commonly used methods for sets in Python. Now let's explore on practice method which is called symmetric difference. And using such method, it is possible to find elements which are present in different sets but are absent in their intersection. It means that using such method, we could find elements which are present either here or here, but are absent here in this intersected part. Let's do that, and let's create two variables, my set, and here will be, for instance, some letters, some characters, A, then here will be, for instance, C, then here will be D. And next let's create other set, and here will be such elements as L, M, and let's add one common element, C. And C is present here and here. And let's find symmetric difference. My set dot symmetric difference, and let's pass other set as argument in the symmetric difference method call. And let's print result to the terminal as usual. Let's run the code, and we get a set with 4 elements, M, L, D, A. As expected, C is absent in resulting set. So we found elements which are present either here or here, but are absent in the intersection of those two sets. In other words, we could rewrite such expression using and or operator. Also, we could use minus operator. If you want, you could pause video now and try to find symmetric difference using just and, or, and minus operators. Let's do that together. And what we have to do, we have to find union of two sets and find intersection of those two sets. And from the union of two sets, we have to deduct intersection of those two sets. If you want to find union of two sets, you could either use union method or use or operator. And for simplicity, let me rename those two sets to A and B. And here will be also A instead of my set, and other set I'll rename to B, like this. So, we could find all elements in those two sets by using OR operator, A or B. Let's put this expression into round braces in order to ensure correct order of operations. And next, from this union of two sets, let's deduct intersection of two sets. And intersection could be found using AND operator, so A and B. Let's print result to the terminal and see what we get. Run the code, and we get the same result as we got here when we called symmetric difference method. So such expression is equivalent to symmetric difference method call. We find first all elements which are present either in the set A or set B, and then deduct from result all elements which are present in the intersection. That was symmetric difference method, and it is useful when you need to find elements which are present either in one set or in another, but are absent in the intersection.
Now it's time for the task for you guys. And this task will be dedicated to sets, of course. So, please create a set which will contain several elements of the type int. Next, add another element to this set. Create another set with several elements, and some of those elements in the second set should be the same as in the first set. Find common elements in two sets and place them in the new set. And convert resulting set to the list and print the list to the terminal. And also optionally, you could find all elements in two sets, and you could find difference between first set and second set, and difference between second set and first set. Those are optional parts of this task. I wish you good luck.
If you want to learn how to create games in Python, I welcome you to the full course, where you'll create several games using Pygame package.
Let's continue, and now let's talk about one more built-in class, which is called range. And range is an ordered, immutable sequence of elements in Python. And ranges are typically used in loops. For instance, you could create a range and loop over elements in this range. Let's have a look at the structure and syntax of ranges. Ranges are created by calling built-in range function, which basically same as other built-in functions like list, dict and others, creates a new instance of the range class. And here we pass a number. And in this case, this will automatically create a range from 0 to 7. And if you check type of the myRange object, you'll see that it is instance of the range class. And if you print myRange, you'll see such result, range from 0 to 7. If you, for example, convert a range to list, you'll see list with 7 elements, from 0 to 6. And technically, range is just a sequence of elements, from 0 to specific number if you supply here maximum value for range. So this value is not included. To summarize, each range is an instance of the range class, and you could create a range by calling built-in range function and passing to it an integer. Also, it's possible to create a range with specific step, and also you could optionally add the start point for the range. And here in this example, there are 3 arguments in this function call, 10, 20 and 3. Last argument, third one, is step for the range. And in this example, range will look like this, 10, 20 and 3. And if you convert range to the list, you'll see 4 elements in the list. We start at 10, then step is 3, we add 3 to 10, 13, then plus 3, 16, and plus 3, 19. And 19 is less than 20, but 19 plus 3 is greater than 20. That's why we stop here. And as I said before, ranges are suitable when you perform loop operations. For example, if you want to perform a specific action 7 times, you could very easily create a range, and no need to create other variable, list or, for instance, tuple. Create range and loop over range elements and perform specific tasks, for example, 7 times. That's what ranges are used for. Also, each element in the range has index, and indexes as for lists and tuples start with 0. So first element has index 0, next element has index 1, and so on. In this example, this range has only 4 elements, that's why here we get results. But if you try access element which is absent in the range, you'll get index error, range object index out of range. So be careful with that and don't attempt to access elements in the range which are out of range. So, using ranges in the loop. Here you see example where we create a range before actual loop, and then using for in syntax. By the way, we will talk about for loops a bit later in the course. But using for in syntax, you could iterate over all elements in the sequence. So in for in loop, you could utilize any sequence in Python. For example, list, tuple, or range. So here we iterate over elements of the range, and we perform action print n. N is variable which is created in this for in loop, and this loop will be executed actually 4 times, because this range has 4 elements, and you'll get the value of the variable n on each iteration. And you'll see numbers from 10 to 19. These numbers are elements from the range. Of course, you could go ahead without creation of separate variable, like in this example, and you could create a range directly here in the for in loop, for n in range. And this is how ranges are utilized most often. That's all about ranges, and the range is an ordered sequence of elements, and in the range, each next element is greater than previous element. And you could create ranges with default step, which is 1, for example, from 0 to 8, from 0 to 100, or you could specify start, end, and optionally step for the range, and create a range, for example, from 100 to 200 with step 10, and then perform some actions. And in most cases, ranges are utilized in the for-in loops, in order to repeat specific action or actions multiple times. That's it about ranges in Python.
Now let's explore ranges on practice, and usually ranges are used when you need to perform specific actions n times, for example 100 times, or let's say 10,000 times. Let's create a range, and the variable name will be, let's say, my range. And here we will create a range using range class. Range, and here let's pass, for example, 5. And let's print my range and see what we get. We get a range from 0 to 5. And my range is instance of the built-in range class. Now we could perform iteration over elements of this range, using, for example, for-in loop. For num in my range, let's print num to the terminal. What we do here, we iterate over this sequence, my range, and on each iteration, value from the my range sequence will be assigned to the variable which we called num. Obviously, we could choose other name for this variable if we want to do so. And here in the body of this for loop, we will print num. And we will do that as many times as there are elements in the my range. Let's see what we get. Let's execute code, and here in the output I get integers from 0 to 4. This means that range has actually 5 elements, from 0 to 5, but 5 is not included. So 5 is the upper boundary for this range. And here we performed iteration over this range. Similarly, we could perform iteration over bigger range. For example, here could be 5,000, like that. Let's run the code now, and now I get last element as 4,999. That was iteration over range, and also it's possible to specify starting value, ending value, and step. For instance, you could create a range from 10 to 20. Let's run this code, and here I get numbers from 10 to 19. It means that 20 is not included. But step remains here 1. This means that by default iteration step is 1, but if you want, you could add here third argument, like 3 for instance, and then step will be 3. Let's run this code, and here we get only 4 elements in the range. 10, 10 plus 3, 13, then again plus 3, 16, plus 3, 19. So in total, 4 elements in this particular range. Let's say that you got a task to find all odd numbers, for example, from 1 to 100. With ranges, it's very easy. So if you need to find odd numbers from 1 to 100, you could create a range from 1 to 100, like this, and step will be 2. And let's, for example, convert range to the list, print list my range, in order to see result in the terminal. Let's run the code, and here I see all odd numbers from 1 to 100, but 100 is not included. Similarly, we could find all even numbers. Let's rename this variable to odd, nums, and here will be even nums, and on the right side will be range, and we start at 0 and end at 101, let's say, because we want to include 100, and step will be 2. And here let's replace my range with odd nums. Again, we convert range to list in order to see result in the output, and let's print also list even nums. Let's run the code, and here I see all odd numbers, and here are all even numbers from 0 to 100. To summarize, using ranges, you could very easily find either odd or even numbers. Now let's have a look at the methods which are available for each range. And let's keep odd nums range, and let's type here odd nums, add dot, and here we see all attributes and methods available for this particular object. And we see such methods as index and count, which are basically self-explanatory. And we could call index and pass here, for example, 50 as argument. And let's see what we get. We get value error. 50 is not in range. So in this range, 50 is absent, therefore we got such a value error. But if we try to find index of the element 51, we'll get result, and it is 25, so no error, because such element is present in this range. Also, it's possible to call other method, which is count. Let's call it count. And here let's pass also 51 and run the code, and obviously we get 1. Because in the range all elements are basically unique. And therefore count method will always return 1 if element is present in the range. If element here will be, for example, 50, and this element we know is absent here in this range, we'll get 0. So there is no such element in this range. But what if we try to modify this step to float number, for example, make it 2.5? If we run the code, we'll get type error. Float object cannot be interpreted as an integer. It means that in ranges you could use only integers as minimum, maximum, and step values. Here they are. Also, odd nums object and other instances of the range class have certain own attributes. Let's have a look at them. Let's again type odd nums add dot, and here are 3 attributes: step, stop, and start. Let's type simply step and hover mouse over step. And you'll see that it is a class attribute step of range. And its value is an integer. Let's simply print to the terminal odd nums step. We don't need to call step, because step is attribute, and it simply holds an integer as a value. Let's run the code, and here we get 2. This is step which we defined here. Also, there are other attributes available for odd nums. Let's print them as well. Odd nums.start, and let's print odd nums.stop. Let's run the code, and here I get 1, 100, and 2. These are values of those 3 attributes: start, stop, and step. And we defined those values here when we created new instance of the range class. And of course, those attributes are own attributes of this odd nums object. How we could verify that? Very easily. If we type simply range here and add dot, we will see step, stop, and start. And if we select, for example, step, let's do that, and print it to the terminal, let's run the code, we'll get member step of range objects. And that proves that step is basically own attribute of each instance of the range, and therefore values for start, stop, and step will be unique for each particular instance of the range. Let's create here one more range, for example, my range, and here will be range from, let's say, 5 to 8, and below let's print my range dot start, and also let's print my range dot stop, and similarly let's print here my range step. Let's run the code, and here I get 581 for second my range, this one, and I get same as before 102 for the first range. This proves that those ranges are of course different, and they have own attributes like start, stop and step. And they are defined when we actually create instance of the range. Here we create first instance of the range and check its attributes, and here is second instance and its attributes start, stop and step. That's where ranges are mostly used in the for in loop, when you have to perform a specific task or set of tasks specific number of times. And also using ranges you could very easily build specific sequence. For example, 0, 10, 20, 30 and so on. Or 100, 200, 300 and so on. And do whatever you want with such sequence. Also, it's possible to convert range to sequence, for example, list or tuple. Let's do that quickly. Print list odd nums. Let's also print tuple odd nums. Let's also print set odd nums. And let's try to convert to dict this range. Dict odd nums. Let's run the code, and here I get three sequences. Here is list, here is tuple, and here is set. Obviously in the set there are all unique elements, because in the range itself there are all unique elements. Therefore length of all those sequences is the same. Here we see that. And if we try to convert range to dictionary, obviously we get type error. Cannot convert dictionary, update sequence element 0 to a sequence. And we discussed already reasons for that before. If you need to convert specific sequence to dictionary, it has to contain pairs of elements for key and value correspondingly. Therefore, here we get type error. That's it about ranges in Python. We already talked about different sequences in Python, like lists, tuples or strings. And now let's talk about built-in functions which could be utilized for any sequence. And those built functions are len. Len gives you length of specific sequence. For example, length of the string or length of the list. In such case, it gives you quantity of the elements in the list. Or you could use length, for example, for dictionary. In such case, you'll get quantity of the keys in specific dictionary. Sum allows you to sum all elements in the sequence. And in such case, you could sum, for example, all elements in the list or all elements in the tuple. Min and max find minimum and maximum value in the sequence. Filter allows you to filter specific sequence and find only elements which satisfy specific condition. Map allows you to perform some actions with each element in the sequence, and map returns new sequence. Also, another built-in function which is called sorted allows you to sort elements in the sequence. And you could sort, for example, elements which are integers in ascending order or descending order. Reversed allows you to reverse order of the elements in the sequence. For example, reverse order of the elements in the list or tuple. Zip performs merging of different sequences. And you could merge, for example, two lists or two tuples or list and tuple into the zip object. And afterwards, zip object could be converted to dictionary. One more built-in function, which is called enumerate, allows you to use specific sequences in for loops. And enumerate basically adds specific counter to iterable and returns such counter. And you could perform iteration over elements
in specific sequence. And next, let's talk about a built-in function which is called zip. Zip is one of the built-in functions in Python. And let's have a look at a few examples related to built-in zip function. Here we have two different sequences, and they are lists. Here is list which contains strings, and here is list which contains integers. And length of those two lists is the same, it is 3. And we could call built-in zip function and pass to it two arguments, fruits and quantities. Here are two lists. And zip function will essentially return a zip object. And if you simply print fruit quantity zip to the terminal, you'll see that. So zip object. But you could convert this zip object, for example, to list by calling built-in list function. And after such operation, you'll see that fruit quantities list object contains list of tuples. And each tuple has two elements, apple 100, banana 70 and lime 50. And that's what actually zip function does. It merges two different sequences, in this example lists, into tuples. And it takes those two first elements and creates such a tuple, apple and 100. Then it takes second pair, banana and 70, and creates such tuple, and last tuple is created based on those two elements, lime and 50. That's how zip function works, but you should keep in mind that it returns a zip object, which you could later convert, for example, to a list. And when converting to a list, you'll get list of tuples. But what if you want to create a dictionary based on those two lists? And in that dictionary should be three keys, apple, banana and lime, with corresponding values from the second list. It is possible to do also using zip function, but in this case we convert zip object to a dictionary. Here we do that. And after such conversion, you'll see such dictionary. This dictionary has three different keys, apple, banana and lime, with corresponding values, 100, 70 and 50. And notice that when you convert zip object to dictionary, only two arguments are allowed in the zip function call here. So you could merge only two lists or other sequences together. Because otherwise, there will be more than two elements in each tuple, and in such case, dict function will not be capable of converting zip object to a dictionary. And definitely order of the arguments here in this zip function call does matter. So that's why if you want to take keys for this dictionary from this list, then it should be first here in this function call. And list with values for corresponding keys must be second here in this function call. So that's how you could merge different sequences together using zip function. Now let's explore zip objects on practice, and we will create a zip object from different sequences, then we will convert such zip object to a list, and afterwards we will convert it to dictionary. Let's start by creating a list, and let's call it, for example, products. And this list will contain several strings, for example, phone, then let's say tablet, and here will be one more element, laptop. And also let's create one more list and let's call it quantities. And it will contain several integers. For example, such a number, this number and this number. And here we have three elements, and in this list we also have three elements. Let's now use built-in zip function in order to create a zip object. Let's call this function, and in such way as usually we create instance of specific class.
And here will be first products and the next will be quantities. And let's assign this to the variable, let's call it products quantities, like that. And next let's print to the terminal products quantities, and also let's print type of the products quantities. Let's run the code, and here I see that products quantities is zip object, and here is location of this object in memory in hexadecimal format, and also I see that products quantities is an instance of the built-in zip class. And as you might see here, we basically don't see actual contents of the zip object. And in order to see what zip object contains, we could actually perform iteration over zip object, or we could perform conversion of the zip object to another sequence. And let's convert this zip object to a list. And we could do that very easily. Let's create one more variable, products quantities list. And here we will use built-in list class, and here let's pass products quantities as argument in this function call. And next let's print products quantities list to the terminal, like that. Let's run the code, and here I see a list with 3 elements, and each element is a tuple. And notice that order of those arguments here matters, because depending on the order of those sequences here, we will get a specific order of the elements in each tuple. So now here we get first element from this sequence, and this one is first element in this sequence, and so on. Each tuple contains pairs of elements. But what if here, for instance, we have not a list, but let's say tuple? Let's change it to tuple, and let's run the code again. And we get the same result. This means that for zip, it doesn't matter which type of sequence you use. It works with any sequences. And you could even use strings if you want to do so. Let's remove this empty line here, and let's add one more sequence, and let's say that here will be text. And text will be string with several characters, like that, ASD. And let's add here one more argument, text, and let's run the code again. And now here I see a list, also with 3 elements, but now each tuple has 3 elements. For instance, phone, this integer, and the character A. So, zip function actually performed iteration over elements of this sequence and took out each separate character, A, S, D, and put it into each tuple in resulting zip object. So you could perform iteration over list or tuple or, for example, string, and create corresponding zip object. Also, it's possible to perform iteration over zip object, because it is a sequence of tuples. And let's now quickly perform such an iteration, and for that I'll use for in loop. We will discuss for in loops later in details, but now let's use it in order to perform iteration over zip object. For product, it is the name of the new variable, in products quantities. Here will be colon, and let's here simply print product. Let's run the code, and here in the output I see 3 different tuples. That's the result of the iteration over products quantities zip object. Iteration happened actually 3 times, and on each iteration we got separate tuple. So value of the product variable is different on each iteration, and here are 3 different values. And if you want, you could get any element from the tuple, because tuples are ordered sequences, and you could print, for example, here product square brackets 0. And in such case, you'll get access to such elements in each tuple. Let's run the code now, and here I get corresponding strings like phone, tablet, and laptop. It means that here in this for in loop, you could perform different operations with each tuple, which in this example contains information about specific product. Let's say product title, availability in stock, and specific label. That's how you could work with zip objects, and here we created zip object based on different sequences, and also we converted zip object to a list, and at the end we performed iteration over all elements in the zip sequence. Now let's explore one more thing. And let me remove this iteration and let's get back to print and let's convert products quantities to a list. And if I run the code now, I'll get 3 elements in this list. But now each of those 3 sequences has actually 3 elements. So quantity of the elements in each sequence match. And what if quantity of the elements in one of the sequences, for example, is greater than in other sequences? So now here in this sequence there are 4 elements. Which zip object we will get in such case? Let's see, and same as before, there are just 3 elements in the zip object. It means that zip object is created based on the shortest sequence available. And for example, if in this sequence there are just 2 characters, 2 elements in the string, and if we run the code, we will get just 2 elements in the zip object, first one and second one. But notice that there is no error in such case, and you are allowed to make a zip object based on the sequences which have different quantities of elements. Alright, that's it about zip object, and here we saw that it is possible to use sequences of different types in order to create a zip object. And also we converted zip object to a list, and in such case we get list of tuples. And also we saw how to perform iteration over elements of the zip object, zip sequence basically, using for in loop. Let's delete this part and also let's get back just to 3 elements here in this quantities tuple. Now let's see how we can create a zip object and afterwards convert it to a dictionary. And let's say that in the dictionary we would like to have such key names as phone, tablet and laptop, and corresponding values for those keys will be from this tuple. Let's create first zip object, products, quantities, and here will be creation of the zip object, zip products, comma, quantities. And next let's convert it to a dictionary, products, quantities, dict. And here let's do that using dict function, and here let's pass products quantities as argument. And next let's print products quantities dict to a terminal. Let's run the code, and here we get a dictionary which obviously has 3 key value pairs. Here is key name, here is value for this key. And Python was capable of creation of the dict object because in resulting zip object there are pairs of elements in each tuple. But what if we add here one more sequence? Let's say again add tags. And here will be same as before, several characters in this string. And let's add here tags as well. Let's run the code, and now here I get value error. And we saw similar errors before, and such an error basically tells us that in the sequence, which is zip object, first element has length 3, but 2 is required. Because now in each tuple in the zip object there are 3 elements. For example, in the first tuple there is element phone, this integer, and character A. But Python expects from you exactly 2 elements in order to be able to convert such sequence to a dictionary. That's why in such case you'll definitely get an error. Let's remove tags from here and let's delete tags from here as well. And let's see what we'll get if we add one more element here, let's say 200. Let's run the code, and same as before we get dictionary just with 3 key value pairs. And this 4th element was simply ignored. Similarly, we could make this sequence smaller, run the code, and now we get just 2 keys in the dictionary. And no error. Great. Of course, order of the arguments here matters, and if I make products a second argument here, we will get completely different dictionary. So now keys here are like that, and values are phone and tablet correspondingly. This proves that order of the arguments here matters. Let's get back to such an order in this creation of the zip object. And that's how you could convert zip object to the dictionary. But please keep in mind that in such case, zip object must have exactly 2 elements in each tuple. In other words, just 2 arguments in this function call.
Before we covered with you most commonly utilized data structures and built-in classes in Python, and now let's summarize what we discussed so far. And now I would like to talk about sequences, such as lists, dictionaries, sets, tuples, and compare those built-in Python types. Because some of them are mutable, some immutable, some are ordered, some unordered, so let's summarize this information in this lecture. So, I prepared such table with 3 columns: mutable, ordered, and identical elements. Mutable answers the question whether a specific object is mutable or not. Ordered answers the question whether object is ordered or not. If object is ordered, it means that each element has its index, and indexes start at 0. And identical elements answers the question whether specific object can have identical elements inside of it or not. So let's start with list. Lists are mutable, ordered, and in the list you could have identical elements. And it means that you could mutate any list, you could add new elements to the list, you could remove elements, you could modify elements, and so on. Each element has unique index, and indexes start at 0. And of course, you could add same elements to the list. And you could mix different types of values in the list. And you could even create a list of dictionaries or list of lists. Next is tuple. Tuples are very similar to lists, but tuples are immutable. You are not allowed to mutate tuple. Tuple is ordered, and the tuple allows you to have identical elements in it. But as soon as you create a tuple, you are not allowed to modify it. You cannot add new elements, you cannot remove elements, you cannot change elements. Tuples are immutable. But you are always allowed to create, for example, a list from the tuple, then modify list, and then create tuple again, if you need to do so. But usually tuples are created in those cases where there is no need to modify actual tuple. So it is like fixed data set with fixed elements. Next data structure is set, and sets in Python are very powerful, and you could perform different operations with sets like union, intersection, difference, symmetric difference, and so on. Sets in Python are mutable. You could add new elements to the set, or you could remove elements from the set. But sets are unordered. There are no indexes of elements in the set. And also, set contains only unique elements. And that is a power of sets. When you need to ensure that a specific data structure contains only unique elements, for example, product IDs or user IDs, you should definitely go ahead with set. Next data structure is range, and ranges are immutable. You are not allowed to add new elements to the range or remove elements, so ranges are immutable. But ranges are ordered. Each element in the range has its unique index, and indexes start with 0. And also, in the ranges, each next element is greater than previous. It means that ranges contain only integer numbers. And therefore, there are no duplicates in ranges. There are no same elements. One more data structure is dict, and dictionaries are actually sets of key-value pairs. And dictionaries are mutable. You could add new key-value pair or remove existing key-value pair using del statement, or you could modify value of specific key. And dictionaries are unordered. It means that order of the key-value pairs doesn't matter in dictionaries. And also, dictionaries don't allow you to store identical elements. It means that one key with one name could appear in the dictionary only once. And if you want, for example, to create new key in the dictionary, and such key is already present, what you will do, you will simply reassign value to existing key. Because keys are unique in dictionary. And one more data structure, which is actually also sequence, is string. And the strings are immutable in Python, but strings are ordered. And each character in the string has unique index, and indexes start with 0. And therefore, you could very easily convert string, for example, to list or to tuple, because string is also sequence of elements. Sequence of chars, basically. And of course, inside of the same string, you could have identical elements, identical letters. This is a summary about all sequences in Python, and you should choose a specific data set depending on your needs. If you simply want to store elements of different types, you should go ahead with list. Lists are mutable, and each element has unique index, and you could basically store any values inside of the list. You should choose tuple when you are not planning, even occasionally, to modify data structure after its creation. Sets are very useful when you want to work with unique elements. But keep in mind that you are not allowed to store mutable objects in sets, like dictionaries, lists, or other sets. Ranges are typically utilized in for-in loops, when you have to perform specific action n times, 1000 times, 100 times, doesn't matter. And you could create range directly in the for-in loop. There is no need for separate variable. Dictionary is a very commonly utilized data structure in Python because it allows to store key-value pairs. And you could always find specific value by key name. This is very easy. There is no need to use indexes, like in lists or tuples. And strings are, of course, utilized almost in all Python programs. It is a very common data structure in Python. That's all about sequence types in Python. And please keep in mind all characteristics of all data structures. And you could always get back to this table in order to refresh your knowledge if you want to find suitable data structure for a specific task. In this section, we will dive a bit deeper into modifications of the objects in memory of the computer where you run Python program. And you already know that you could very easily create a copy of the object by reference, and that means that few variables could point to the same object in memory. So let's discuss this process a bit more in details. So modification of the objects in Python. Variable in Python always contains only a reference to a specific object, no matter which type this object has. String, integer, doesn't matter. And certainly variables could refer to the same object in memory. In such case, different variables simply hold pointers to the same location in memory. but object itself is just 1. Let's now talk about IDs of immutable objects. You know that there are immutable objects and mutable objects. And such objects as strings, integers, floats, none, and tuples are immutable objects in Python. And let's examine what happens when you utilize specific value of immutable type. And here you see that we create the integer, it is 10, and assign it to the variable myNumber. And here I print ID of the myNumber. Then I create same value 10 and assign it to another variable, other number. And in this case, as you might notice, ID of other number is the same as ID of myNumber. And if I simply print ID of number 10 like this, of object 10, I get the same result. This means that when you use immutable objects in Python, Python creates such an object only once in memory. So here on this line we created object which holds integer 10, and Python allocated memory for this object. And here is ID of this object. And when you try to create again same object, Python checks whether such object is present in memory or not. Here Python has found such object as integer 10 and simply reused this object. And other number simply holds pointer to the same object in memory, same as myNumber. That's how Python behaves when you work with immutable objects. Similarly, here you get simply ID of a specific object which is already present in memory. So there is no need to create separate objects if there is already one immutable object in memory. That's our IDs of immutable objects. And let's now have a look at this example. In this example, we again create integer 10 and assign it to the variable firstNum. And afterwards we copy firstNum to secondNum. And in this case, IDs of those two variables will be, of course, the same. Because here we copy simply reference to specific object in memory. And now, let's suppose that afterwards you want to increase value of the secondNum. And we do that using plus equal operator. Add 5 and assign new value to secondNum variable. What happens in this case? We get value 15. And in this case, Python creates a brand new object in memory and assigns a reference to this new object in memory to secondNum variable. And after that, secondNum and firstNum will hold different pointers to different locations in memory. And notice that the value of the firstNum variable was not modified. So value of the firstNum was not changed. It still points to the previous object 10 in memory. So when you perform specific operations with immutable objects, Python does not mutate existing objects. It creates brand new objects. And that's what we prove here. In this example, finally we get two different objects, integer 10 and integer 15, and they are located in different places in memory. IDs of those two variables are different. Let's now examine same process using diagrams. So initially we create integer 10 and assign it to variable firstNum, and afterwards copy firstNum to secondNum. And after such two assignments, we have only one object in memory. This object has integer type, and two different variables point to the same location in memory. Afterwards, when we perform such operation, secondNum plus equal 5, brand new object is created, and now there are two different objects in memory. Object which holds integer 10 and object which holds integer 15. And now two variables first num and second num point to different objects in memory. And again, this happens because integers are immutable in Python. We cannot mutate existing object. And that's why after such operation, first num and second num will hold different numbers, will point to different integer objects.
Hey guys, this course is part of the big Python course, which is more than 50 hours long. Link to the complete course you'll find in the description under this video.
Let's have a look at another example. And in this example, we have mutable object. It's a list. Here we create a list which has 3 elements and assign such list to variable myList. And then we print to the terminal ID of myList object. That's its location in memory. Afterwards, we create new list, and it is the same as this list. It has same length and same elements, but it is a brand new object. And here, if you print ID of other list to the terminal, you'll see that ID here is different from this ID. So two different objects were created. And if you simply print ID of such list 1, 2, 3 without creation of the variable, you'll get another ID. So each time when you create a list, Python doesn't check whether there are other lists in memory or not, because lists are mutable in Python, and it is possible to mutate each of those lists independently from others. That's why addresses in the memory for different lists are different. But if you compare such lists using, for example, comparison operator, you'll get true, because lists have the same length and have same elements with the same order. But objects in memory are different. And that's what Python does for all mutable objects. It does not reuse existing objects. It creates brand new objects. In case you create, for example, lists like that, we don't copy my list to other list. We create new list here. So 3 different lists are created here in this example. Let's have a look at one more example. In this example, we create 2 different lists, 2 different objects, and assign them to different variables, my list and other list. And afterwards, we use append method for second list, other list, and append new element to this list. And in this case, previous list, my list, was not changed. But other list was changed. And that proves that here we work with 2 different objects, 2 different lists in memory. And changes, mutations of one list doesn't affect another list. So this is very important. We don't mutate other lists when we change only one of the objects in memory, one of the mutable objects in memory. Let's have a look at one more example, and in this example there is a dictionary, and this dictionary has 2 keys, name and isinstructor. And we assign such dictionary to variable info. So here we have dictionary. And in this example, variable info will hold pointer to location of this object in memory. And next, let's assume we copy info to info copy variable. We don't create new dictionary. We copy info to info copy. And in this case, info and info copy will point to the same object in memory. And this object holds a dictionary. Afterwards, if we perform any actions either with info variable or info copy variable, for instance, add new key to the dictionary, like this, using square brackets, then reduce quantity and assign value to this key, you'll see that actually we mutate only single object in memory, this one. And two different variables still point to the same location in memory. And after such operation, certainly, you will be able to access key named reduced quantity via either info variable or info copy variable. So you can go to this object in memory either from this variable or from this variable, like this. And that's why here we get 5 for both cases when we access value of the reduced quantity key. And this again happens because we copied variable. And you could perform such action, assignment of one variable to another, with any variable in Python. But here we use dictionary, and dictionaries are mutable in Python. That's why using any of those variables, we can mutate such dictionary in memory. And that's what we did here. We didn't create new dictionary. We modified existing dictionary. We added new key value paired to that dictionary. And if you, for example, after such operation perform assignment of the new value to the same key reduced quantity using, for example, info copy variable, you'll see that again we mutate the same object in memory. And info reduced quantity and info copy reduced quantity will produce 100. This proves that we could mutate this dictionary via any of the variables, either info copy or info. And this changes only single object in memory. Let's have a look at other example, example number 3. In this example, we create two different dictionaries. And they are different because dictionaries are mutable in Python. And in such case, same as for lists, Python creates different objects, even though they have same keys, like name, isinstructor, and same corresponding values. But here, two different objects will be created in memory, and now my info and other info will point to different objects in memory. So IDs of those two variables, my info and other info, are different now. And here we see two different objects. And if we perform, for example, such operation, we create a new key named rating and assign float value to it, for example, 5.0, we mutate only this object, because other info points to this object. And this object is not affected. So here are two different objects in memory. Only other info object was modified in this case. And the rule is following. After copying the mutable object, changes will be reflected on all copies. And you are able to modify such an object via any of the variables which point to that object. And mutable objects in Python are lists, dictionaries, sets, and custom objects, which you create based on your user-defined classes. Those objects in Python are mutable, and that's how Python behaves relative to mutable objects. So changes are reflected on all copies, if multiple variables point to the same object in memory. And in some cases, such behavior is not desirable, and you should create copies of the mutable objects. It means you should create brand new objects from existing objects. And next, let's discuss how you could create copies of the objects. We just discussed with you few examples related to mutations of the mutable objects in Python. And when you copy one variable to another, you technically copy only reference to specific object in memory. And if that object is mutable, for example, list or dictionary, or object created based on your user-defined class, you will be able to modify that single object via any of the variables. And this change will be reflected on all variables which point to the same object in memory. And now let's discuss few approaches which allow you to create brand new copy of specific mutable object. In this example, there is a dictionary with same keys as before, name and isinstructor, and let's assume that we want to create brand new copy of this object. And for this purpose, you could use copy method, which is method of each dictionary, because such method is inherited by each instance of the dictionary. It is located in the dict built-in class in Python. And therefore, you could call such method for any dictionary object. In this example, info. And in such case, brand new object will be created, and info copy variable will hold pointer to brand new object. And now, if you want to create new key in that new object, you could do that using square brackets notation. And here we create a key named reviews quantity and assign value 5 to it. And after that, info copy dictionary will have 3 keys, including reviews quantity key, but info dictionary will still have only 2 keys, name and isinstructor, because info copy and copy point to different objects in memory. Let's now continue with this example, but now in the info dictionary there will be key called reviews, and value of this key is empty list. Recap that lists are also mutable objects in Python. And let's assume that we again call copy method and create brand new object, and the info copy will point to that brand new object. And let's assume that now we want to append to reviews list new element. And for that we could use append method, which is available for any list. And we perform such operation for info copy variable. And after such operation, both info and info copy dictionaries will have great course element in the reviews list here. And this happens because lists are mutable objects in Python, and the reviews key only points to specific location in memory where this list is located. And when you perform such copy operation, copy one dictionary to another new object, such reference here is not changed. So, reviews key in both dictionaries, here and here, points to the same location in memory, where we store this list. And that's why we are still able to mutate just one list using 2 different variables, info and info copy. This means that copy method creates so-called shallow copy. It is a copy on the first level. But if there are nested mutable objects, like in this example, references to those nested objects are copied to another object. So please keep that in mind. If you don't have nested mutable objects, like in this example, you could of course safely utilize copy method, and you will be sure that 2 different objects will be fully independent. But not in such case. Let's have a look how we could actually fix this issue. If you want to create a deep copy, including new links to nested mutable objects, you have to utilize, for example, deep copy function. And this deep copy function is available in the built-in Python module, which is called copy. And using such syntax, you could import deep copy function from the built-in copy module. We will discuss module a bit later in this course, but that's how you could perform import from other module. And here, when we call deep copy function and pass to it existing variable, for example info, full deep copy will be created, including nested references to mutable objects. And after such deep copy operation, if we perform same action as before, for example add element to the reviews list, and we do that for info deep copy object, you'll see that info dictionary was not modified. Here this list still contains 0 elements, but here there is 1 element. Great course. And I suggest to you to use deep copy function when you want to create full deep copy of specific object, in case source object is like this. It has nested references to mutable objects. That's the option which allows you to avoid mutation of any of the objects after copy operation. And you could use deep copy for other value types in Python as well, for example for lists, because you might have list of dictionaries or list of lists or list of sets. You could have other mutable objects as elements of another mutable object. So please keep that in mind. When you simply call a copy method, which is available for lists, sets, or dictionaries, as we saw in those examples, you create only shallow copy, or so-called first-level copy. All nested references are not modified during such copy operation. So please keep that in mind. Now let's discuss how to create a deep copy of specific object in Python on practice. And in order to save some time, I'll paste what we discussed on the slides, and you please type that manually. And here is actually a dictionary which is called info, and such a dictionary has 3 key value pairs. Key names are name, isinstructor, and reviews. And value of the reviews key is a list. And this list initially is empty. And here we import from the built-in copy module a function which is called deep copy. And we will discuss built-in and external modules later in this course, but for now I tell you that using such line of code we are able to import a specific variable from the built-in module, and the variable which we import has a name deep copy. And using such function we are able to create deep copy of specific object in Python. And again here we have dictionary. And in order to create a deep copy, we simply call deep copy function, and if you hover mouse over deep copy variable, you could see what it does. It creates a deep copy, and such operation is performed on arbitrary Python objects. It means that such a function works with different objects in Python, like dictionaries, lists, and so on. And after this operation, let's try to print to the terminal info deep copy, like that, and let me temporarily comment out those lines. Let's run the code, and here we see such dictionary, and it is already a copy of this object info. We could ensure that those objects are different by comparing their IDs. Let's print ID of the info deep copy, and let's also print ID of the info. Let's run the code, and here I see 2 different numbers, which proves that those objects, info deep copy and info, are different. And what we do next, we actually try to add to the list, this one, specific value. And we perform such operation using info deep copy dictionary. And we access specific key of the dictionary using square brackets notation. And here we put reviews, which is name of this key. And afterwards, for this list, we call append method. And recap that such method as append and many others are inherited from the built-in class which is called list.
And using append, we could add new element to existing list, and such element is added at the end of the list. Therefore, after such operation in this list, but in the info deep copy dictionary, there should be single element great course. And here we print info and info deep copy, and let me comment out those two lines and run the code. And now here I see info dictionary, and the reviews key still has empty list as a value, and here I see new dictionary, which is info deep copy. And now here in this list we see single element great course. Let's now try to append specific element to another list in info dictionary, and for that in the info dictionary we will access reviews key, and let's call append method and let's append string thanks, like this. And let's run the code again. And here I see two completely different lists. Reviews in info and reviews in info deep copy are different. Also, we could compare IDs of such two lists in different dictionaries. How we could do that? Very easy. Let's print ID of the info square brackets reviews, like that, and let's print ID of the info deep copy square brackets reviews. Let's run the code, and here I see two different IDs. And those IDs represent those two lists in the memory of the computer. Lists recap are mutable in Python, and here we ensure that such two lists have different locations in memory. That's how info deep copy works. It creates not just first level copy, let's say, but it also copies all inner mutable objects, like list in this example. But what if instead of deep copy, we will use regular copy operation? Let me comment out this line and let's do copy here. I'll still keep info deep copy variable in order not to replace other occurrences of the info deep copy here. And let's simply call copy method, which is available for any dictionary. And if I run the code right now, I'll see here exactly two same numbers. It means that now reviews key points to the same location in memory in both variables, in this one and in this one. And therefore, those lists here and here are exactly the same. They have two elements. And it doesn't matter how we actually add elements to those lists, either via this variable or via this variable. Such a copy is called shallow copy. And let's basically replace deep copy with shallow copy in order to make you 100% sure that we are working with shallow copy. If you want to rename variable everywhere, you could select it, click right button of the mouse, select refactor and then select rename, or hit this key combination. Let's rename, and I'll rename info deep copy to info shallow copy. Like that. Press enter and the variable was renamed everywhere. And if I run the code again, I'll get the same results, same as before. Same IDs, same location of the object in memory, and same list here and here. Alright, that's the difference between shallow copy and deep copy. And let's get back to deep copy operation, and I remove this line and I'll keep this line. And to summarize, each time when you want to create a deep copy and in case specific dictionary, for example, or list has nested mutable objects, for example, list of lists or list of dictionaries, or dictionary which has lists or, let's say, sets as values of some keys, I highly recommend to you to use deep copy. And deep copy function is available in the built-in copy module. And in such case, you will avoid occasional modification of other variables when you modify for example, copies of such variables. And together with you, we ensure that in this example, we create complete deep copy. And links to such lists are different in different dictionaries. That's all about deep copies and shallow copies in Python.
Before in this course we utilized different built-in functions and also we used different methods of the classes, such as copy, append and so on. And now let's talk about functions in Python in greater details. And function in general is a block of code which could be executed multiple times. And more than that, you could also supply parameters for specific block of code. And this will lead that each time when you call a function, it might be executed differently. So each call is different from other calls. And let's have a look at such code. And in this example, you see that there are several variables like a, b, c, and some blocks of code here are exactly the same. As you might notice, we assign a plus b to the same variable c and afterwards print c. So here are two exactly the same code blocks. Even though on those two lines values of a and b are different, and of course result is different. Here we get 8 as a value of the variable c and here we get 20. But lines of code are exactly the same. And of course, in such case, it does make sense to create a separate function which will perform such operations inside of it. So sum a and b and assign result to the variable c, and afterwards print c to the terminal. And in this case, this function has a name. Also, we use reserved keyword def, which is an indicator for Python that you create a function. Then here in braces there are two parameters, and using different function calls you could assign different values to those parameters. And afterwards inside of this function we perform some operations. And notice indentation here, it is mandatory in Python. So here we create two variables a and b and assign such values to them and afterwards call a function. And here in this function call, a and b are arguments. We supply values to those parameters in some function. And afterwards in the terminal you'll see 8 as a result of this function operation, because inside of it we print to the terminal value of the variable c. Then we could modify values of variables a and b. It is possible in Python because Python is dynamically typed language and you could assign any new value to any existing variable. And afterwards we call some function again, and here we specify same variable names as in this call, a and b, but now values of those two variables are different from the values in the first call, and therefore in the terminal you'll see 20. That's again the result of this print function call. That's how we refactored left block of code to the block of code where we use function. And afterwards you could call function as many times as you want. So we moved repetitive blocks of code to the function body. And if you want, you could even move function to separate module in your Python application in order to make it available to other modules and in order to make it separate from other blocks of code. So, next, function of course is an object in Python, because every entity in Python is an object. That's why when you, for example, create a function called sum, so same function as before, and print type of the sum in the terminal, you'll see class function. Because each function in Python is an instance of the built-in function class. And this is just syntax that allows you to create new instance of the function in Python. So let's have a look again at the structure of each function. Def keyword, then function name, myFn in this example, then parameters. Of course, function might not have any parameters, and in such case you simply add here braces. But you must add them. Then comes colon, and on the next line after indentation, there is a function body. And in the function body, of course, you could access values of the parameters a and b. Think about those parameters as variables which are available only inside of the function. And values for those variables are set when we call a function. And in each function call, values for parameters might be, of course, different. And also it is possible inside of the function to create new variables, like we do here. We create new variable c and assign to it result of the a plus b. And such variable c will be available only inside of the myFn function. It will not be available outside. And for each myFn function call, we will create brand new variable c. And optionally in function you could return result. In this example we return c. This means that this function returns value of the variable c as a result of the function operation. And when you call any function, and function returns, for example, such result, you could reuse such result, for example, in another function call, or assign it to the variable. Do whatever you want. But if you don't explicitly return result of the function call, like we do here, function will return none, because each function must return something. And by default, function returns none. And please keep that in mind. If there is no return statement, function returns none, which is an instance of the built-in none-type class. And in such class, there is only single possible value. It is none. Also, it's obvious that a function must be called in order to execute code inside of that function. If you don't call a function, no code inside of the function is executed. So when you define a function, it is not executed. You must call a function. So therefore, back to our example, if there is a function declaration, where we create a function and assign it to the variable myFn, you can call a function later, like here. We call myFn function and here we supply two different arguments. So in function declaration, there are parameters, or variables which are available only inside of the function. And when you call a function, you supply arguments. In this example, there are two parameters in the function declaration, and therefore you have to pass two different arguments in the function call. And this function returns a result. Here it is. And therefore we could use result which is returned by the function in order to perform other operations. And here we call another function. It is a built-in print function. And you'll get 14 in this example in the terminal. That's the difference between parameters and arguments in the function. So parameters are located in the function declaration. Those are variables available in the function. Arguments could be different in each function call. And you could call the same function as many times as you want, using different arguments, and perform some actions with function result, if you need to use a result of the function. Let's have a look at the process of creation of the variables, assignment of the values to the variables when we call a function. So, when we call a function here, we supply two arguments, 10 and 3. And it means that in this function call, parameters a and b, in this function are assigned values 10 and 3 correspondingly. Next step. Value of the a inside of the function is increased by 1. So here is this line of code. Next operation, sum of a and b is assigned to the variable c, and this variable is defined inside of the function, and it is available only inside of the function. Next step, value of c is returned from the function, and function ends its operation. And please notice that as soon as function returns result, it does not continue to next lines. For example, if there would be some other lines here under return, they will not be executed after return. So return stops execution of the function, no matter what comes after return inside of the function body. And finally, we assign result of the function call to the variable res. So function returned result here, and we could use this result. And afterwards print result to the terminal. And on the last step, we print value of the res variable to the terminal. And that completes this code. So first we declare a function using def keyword, and afterwards we call this function. And this describes step by step what happens when you call a function in Python. And also notice that parameters in the function declaration are optional. Here there are 2 parameters, but function could have 0 parameters. Next, return statement is also optional. If you don't add return statement in the function body, then function will by default return none. Next, assignment of the function call to the variable is also optional. You could perform some operations inside of the function and that's it. And don't return anything from the function and don't use result of the function call. And also, arguments in the function call are also optional. If there are no parameters in the function, therefore there is no need to supply arguments. Moreover, if there are no parameters in function declaration and you supply arguments in the function call, Python will produce an error. It will tell you that function does not expect any arguments from you. Therefore, you could create the shortest function in Python, which will consist only of function name and function body, which has pass statement. And in this case, in this function declaration, there are no code lines, and if function body is actually empty, you have to add pass statement. And Python interpreter simply ignores such a statement. But because function must have a body with at least one statement, you could use pass statement for that. And it's useful when you create a mock of your application and when you create functions in different modules, when you name functions, but you have not yet added any function bodies. You could simply add pass statement into each function body in order to make such code valid code in terms of Python. And in this example, there is no return statement, and this means that such function myFn returns none. This is default value, which is returned by any function if there is no return statement. Also, it's possible to write function just in one line. If there is one line in the function body, you could write like that. So after colon on the next line after indentation comes, for example, return a plus b, or any other expression or statement. And if there is just single line in the function body, you could shorten such function to just one line of code and write return a plus b directly after colon on the same line where you declare a function. But please notice that such syntax is allowed only when there is one line in the function body. If there are 2 or more lines, you are not allowed to put them on one line of code. In such case, you have to use function body like you see here. Now let's discuss what happens when you call a function and pass to this function immutable or mutable objects. You know that, for example, integer is immutable object in Python. And here we do following. We still work with the same example, so here is myFn function with two parameters. And here we call myFn function, and in the function call we pass names of two variables, num1 and num2. And what happens after this call is following. Python creates new references a and b to those objects, 10 and 5. Because technically, when you call a function, a will become a copy of num1, and b will become a copy of num2. And after this call, after this line, so here, before function body, a and num1 will refer to the same object in memory, object which holds this integer. b and num2 will refer to another object, which holds this integer value. And afterwards we start function body. And here is first line. We increment value of parameter a by 1. And we discussed with you before that in such case Python creates brand new object. It is integer object and it holds a value 11. And after such operation, this variable a, this parameter a, will point now to another object in memory. Not the same object as points this num1 variable. So, here on this line, brand new object is created. And a will refer this newly created object. And this means that num1 still points to this object in memory. Afterwards, we print result of the function call to the terminal and we get 16. And if we check value of the num1 variable, it is variable outside of the myFn function, it still has value 10. It means that in this example, we did not modify values of external variables inside of the function, because we performed operations with immutable objects. So value of external variable was not changed. Now let's have a look at the example where we pass mutable object to the function. So here is a function which is called increase person age, and there is just a single parameter in this function, this person. And inside of the function we perform such operation. We take value of the age key in the dictionary person, because we expect a dictionary, and increase its value by 1. And return person. And here is the person1 dictionary. It is located outside of the function, and here in the function call, we specify only name of the variable. It is person1 variable. You know that dictionaries are mutable in Python. And in this case, we pass person1 in the function call by reference. And after function call, person1 and person will refer to the same variable. And inside of the function, we will mutate external variable. Because, again, person and person1 point to the same object in memory, and this object holds this dictionary. And now inside of the function, we mutate external variable. And when after function call, you access value of the person1 age key, you'll get 22. And here it was 21. And this picture differs from the previous example in the way that inside of the function we are capable of mutation or change of external variable, of external object, because we pass specific variable by reference. And you have to be very careful with that. And in general, it is not recommended to change any external objects inside of the function. function should work only with parameters of the function and with own variables, which are created inside of the function. Please don't change any external objects. And you might notice that in the previous example it was not obvious that we actually mutate external object. And you have to know behavior of the objects in Python, and you have to know that dictionaries, lists or sets are mutable in Python. And therefore Python acts in such way when you change specific object, for example, inside of the function. Therefore, it might be better to create a copy of the object inside of the function. So here we still work with the same example. Person1 is a dictionary and it is located outside of the function, and we here specify this variable name in the function call. But on the first line in the function body, we create a copy of the object by calling copy method of the dictionary. And after that operation, we work only with copy here inside of the function. We don't work with person object, which still points to the same object as person1. And here we increase age by 1 and return person copy. So we return new object. We return actually reference to the newly created object. And after that, if we assign result of the function call to new person variable, it will hold pointer to another created object, which we created here on this line. And in this object, value of the age key will be 22, because we increased it here. But person1 age will still be 21. So external object person1 was not modified. That's how you should approach modifications of the objects inside of the function. If you work with mutable objects in function, start with creation of the copies of all mutable objects in order to avoid mutation of external objects. However, in some cases you might want to modify external variable on purpose, and you want to do that inside of the function. And if you know what you are doing, of course, you could do that. But in general, you should not mutate external variables inside of the function. And in this example, because we call copy method of the dictionary, we create new object inside of the function. And therefore, after function call, person1 still points to the previous object in memory, and we don't modify that object inside of the function. That's all about the function syntax and about behavior of the functions when you pass mutable or immutable objects to the function in the function call. Now let's have a look on practice on behavior of the mutable and immutable objects when you call specific function. And let's here create a function using def keyword, and the function will perform printing of information of the fruits which specific person likes to eat. So therefore let's call it print fruits info. And let's say that this function will have two parameters, person name, and the second parameter will be called simply fruits. And we expect actually a string as a value for this parameter and list as a value for second parameter, fruits. And here inside of this function, let's simply print person name and comma fruits, like that. And that's it. Function will return nothing, it means by default it will return a none, so we don't use any return statement here. And next, after function declaration, let's create two variables and let's call them, for example, my name, and here will be my name, and also let's create here one more variable, favorite fruits, like that. It will have a list as a value, and here will be several variables, oranges, apples,
and bananas. Like that. And now let's call this function print fruits info and pass to it two variable names, my name and favorite fruits. Let's do that. Print fruits info, and here will be my name, comma, and favorite fruits. Let's run this code, and here in the output I see such a line. Here is value of the person name parameter inside of the function, and here is value of the second parameter in the function, which is fruits. And in order to make this output more readable, we could, for example, perform iteration over this list, which is fruits, and print each value together with person name to the terminal. And we could do that using for in loop for fruit in fruits, colon, and here let's print to the terminal Bogdan likes oranges, Bogdan likes apples, and so on. And for that we could use f strings, f, single quotes or double quotes, then will be first expression, person name, likes, then again pair of curly braces, and here will be fruit, not fruits. Here should be fruit, because here in the for in loop we will have access to specific element from the list, oranges, apples, and bananas. And we again will discuss for in loop in greater details later in the course, but in general for in loop allows us to perform iteration over any sequence. And on each iteration, value of this variable, and this name could be any, will hold the element of the sequence. And in this example, we will perform iteration 3 times. Let's run this code and see what we get, and I see such 3 sentences. And it means that for in loop was executed 3 times. Alright, that's what we get now in the function. And let's suppose that inside of the function we want to modify fruits list. And let's assume that we want to remove one of the elements in this list. And we could do that using, for example, pop function. Let's write fruits.pop, and let's simply call this method. Let's run the code, and now I see only 2 strings in the output. It means that after such line of code, fruits list contains only 2 elements, oranges and apples. And this element was removed. Now, let's after this function call here, let's print value of the favorite fruits variable. Let's print favorite fruits. Let's execute code now, and I see such a value of the favorite fruits list. It also contains only 2 elements. But we never modified favorite fruits variable here in this code. Look, we simply assigned list to this variable, then called the function, passed name of this variable in the function call, and that's it. And after such function call, value of this list is different from this value. But if I comment out this line of code and run the code again, I'll get such a list, which shows us that without function call, this list is not modified. And this happens because in this case, when we call a function like that, we pass this variable by reference. And inside of the function, fruits will point to the same list as favorite fruits, because lists are mutable in Python. And when we modify list, which is fruits, inside of the function, we modify the same list where this favorite fruits variable points to. And we could prove that by printing IDs of 2 different objects, fruits and favorite fruits. Let's print ID of the fruits inside of the function, and let's print ID of the favorite fruits outside of the function. Let's run the code, and IDs are exactly the same. This one and this one. And that works basically with any mutable objects. if you pass any mutable object to the function, any function, and modify that object inside of the function, then object outside of the function, which is in our example favorite fruits, will be modified as well. And you could do that even occasionally without knowing that. But I discussed this topic together with you in details in order to make you fully understand what happens when you pass specific mutable object in the function call. But what about second parameter, which is person name? In this example, it holds a string. And let's say that we want to modify value of the person name here inside of the function. Let me remove this line and let me remove this line. And let's say that inside of the function we want to change value of the person name, and let's say that it will become Alice. Let's run the code now, and here now I see that Alice likes oranges and Alice likes apples. And if I print value of the my name variable outside of the function after function call here, let's print my name, run the code, I'll see that value of the my name object is still Bogdan. This means that when you pass specific immutable object in the function call, and you know that strings are immutable, and modify value of such variable inside of the function, then here on this line you create another object, and now person name will point to that another object. So after such operation, pointers of person name and my name outside of the function will be different. And let's verify that by printing ID of the person name inside of the function, and let's also print ID of the my name outside of the function, let's say after function call. Run the code, and here I see two completely different IDs. So, when you pass immutable object like string or let's say tuple or integer in the function call, you could be sure that even if you modify value of the parameter inside of the function, then corresponding variables outside of the function which you passed in the function call will not be modified. This applies in this example only to my name variable. But we discussed with you what happens in case you pass in the function call specific variable which points to the mutable object, like list or set or, for instance, dictionary. And in order to avoid such behavior, when inside of the function you basically modify external variable, you could create a copy of specific mutable object, in this example list. Let's remove this line, and let's also remove this print line, and let's inside of the function create copy of the fruits. And for that we could use copy method of the list. Let's create new variable and let's call it fruits copy, and its value will be result of the copy operation of the fruits list. And we could do that using following syntax, or if you want you could use list class and make new list like that. Or if you want, you could use list slicing. Fruits, square brackets, colon. I prefer to use copy because in such a way we explicitly show that we create a copy of specific object. In this example, copy of the list. And now further in this function we should work with this variable. And we should call pop for this variable, not fruits. Like this. And we have to iterate over fruits copy instead of fruits. And in such way we will not modify this list, because here in the function we modify copy of the list. And that is new different object. Let's replace print my name with print favorite fruits outside of the function, like that, and let's run the code. And here inside of the function we see two outputs to the terminal, which proves that fruits copy list has only two elements, oranges and apples, but outside of the function favorite fruits list still has three elements, oranges, apples, and bananas. So in such a way, we didn't modify external variable inside of the function. And one of the signs of the good code is that when you inside of the functions, never modify any external variables. So if you are planning to modify values of some parameters, like in this example, we modify fruits list, you should create a copy. If you don't plan to modify mutable objects inside of the function, then there is no need to create a copy. Simply work with specific parameter of the function. So if you don't modify list here, let's remove this line, then there is no need for this line. And here you could work with fruits parameter like that. Because here we don't modify fruits, and therefore don't modify favorite fruits. And also please notice that names of those two variables, fruits here and favorite fruits here, could be different. And they are different in this example. Because this is parameter name and this is name of the variable. And of course, in each function call, you could pass different variable names. In this function call, it could be favorite fruits. In other function call, it could be my fruits, and so on and so forth. It doesn't matter. What does matter is that when you call a function, you pass objects by reference. It means that my name and person name will point to the same object in memory. Favorite fruits and fruits will point also to the same object in memory. So please always keep that in mind. It is very, very important. Before in this course, in the most function calls, we used actually positional arguments. And even if we call, for example, print function and pass to it two different arguments, like this, and run the code, we will see in the output same order of the arguments here. If I add one more argument like that, run the code, I'll see that true appears after ABC. And such arguments in this function call are called positional arguments, because order of those arguments here does matter. And if I move 10 to second place like that and run the code, I'll see that order of the elements in the output was also changed. These are positional arguments, and order of each argument matters. And we could create our own function, and let's name it myFn, and it will have two parameters, first and second. And let's simply print first and let's print second. And let's call this function here below myFn, and here let's pass two arguments in the function call. Let's say number 100 and none, like that. Let's run the code, and here in the output I see corresponding values of two parameters. First got value 100 and second got value none. And that's the order of those values here in the output. So here we also used positional arguments in the function call. If you change the order of those arguments here, you'll get different values from those two parameters. Order was swapped. And you already know that in this example, if you try to call this function just with one argument like that, you will get an error, type error specifically, missing one required positional argument. And opposite is also true if you try to call this function with three arguments, let's say, like that. You'll also get type error. myFn takes two positional arguments, but three were given. And general rule is following: if a specific function has only several parameters, like in this example, and you call this function, you have to pass exactly the same quantity of arguments as there are parameters in the function. So two parameters and therefore two arguments, not 3, not 0, not 1. But also it's possible to add default values two parameters, and here we could do that using equal sign, and let's say that here we could add default value as true for this second parameter. And in such case, second parameter becomes actually optional. And we could, for example, call function with two arguments none and, let's say, false, run the code, no error. Or we could omit second argument, let's remove it from here, run the code, and there is no error, and now I see that the value of the second parameter is true because of this default value. So default values make certain parameters optional. That's all about positional arguments, and that's behavior of the functions when you use such parameters as we used in this example.
Now it's time for the task related to functions for you guys. And the task is following. Please create a function which is called merge list to dict. And the function must have two parameters. The function should combine two lists using the built-in zip function. So, function expects from the user two different lists, and the function should combine them using built-in zip function. Next, convert a zip object to the dictionary and return it from the function. Call a function by passing to it two lists as arguments. And finally, output result of the function call to the terminal. So, function expects two lists. In the function, we combine two lists using built-in zip function, and afterwards convert zip object to a dictionary and return such a dictionary from the function. I wish you good luck. You already know basic syntax of the functions in Python. And you know that each function has a name, optional parameters, function body, and optional return statement. And you know the difference between parameters and arguments. Parameters are located in the function definition, and arguments you supply in each function call. And now let's talk a bit deeper about function arguments. Because in Python there are different types of arguments which you could utilize in the function calls. So, again, in this example, a and b in the function declaration are parameters. So this function has two parameters. And in the function call there are two arguments. And Python is very strict in terms of verification of the arguments which are passed to the function. And in this example, there are exactly two parameters, and therefore Python expects from you exactly two arguments. If you call a function and supply two arguments, like here, you will not get any error from Python. Because there are two parameters and you supply two arguments, and you'll get a result, which is 7 in this example. But if you call the same function and supply only one argument, you'll get type error, some nums missing one required positional argument. It means that you must supply a value for another parameter, this one. So this function has two parameters, and it is necessary to pass two arguments in the function call. Same error you'll get if you attempt to call this function without any arguments. In this case, you'll get another error, type error missing two required positional arguments, a and b. So, if you define a function in such way and specify two different parameters in the function, you must call a function with two arguments. And of course, any IntelliSense in Visual Studio Code or in other editor will actually tell you which arguments function expects from you when you add function call brackets. But you have to keep in mind that if you don't supply necessary amount of arguments, you'll get type error, missing one or two or whatever other quantity is required positional argument. But what happens if you attempt to call this function with 3, 4, or 5 arguments? Let's have a look at another error which you'll see in this case. If there are still 2 parameters in the function and you call a function and supply 3 arguments in the function call, you'll get such nasty error. Function takes 2 positional arguments, but 3 were given. It means that in this example, you must supply exactly 2 arguments in the function call. Not 0, not 1, not 3, not 4, exactly 2, because there are exactly 2 parameters in the function. And Python is very strict in terms of verification of the quantity of positional arguments. Because those arguments are positional in Python, and order of the arguments in the function call does matter. But here we come to the question. Can a function in the Python accept any number of arguments? 10, 20, and so on. Yes, it is possible. It is possible to merge arguments into the tuple. And you could do that directly in the section where you define function parameters. And for that, you have to add a star before parameter name. And usually such parameter is called args. And in such case, you will be allowed to call some nums function with any number of arguments. And here below we call such function with 3 different arguments. And after such function call, all those positional arguments 2, 3, and 7 will be gathered into the tuple. So type of args parameter is tuple. Here we verify that. And inside of this tuple there will be 3 elements, 2, 3, and 7. And each time when you call a function, brand new tuple is created, and Python gathers all arguments into one object, into one tuple. Of course, you know that tuples are immutable in Python, and you are not allowed to modify args tuple inside of the function body, but if necessary, you could, for example, convert tuple to the list, if you need to do so. But anyways, inside of the function body, you have now access to all arguments which were passed in this function call. And you could perform different operations with those arguments. For example, you could perform iteration over all arguments and perform some action with each integer in this example. So, star and then name of the parameter, usually it is args, is used in order to merge all arguments in the function call to one variable, to one tuple. And now let's get back to positional arguments. If you specify parameters in the function like this, here is first parameter, here is second parameter, then this function expects from you exactly 2 arguments in the function call. Not 0, not 3, exactly 2. And those arguments are called positional arguments. Here we call getPosInfo function and pass to it 2 positional arguments. And the order of the positional arguments is important, because this value will be assigned to this parameter and this value will be assigned to this parameter. If you swap order of the arguments in the function call, you'll see completely different result. In this function, we create info variable and assign to it result of such expression, where we use f-strings syntax in Python, and we form a new string based on the values of the name and pos quantity parameters. And afterwards, we return info from this function. And again, if you change order of those 2 elements, you'll see, instead of Bogdan wrote 25 pos, a string 25 wrote Bogdan pos. So that's how positional arguments work. Order of the positional arguments does matter in Python. And next, let's talk about other type of arguments in the Python, which is called keyword arguments. But for now, you already know what are positional arguments, and how you could combine all arguments into one tuple inside of the function. And for that, before parameter name, you have to add a star. And usually such parameter is called args.
If you want to become data science or machine learning specialist, I welcome you to the full Python course, which covers such packages as NumPy, Pandas and scikit-learn. Now let's create a function, and we will call that function with different quantity of arguments. And function will sort numbers inside of it and print sorted elements to the output. Let's call this function sort nums, like that. And in order to be able to accept any quantity of the arguments in the function call, we have to prepend star before parameter name. And usually in such case, parameter name is args, like that. But you could choose also other name. And first, inside of the function, let's simply print to the terminal value of the parameter which is called args. And next, let's call sort nums function, and let's pass to it several elements, and they will be integers, like that. And let's see what we get. Run the code, and here I get a tuple. So that's the value of the args parameter. And this star means that function actually takes all arguments in the function call and combines them into single object, into the tuple. And now we can call this function with any quantity of the arguments. Let's add one more argument here. Run the code, and here we see one more element in this tuple. If you want, you could even call function without any arguments. That will also work. In such case, we get empty tuple. We could ensure that it is a tuple. Let's get back to such arguments by printing type of the args. Let's run the code, and here we get class tuple. And because of the fact that args contains actually a tuple, we could work with it as with any tuple. As you know, tuples are ordered, but immutable. You cannot add new elements to args. And if you attempt to do that, for example, using append method, you will definitely get an error, because append method is not available for tuple objects. Tuple object has no attribute append. But you could perform iteration over elements of the args variable. And for that you could use, for example, for in loop, or if you want, you could convert args to, let's say, list, if you want to do so. But let's use for in loop for arg in args, and let's print arg to the terminal. And let's remove this line and this line. Let's run the code, and now here I see different arguments in different print outputs, 10, 3, 15 and so on. And of course, order of those elements in this args tuple is the same as order of the arguments in this function call. Because here in this function call we use basically positional arguments. Here are positional arguments. And all positional arguments are gathered into one tuple here inside of the function. And as I already mentioned, it's possible to use any other variable for this parameter, not necessarily args. And here we could call this parameter nums, for example. Here we will also rename args to nums, and here instead of arg will be num, and let's rename arg here as well to num, like that. Let's run the code, and result is the same. So name of this parameter doesn't matter. And now if you hover mouse over sort nums function name, you'll get actually information what this function actually expects from you. And here you see that it gathers all arguments into the nums parameter. So here is star in front of it. And this function at the moment returns none. Here you see that as well. Great. Let's now remove this iteration and let's get back to args parameter name, because it's a common convention to name such parameter like that. And now let's, in this function, sort all arguments from the function call and return sorted list, not a tuple, list. And in order to perform sorting operation, it's possible to use built-in function, which is called sorted. Here it is. And this function expects from you an iterable, here you see that, and we could pass here either tuple or list or any other sequence. And let's pass to sorted function call args, like that. And let's return from this function result of the sorted function call. And now let's assign result of sortNums function call to the variable in order to be able to access this value which will be returned by the sortNums function. Let's create here a new variable sorted nums like that, and let's next print sorted nums to the terminal. Let's run the code, and here I see value of the sorted nums variable, which is a list. And in this list all elements are sorted, from smallest to biggest. That's how this built-in sorted function works. And as you see here, in sorted function call we basically passed a tuple, but it returned a list. And if you hover mouse over this function name, you'll see that this function returns a list. Alright, that's how we were able to get all arguments in the function call, gather them into single tuple, and the parameter args contains such a tuple, and then we sorted all elements in the args tuple and returned sorted list using return statement from this function. And therefore, in order to use result which is returned by the function, we assigned result of the sortNums function call to variable sortedNums. And afterwards you could perform different operations with such list, because it is a regular sequence and you could modify it if you want to do so, or add new elements and so on. So perform any operations with such list. That's where positional arguments in this function call, and using star in front of the parameter name, we are able to combine all arguments into single tuple. And now we are able to call this sortNums function multiple times, and we could duplicate those two lines of code like that, and now here let's use other numbers like this. Let's run the code, and we'll get different results. So each time when we call a function, we could use different quantity of the arguments. And here I simply reused same variable name as sortedNums. It is possible in Python to assign different values to the same variable. We did it here and we did it once again here. That's it about args in Python, and you have to remember that for that you have to add simply star in front of the parameter name, and in such case you will never get an error from the Python telling that there is missing positional argument or there are too many positional arguments and so on. But in such case you have to work with tuple inside of the function. And of course, if needed, you could convert tuple to any other sequence, for example, to a list.
We just talked about positional arguments in Python, and the order of the positional arguments in the function call does matter. And also we talked how you could combine all arguments just into one parameter. And for that you have to add star in front of the parameter name, which is normally called args. And in such case you'll get a tuple which contains all positional arguments which are passed in the function call. And now let's talk about keyword arguments in the Python. Here we have same function as before, it is called getPoseInfo, and this function has two parameters, name and pose quantity. And those names are actually names of the variables which are available inside of the function. And here we form such f-string and return it from the function. In this case, you could call such function using positional arguments, as we did before, But it's also possible to call such function using keyword arguments. And keyword argument looks like this. First comes name of the parameter, it matches with this name, then equal sign, and after equal sign comes value for specific parameter. So this is called keyword argument in Python. And here we supply another keyword argument, postQuantity. Again, name here and name here match. And after equal sign comes value for this specific parameter in the function. And in such case, we'll get such string which is returned from the function. So in this example, you could either use positional arguments or keyword arguments. And please notice that order of the keyword arguments in the function call does not matter. And you could first pass this keyword argument and next postQuantity or change order. So order of the keyword arguments doesn't matter. Same as order of the key value pairs doesn't matter in dictionaries in Python. So same rule applies here. And keyword arguments are more readable, and in each function call it is clear which parameter gets assigned specific value. So parameter name gets value Bogdan and parameter postQuantity gets value 25. When you use positional arguments, it is not clear which parameters are utilized inside of the function. So I suggest to you to use keyword arguments whenever possible. They improve readability of the code in Python programs. So I suggest to you to use keyword arguments because it makes Python code more readable. And of course, order of such keyword arguments doesn't matter. Also, it's possible to merge arguments to the dictionary. You know that it is possible to merge positional arguments into the tuple, and it is possible to merge keyword arguments into the dictionary. And that's as easy as adding two stars in front of the parameter name. So here this function getPosInfo has just single parameter, person. And you could call such function by supplying any keyword arguments, or so-called named arguments. Here we pass two keyword arguments, name Bogdan and postQuantity 25, and after such function call, there will be a dictionary inside of the function, and this dictionary will contain keys according to names of the keyword arguments which were used in the function call. So here you'll get such dictionary. Two keys and two values. And type of the person object is of course dictionary, so it is an instance of the dict class in Python. And afterwards in the function you could access any value of such dictionary. And here I used f-strings again, and in order to avoid very long f-string, I split it into multiple lines, and in Python it is possible to do in such way. Here on the right side of the assignment operator there are brackets, here is opening one and here is closing one, and here are two parts of the same f-string. Notice that here there is no comma, and it makes possible to merge results of those two expressions together. And we'll get simply such string as is shown here at the bottom of this example. So if you don't supply comma here, Python will automatically combine two different strings or three strings if you use more lines here. But main idea here is that we have access to person dictionary, and it has two keys, name and postQuantity, and we could access values of those keys. And that's how you could merge all arguments, all keyword arguments more specifically, into one dictionary in Python. And in such case, you could supply as many named arguments or keyword arguments as you want. All will be merged just into one dictionary. And for that, you have to add two stars in front of the parameter name. And in this case, we used person as a name of parameter in this getPosInfo function. That's all about keyword arguments, and I recommend to you to use keyword arguments instead of positional arguments where it is possible, because keyword arguments make code more readable and more clear, because in each function call it is clear which parameters get specific values. And of course, order of the keyword arguments doesn't matter, same as order of the key value pairs in the dictionary. This order also doesn't matter. That's all about keyword arguments in Python. Let's now explore keyword arguments in the function. And let's create a function which will print information about quantity of the comments which were posted by a specific user on specific day. And let's call this function comments.info. And it will have two parameters, and first one will be comments quantity, and second one will be day. And it will be like Monday, Tuesday or Wednesday. Let's add colon, and in the function body let's print to the terminal result of the expression, and here I'll use f string. F single quotes or double quotes, then pair of curly braces, here will be comments quantity, then where posted, on, and again pair of curly braces, and here will be day. And next let's call comments.info function with two arguments. First one will be, let's say, 50, and second one will be Monday. Let's call comments.info once again, and here will be quantity 20, and the day will be, let's say, Sunday. Let's run the code, and here in the output I see that 50, let's say, add here, comments were posted on. Let's run the code, and here I get two strings. 50 comments were posted on Monday and 20 comments were posted on Sunday. And those are results of those two function calls. Let's remove one function call and discuss what happens here. We have two parameters, comments quantity and day. And here we use two positional arguments, 50 and Monday. And that means that comments quantity parameter gets value 50 and day gets value Monday. If I change order of those two arguments here, and Monday will be first and second will be 50, I'll get opposite result. Monday comments were posted on 50. So that's not what we actually expect. But from such function call, we basically don't know what we actually do inside of the function and what are names of corresponding parameters. We simply pass two arguments in the function call. And someone who will look on this code without looking at the function will not be able to understand what function actually does and what those two values actually represent. And therefore, we are able in Python use keyword arguments. And here in front of 50 we could add comments quantity equals sign 50, like that. And here we could add day equals sign Monday. Let's run the code, and result is the same as before, 50 comments were posted on Monday. But now from this function call it's clear to everybody that function actually expects from us comments quantity and day. And it is relatively easy to understand what function actually does from parameter names. And here we just used keyword arguments. And there are two of them, comments quantity and day. And now we are able to change order of the arguments here in this function call. Because with keyword arguments, order of the arguments doesn't matter. Let's check result, and result is same as before. Because now we actually add here names of the parameters, and for Python it's very easy to understand which value is for which parameter. But definitely names here and here must match, and names here and here must match. These are keyword arguments in the function call. And we just saw that we are able to use either positional arguments
or keyword arguments. But now question, is it possible to mix positional arguments and keyword arguments? Let's try that. Let's pass here 50 as positional argument and leave here day Monday as keyword argument. And let's run the code. And I see no error, and result is as expected. This means that you are able to mix positional arguments and keyword arguments if you have, for example, such function definition, which has two different parameters. But what if I try to change order of the arguments here, like that? Day Monday and next will be 50. Let's run the code, and now I get syntax error. Positional argument follows keyword argument. It means that you are not allowed to place positional arguments after keyword arguments, like we did here. It is not allowed in Python, because in such case, Python doesn't understand for which parameter you supply this argument. For first one or for second one, it is not clear. That's why if you want to mix positional and keyword arguments, you have to put positional arguments first, and then keyword arguments if you want to do so. And in your Python developer life, you might see that different built-in functions or functions from external modules will be called using mix of positional and keyword arguments. And you might see scenarios when specific function is called using several positional arguments, for example, like that, and next comes one or several keyword arguments. This is very common in Python. And keyword arguments always come at the end in the function call. Please keep that in mind. And now let's try one more thing. Let's, instead of two parameters here in the function declaration, use star args, like that. And here, instead of comments quantity, we will put args square brackets 0, and here will be args square brackets 1. We already discussed what is star, and you know that in such case, Python gathers all arguments into single tuple. And here we simply access specific element from the tuple, first one here and second one here. And let's call this function with such two arguments, which are obviously positional arguments, 50 and Monday. Let's run the code, and here I get same result as before. 50 comments were posted on Monday. But let's try to use keyword argument now. As we did before, day equals sign Monday. And obviously I get here an error. Type error comments info got an unexpected keyword argument, which is called day. This means that if your function has just single parameter with star in front of it, you are not allowed to use any keyword arguments. Because in such case, Python doesn't know how to gather such values of the parameters in this tuple. Because tuple has only elements without any keys, it is not a dictionary. That's why, if you have such function, you are not allowed to use keyword arguments. It is prohibited. Alright, that was last example dedicated to keyword arguments, and let's get back to previous case when we actually have two different parameters with names, comments quantity and day. And in such case, you could either mix positional and keyword arguments or use just all keyword arguments, like that. Let's run the code, and in the output we see such a string. That's where keyword arguments on practice. We already explored how to use keyword arguments in the function call, and now let's explore how to merge all keyword arguments in the function call into the dictionary inside of the function. And let's create a function which will be called, for example, product price info, and this function will have two parameters: product title, let's say, and product price. And here inside of the function, let's print to the terminal following expression f single quotes. Here will be product title, next will be costs, and here will be again curly braces, product price, and here will be, let's say, dollars. And let's call this function product price info, and here will be, let's say, string bottle of water, and price will be, let's say, 2. And if we run the code, we will see such output: bottle of water costs $2. And here we used positional arguments here and here, and also we have here two parameters. Let's change those positional arguments to keyword arguments. Here will be product title equals sign bottle of water, and here will be product price equals sign 2, like that. Let's run the code, same result. Bottle of water costs $2. Now let's merge all keyword arguments, this one and this one, into single dictionary inside of the function product price info. And instead of product title and product price, here will be just single parameter, and let's call it product. And in front of it, let's add 2 stars, and that will be an indicator that we want to merge all keyword arguments into the single dictionary, which is called product. And now here, instead of product title and product price, we have to access values of specific key in the product dictionary. But first, let's comment out this line, and let's print product, like that. Let's run the code, and here we see a dictionary which consists of 2 key value pairs. Here is first one, and here is second one. And basically now we are able to call this function with any number of the keyword arguments. We could add here one more keyword argument, for example, let's say product availability, and its value will be true. If I run the code now, I'll see dictionary which has now 3 key value pairs. Let's remove last one, like that. And now we are able to access keys of this product dictionary, and let's do that here in this f string. Let's uncomment this line, and now let's access values of the corresponding keys which are named product title and product price in this dictionary. Let me copy this name of the key, because here we have such key name, and now here will be product, square brackets, and in double quotes let's put name of the key, which is product title. And now here, as you might notice, I got an error. And I got this error because here I used single quote, and here in the f string I also used single quote. And in order to get rid of this error, I have to replace single quote for f string, for example, to double quote. And now error is gone. In similar way, I should use here, instead of product price, product, square brackets, and in double quotes, product price. We access values of corresponding keys in the product dictionary. Let's run the code, and I get same result as before. And now we work with dictionary inside of the function, and we gather all keyword arguments into single dictionary. If you want, you could create separate variables inside of the function, and let's name them product title, and its value will be result of this expression. Let me cut it from here and paste here. And similarly, let's create product price variable, and its value will be result of this expression. Let me cut it from here and paste here, and now here we could use such variables as product title and product price, or simply here could be title and price to make f string shorter. Title, and here will be price. Like that. Let's run the code, and result is as expected. Great. Here are keyword arguments, and they are gathered into single dictionary. And here we access values of corresponding keys inside of the product dictionary. But what if in the function call we use not keyword argument, but positional argument, for example here. First comes positional argument, and next comes keyword argument. Let's see what we get, and we get type error. Product price info function takes 0 positional arguments, but 1 was given. It means that with such syntax in place, it is not allowed to use positional arguments in the function call. Because this particular function doesn't know how to use positional arguments and to which parameters assign such value as bottle of water. Now function expects only keyword arguments. And if you hover mouse over it, you might see that 2 stars product. This proves that you could call this function using only keyword arguments, like we did before. Product title, keyword argument, and then value for this argument. Product price, then value for product price. That's how it works when you use 2 stars in front of the parameter name in the function. To summarize, using 2 stars, it's very easy to merge all keyword arguments into single dictionary in the function, and now function basically could expect from you any quantity of the keyword arguments. And it is not limited to specific names of the keyword arguments. You could use here other name, for example, product, let's say, new title, and function will be called without any problems. But now, of course, result will be different, and here we will get key error product title, because now we try to access such key in the dictionary which is called product, but such key is now absent in this dictionary. And if you are not sure whether a specific key is present in the dictionary or not, you could always use get method instead of square brackets notation. And we discussed that before. But if we are sure that specific keyword arguments are supplied in the function call, then we could use square brackets notation like we did here. But notice that now when we hover mouse over function name, we don't see actually which keyword arguments are expected from the user. We simply see that all keyword arguments are gathered into single dictionary, which is called product. We don't see here product title or, let's say, product price, which are expected by the user, which are used inside of the function. That's why there are 2 options in this scenario. Either use function description and describe all parameters of the function in order to make such description available when user uses function when it tries to call it, or use separate parameters, like we did before, product title, for example, and product price, without those 2 stars. But if you want to accept any keyword arguments, you could always use gathering of them into single dictionary, like we did in this example. If you want to learn how to create games in Python, I welcome you to the full course, where you'll create several games using Pygame package.